Hi everybody, Chris here, and a big welcome to Excel VBA for beginners. Now, Excel VBA, there's no doubt it's a technical thing, and over the course of the next 4 or 5 hours, we're going to learn awesome technical skills. There's no doubt about that. But Excel VBA, I've got to say, probably changed my career. It's such a powerful thing. It allowed me to have impact, to have a YouTube channel, to have a small company. So we're not just coming at this from a technical perspective. Excel VBA for me is career changing, and it's my aim over the next few hours to help you realize the potential of Excel VBA and really think how it could help you in your career. So with that said, let's get into the first slide. Reasons to learn Excel VBA. I invite you to grab a pen and a piece of paper and write this down. It's going to help motivate you through this series. So reasons to learn Excel VBA. What's yours? The first thing is it saves people and organizations time and money. Yes, for the past 15 years, I've been working for a small company, Tiger Spreadsheet Solutions, and the primary focus of our activity is helping people and organizations save money with Excel VBA. So what scale are we talking about here? Are we talking about saving a few minutes? Are we talking about saving a few dollars here and there? Well, let me tell you a quick story, which is we have a customer over in Florida. They spent around $50,000 with us over a couple of years, and we developed a VBA application. We're going to learn how to do that over the next few hours. They then took the application, took it to a software company and said, could you recreate this as a piece of software? And they were quoted by the software company. So initial cost, $50,000. Can you guess how much the software company quoted them? They quoted them $1 million. So it just gives us a sense about the power of VBA and all of the techniques, the constructs in that VBA application we're pretty much going to cover in this series. So it saves people and organizations time and money, could save your organization time and money. That could have an epic impact in your career. Reason 2, it's a great way to start computer coding. Yes, there's so many programming languages out there, so much good stuff. There's AI options these days. So why should you spend your time with Excel VBA? Well, simply put, it's a great way to learn all of the others. Within a few minutes, we're going to open up Excel in this demonstration. We're going to open up the VBA Editor, and you're going to start seeing what computer code looks like. And I say computer code, not VBA specifically, for a reason. That's because all of the concepts in computer coding, things like conditional statements, things like loops, things like variables that we're going to cover, all of those concepts are common to all computer programming languages. So whatever you might end up working with, VBA is going to be a great start for you. But there's more than that. There's something specific about Excel VBA, which it works out of Office and specifically out of the spreadsheet, out of Excel. Why does that help us? It helps us visualize. It helps us see what the code is doing. As we're going to do many times in this series, we're going to see the coding window on one side, Excel on the other side, so we can understand what the computer code is doing. A lot of computer programming languages, they're a bit abstract, so we can see very, very clearly what the code is doing. That's a great learning benefit. That's why Excel VBA is a great way to start computer coding. And thirdly, it builds your Excel skills. Yes, we've already mentioned we're working in Office, and specifically in Excel VBA interacts with the other Office programs as well, things like PowerPoint and Word. But we're specifically in Excel, and Excel I call one of the languages of organizational life. Yes, it's one of the common currencies, isn't it, of organizational life. How many Excel files get attached to emails every day? How many get shared via SharePoint every day? You really have to be good at Excel to be able to accelerate your career if there's any kind of analytical aspect to your job. This is why I love Excel VBA. We're going to be building the very practical skills in Excel, and finally, it could transform your career. Yes, I had something of a career crisis. Around 15 years ago, I was actually working out in Japan. I was working for a PR company and I was made redundant. This was around the time of the financial crisis. Wasn't quite sure what to do with my career. I elected to do a master's in business analytics, University of Warwick here in the UK, where I've subsequently taught for several years. And yes, it was transformational. It was a bit of a master's in spreadsheets, but it definitely transformed things for me. Once I told people I could do spreadsheets, that led very organically to projects. That led to the YouTube channel, me doing things like this, and that led to my company. So it's no exaggeration to say it could transform your career. So with that said, a little bit more about me. I'm the founder of Tiger Spreadsheet Solutions, a company here in the UK. We also have the Tiger Spreadsheet Solutions YouTube channel. You can find on YouTube, approaching 100,000 subscribers there. So real world consulting. Yes, this is the main thing I do. I love creating content like this on YouTube, but most of the time I'm working with real world customers, small and large, across the world, with the aim of saving them time and money, doing what we call data automation. So automating processes where they're moving data around, those really annoying day-to-day things you have to do every day. You think there must be a better way. Yes, that's the kind of thing we do. YouTube approaching 10 million views, 100,000 subscribers. As I've already mentioned, I undertook my master's at Warwick Business School here in the UK. I was subsequently asked to teach at Warwick Business School. I've taught tens of thousands of students on various business topics, including Excel VBA at BSc, MSc and MBA level. What should you ask me about? Well, you can ask me about Luna the dog. She's a bit of a star on our YouTube channel. Drumming, High Rocks, Nottingham Forest FC, and the Japan days that I've already mentioned briefly. But drumming, let me just say something about drumming. What skill do you learn, right? You must have some kind of hobby. Maybe it is going to the gym. Maybe it's drumming. Maybe it's even gaming. Excel is a skill. Excel VBA specifically is a skill. So you're going to have to call on that ability to learn a skill. Yes, you've learned something. I know you can ride a bike. So all of those things you had to bring to the table when learning those skills. For me, it was drumming. You're going to have to call on those when we're learning Excel VBA. We're going to talk more about that in the course of the next hour. So the structure for this series is as follows. This video is our Excel VBA quick start. So hopefully we've established some motivation for learning Excel VBA. It's a quick start. Yes, we're jumping in at the deep end. Next, I'm going to demonstrate some Excel VBA to you. And before the end of this video, you will have written your first macro. You'll be getting involved with some pretty powerful Excel VBA code. That's coming up very shortly. The second video, we're going to be working with ranges and variables. You know, what's a variable? We're going to dig into that. It's not as complicated as it sounds, and it's an essential of Excel VBA and programming more generally. I love loops. Loops are the key to quick automation because a loop allows us to repeat an action any number of times in VBA and computer programming more generally. And then position control and offset, something that's kind of idiosyncratic to Excel VBA, because position control is where are we in the spreadsheet? Yes, this is a benefit of Excel VBA. We have an almost physical thing, although there is a spreadsheet physical. Let's not get into that conversation now. But we have a thing that we're working with, a grid. So your ability to control which cell we're working on that grid, that is an absolute key component of the impact your VBA skills will have. And finally, video 5, we're going to be talking about conditional statements. We want to send the code in one of two or more directions according to what's happening in the spreadsheet. Conditional statements we will be covering in video 5. So I hope that's some motivation for you. I hope you feel we've plotted a bit of a course through this very complex but incredibly exciting topic. I'll see you in the next section for a practical demonstration. So personally, when I'm learning something new, I like to bear the how, what, why concept in mind. So let's apply this to Excel VBA, starting with the why. Well, hopefully we've covered a bit of the why Excel VBA is important. So let's deal with the how and the what. So the what is Excel VBA? A quick definition: Excel VBA stands for Visual Basic for Applications. It's the programming language that sits in the Office suite, so sits in Excel, sits in Word, sits in PowerPoint, and in other programs, apps in the Office suite, and allows you to automate actions and automate processes. This is the most clear and concise definition I can give you of VBA. So just quickly, what would automating an action be? Well, you might want to change the value in a cell. You might want to reformat a cell. You might want to sort some data. So all of those single actions can be automated, but it really gets exciting when you start building chains of commands, when you start connecting those actions together step by step to do something altogether more exciting. And we're going to jump in with a demonstration in just a second. But before we do, 3 things I want you to bear in mind, because we're going to jump in at the deep end, and I want to give you reason not to feel discouraged. I talk about the 3 Excel meta skills. So let me say, we have a small company and we have to, hire people to fulfill on projects and stuff. What kind of person is the best programmer? So if you would give me one programmer and you would say, yeah, this person has solid technical skills, but we're not sure about this person's attitude, they're largely untested. And then you were to give me candidate B, and this person didn't have very strong technical skills, maybe had limited experience in VBA, but really understood the meta skills and could demonstrate experience applying the meta skills. I would definitely go for candidate B. That's because the meta skills are so important, and that's why we mentioned them in the previous section. You've already learned stuff in your life. When you were learning the other stuff, whatever we're talking about, you were applying these meta skills. So the first skill is, just quickly, conceptualization. I also say translation sometimes, but this is, can you look at what you're trying to do in Excel, whatever process you're trying to automate, and can you translate that into the VBA you need? So we're going to build a toolkit of VBA tools and techniques, but they don't mean anything if you can't pair them with situations where you would apply each one. I call this process translation. In a previous job, I was a translator from Japanese to English. Can you believe that? But this is entirely a conceptual thing. So one of the most important skills when we're talking about Excel VBA isn't technical at all. Conceptualization and translation. Second skill, experimentation. Can you play? Can you use trial and error? I implore you to download the download files that we provide with these resources and play. So if I change that line of code, what happens? If I change this line of code, what happens? Okay. Then what happens if I do this? If you can get yourself in that nice reinforcing loop where you try something and it works and you get that little positivity hit, that is where you're going to make big gains with Excel VBA. That is all about experimentation. And finally, debugging. Yes, things are going to go wrong. Things go wrong every day in my real world Excel VBA programming work. So how well can you handle the psychological setback of an error and eventually see it as a chance to learn and improve? That might sound a little bit patronizing. It's not meant to, but if you can eventually learn when we get an error to think, right, I can learn something about this. I can learn about the type of error. I can learn how to avoid it. That is really going to help. So debugging, our third Excel meta skill. I'm going to go ahead, jump into the download file, and this is all it is, guys. Excel VBA. Where does this code live? Well, we're going to make sure we can see the developer tab. We're going to deal with that shortly in this video. If you get the developer tab visible and select it, you can then click Visual Basic here. It's the Alt and F11 shortcut on the Windows PC. And this is where Visual Basic VBA code lives in Excel. It lives in the Visual Basic Editor, which is attached to an Excel file as long as you save to .xlsm. All of these technical points we're going to cover later in the video. So if you're in the Visual Basic Editor, this is what it looks like. We've got our modules listed down here. We'll talk more about the Visual Basic Editor later, but this is a macro. This is a piece of VBA that's going to do something useful. So the purpose at this point isn't to understand it. The purpose is to appreciate the impact. So what do you think this VBA code does? Well, as with all computer programming languages, most as far as I know, it's in English and well-written code. You'll be able to understand what it does just from having a basic understanding of English. Create worksheets is the name of this routine. So yes, what does this routine do? It creates worksheets. So I've clicked in the routine. I'm going to go ahead and hit play, and I'd just like you to keep an eye on the spreadsheet and what changes in the spreadsheet. I'm going to go ahead, click play, and we just had a little flash there. And what can we see? We've seen worksheets created in the spreadsheet. We have 5 worksheets. Why do we have 5? Why don't we have 50 or 15? Why do we have 5? And then helpfully, the VBA routine has told us when this sheet was created. Interesting. So the only purpose of this is to understand what's going on, and then Excel VBA Metaskill incoming to do some experimentation. So what if I say from 2 to 2 here? How many worksheets are going to be created? Make a little hypothesis. Well, maybe it's 1, maybe it's 2, maybe it's 0. It doesn't matter. It doesn't have to be super clear, but I can see I've created 2 worksheets here. Okay, what if I set this number to 10? What's going to happen? Are we going to see 10 worksheets? And I can skip through the worksheets in the file, and I can see we've created 10 worksheets there. Could I change the message that's being written here? This says sheet created, and now maybe even without any specialist knowledge of VBA, maybe that controls what's going on in the spreadsheet here where it reads sheet created. Could I just make a minor adjustment here? Could I experiment and appreciate what's going on? So what if we said worksheet there? Is that going to change? That didn't change, did it? Okay. There we go. It changed second time. The second time I ran the routine, it now says worksheet created here. So what do we got? We've got a routine that can create any number of worksheets at the click of a button. How cool is that? How many worksheets have you created in Excel in the course of your career? And how many repetitive tasks are you engaged with that involve the creation of worksheets? As you can see, we can do it at the click of a button with Excel VBA. In the next section, we're going to talk more about real-world projects, but I'm just hoping you can begin to appreciate the possibilities here, just how powerful Excel VBA is, those worksheets created at the click of a button. But it's also about getting into the VBA editor, seeing it's not that scary, and just beginning to apply those meta skills, conceptualization. We've got a loop in that code. So an example of how to apply a loop is to create multiple worksheets. We've got a VBA technique and we've got a concept, being able to apply those together. We've just been doing some experimentation, and we're going to go ahead to complete this. We're going to go ahead and do some debugging. So what if we have a syntax error in our code? We're going to go ahead, click play, and we have a VBA error. We want to get this out of the way early. We're going to see many VBA errors. Have I thrown my computer out the window? No. Many times in my career, I felt like doing that. But yes, that immediate response to the debug error, appreciating it as part of the learning process, as I said, appreciating it as an opportunity to learn, that's going to, if you can do that, that's a meta skill, and that's going to really help you. So quick demonstration. Discussion of the meta skills. Hopefully you're beginning to appreciate the possibilities. In the next section, we're going to talk more about the pros and cons of Excel VBA, some example projects, hopefully get you thinking about how you could use VBA in your career. So hopefully you can feel we're working on 2 tracks here. Firstly, we're getting into VBA, getting into the Visual Basic Editor, more of that coming in the next section. But on the other track, we're looking at what might actually be possible. What might be possible for you next week, next month, next year, 5 years time in terms of what you're doing with Excel VBA. So in this section, we're going to go through some practical stuff, the pros and cons of Excel VBA. I'm going to walk you through 3 example projects to help you appreciate the possibilities, what we can do with Excel VBA. But then finally, you're going to write down your dream Excel VBA project. Yes, it's not just about us learning some code, that's great, but it's about having impact in the real world. So that's what we're going to do in the next 10 minutes or so. But VBA, like any programming language, isn't perfect. There are pros and cons. You know, I think computer programming is a bit like owning a sports car. Now, I certainly don't own a sports car. My car is a 10-year-old Golf. But if you did own a sports car, you could move very fast, but you might occasionally have a little crash. And that's what computer programming languages are like. We can get incredibly powerful impacts in terms of automation, all the good stuff we've been talking about, but there are some risks. So what are the risks specific to Excel VBA? So the pros first, availability and access. Yes, Excel is one of the common currencies, as we know, of organizational life. So it's very likely your colleagues or your customers, if you're consulting with someone, are going to be using Excel. So Excel's available. The people you want to help are likely to be using it, and access. Availability and access. VBA is accessible. There's no additional cost beyond what you're paying, whatever your Office subscription is. There's no additional cost. So a pro is definitely, it's available, it's accessible. Secondly, here, it's part of Office, the Microsoft Office suite, and it applies to the apps you're using daily. This is a great thing to remember with Excel VBA. Yes, a lot of people learn VBA in Excel, but you can interact between apps. We've done projects where we create charts in Excel, put them into PowerPoint, creating, a 20-slide PowerPoint presentation instantly with analysis from Excel. So this is a great pro of Excel VBA. It's easy to learn. As we've already mentioned, the VBA Editor can sit alongside the spreadsheet, as we saw in the previous section. That means there's a concreteness to it, if that's the right word. We can actually see what the code is doing, as we're going to see before the end of this video. You can step through the code step by step, an important debugging skill, and see what's happening step by step in the Excel spreadsheet. Incredibly useful for the learner. Finally, unrivaled power. Anything you can conceptualize, you can code with Excel VBA. Yes, an incredibly powerful coding language. It's probably fair to say they wouldn't invent VBA today. VBA is a well-established, bit of a euphemism. It's a bit of an old coding language, 40 years old? Maybe more now. They wouldn't create something so powerful now because of the potential for, how would you say, for people doing bad things to your system. The power is unrivaled. We've seen we can create sheets, but we can do so much more than that. We can create files. We can also delete files. Yes, with a VBA routine, you could delete all the files off somebody's system. So huge power, but moving on to the cons, also needing close control. We're going to see in the next section, when we actually open up Excel and get it set up for VBA, there's a few steps for us to work through to make sure we can get VBA working. Microsoft has introduced those to make VBA better controlled, to make it secure. So when you've got that enable macros notification, that's so the user is sure that they want to allow VBA to work and that they trust whoever has sent them this file. So lots of power, needing control. And just quickly, if you compare to a more modern coding language like OfficeScript now available in Microsoft Office, and it works online, OfficeScript. Just quickly, OfficeScript, what's the scope of OfficeScript? It's only the workbook you're in. So VBA, we can go and find another workbook. We can go and delete another file potentially. With a more modern programming language, OfficeScript, it can't do anything outside of the file it's in. So it just gives you a sense of where VBA lies in terms of, the history, if you like, of computer programming language and what the pros and cons are. Let's move into the cons. So not usually available in the cloud. What does this mean? If you're working on SharePoint, and lots of organizations are these days, VBA isn't immediately available in SharePoint. If you open Excel in the web browser, VBA is not going to be available. To be able to access Excel, you have to open it in the desktop app. So not immediately available in the cloud applications, as I just mentioned. Something like OfficeScript is available in the cloud applications. As I said, control issues, its power can be a double-edged sword. And this is why you'll often find IT departments being a bit suspicious of Excel VBA because of that lack of control. I have fought that battle hundreds of times over the years, explaining the pros of Excel VBA, the unique power we've already discussed, Yes, you will come up, you may well meet some organizational resistance, which is well-meaning, but we can control VBA to ensure everything's going to be okay, and we can still harness its unique power. A traditional coding environment lacking graphical support. We've been in the VBA editor already compared to more modern programming languages and facilities. I'm thinking of things like Power Automate, for example. There's not much in terms of graphical support. Now, I'm very used to working in the Visual Basic Editor. I've got used to Excel's quirks and Excel VBA's quirks over the years. I think overall it's pretty good, the VBA coding environment. It's very flexible, easy to work with, as we're going to see, but it does lack some of the, how would you say, premium features perhaps that you might find in some of the more modern coding environments. Does have a bad reputation in some quarters, Excel VBA, as I mentioned, because of that lack of control. But I would say, as a parting comment, I've been working in the world of VBA for 15 years. I am yet to see VBA being used for this kind of nefarious application. You know, we live in an age where people are trying to do this with computer coding, with all kinds of, how would you say, phishing devices and stuff. I've never seen someone try to use VBA to do that. So as with any reputation, you know, you want to be asking the questions, is this fully deserved? Anyway, you've got the pros and cons there, and it's up to you to decide how it fits into your career. Okay, let's move on to 3 example projects. So for me, it's my mission to get you to appreciate what the potential of Excel VBA is. We've spoken about the power. So give me an example of the power. This is from a real world project that we have been working on the past few years. Each morning, the manager of a commodities trading brokerage wishes to send indicative prices to prospective customers. Excel VBA is used to get live base prices from online data sources, along with live exchange rates. These are inputted to a model in the spreadsheet, which adds haulage price and user configurable margin. The final price is formatted as a quote and emailed to around 200 prospective customers at the click of a button. Yes, this is an Excel VBA application. This is maybe a couple of 100 lines of code. We've seen a VBA routine with 20 lines of code. So it does take a bit more in terms of coding. Interesting features here. We've got Excel VBA sending an email at the end. Yes, that's something we can do. We can tap into Outlook and send an email. This is an interesting project because it has awesome real-world impact. Our customer uses this every morning. 200 prospective customers receive a quotation. Quotations mean a potential conversation about a sale. That's what I am all about as a consultant, real-world impact of Excel VBA. Example project 2, a manager based in the US wishes to create a RAMS, risk assessment method statement, for a new project. Excel VBA is used to select the methods for the project, which are kept up to date in a spreadsheet along with associated risks. Risk level is calculated via a simple numerical model in the spreadsheet. The methods, risks, and risks levels are listed, formatted, and output to a PDF at the click of a button. Yes, all this magic is happening at the click of a button. This is an interesting project because we've got 2 or 3 what we'd call data sets sitting in Excel with these risks listed and with these methods listed. And the user is able to select the kind of project that they want to create their RAMs for, click a button, then in the background, Excel is going to go into these different data sets, assemble the data, lay it all out and put it into a PDF. It takes just a few seconds. If you've ever had to do a RAMs risk assessment, these things can take time, can be somewhat onerous. Imagine being able to do that at the click of a button, maybe not at the end of this video or even at the end of this month, perhaps at the end of this year. Your VBA skills could be good enough to do this. Finally, example project 3. A sports trader trading football matches wishes to backtest systems based on football data. The data comprises the odds available 3 and 5 minutes before the kickoff time across various markets, such as home win, a number of goals scored. Each Excel VBA tests thousands of theoretical trading strategies based on different combinations of odds, brackets, and markets. The output, candidate bets with analysis of theoretical performance over time, is viewable at the click of a button. Yes, we can say it all together now, can't we? This all happens at the click of a button. I like this application because VBA, it's not just all about work. Yeah, and I'm a big sports fan. Football here in the UK is incredibly popular, and I love this project. We've been working with this customer for nearly 10 years now. And I love this project because it's about something that I enjoy, something that I'm interested in, something that I can understand easily, this football data. So your Excel VBA dream project doesn't have to be about work. It could be related to your hobby if data plays a part in your hobby. Having said that, this is very much a professional football trader that we're working for here. So I invite you to write it down. I'm never too far from my pen and paper. I always like our clients to see me writing stuff down on pen and paper. I think that's an exciting, a powerful thing. But what would your dream project be? You've learned a bit about the pros and cons of Excel VBA, the power and the need to control it. You've seen my example projects, real world projects, all of these projects we're working on still. Your dream project: process is automated, errors reduced, time and money saved. What could it be? Write it down. I'll see you in the next section where we're going to be jumping into Excel VBA. This section is Excel VBA Quick Start. So as the name suggests, we are getting started with Excel VBA. First, what are the practical things we have to consider when getting set up for Excel VBA? So have you ever received a file containing VBA via email, and have you noticed it can be a bit frustrating to get everything going? So firstly, let's work through that and let's make sure our system, your system, is set up for Excel VBA. So I'm in the Windows File Explorer here, and I have downloaded a file from an email that I know contains Excel VBA. How might you be able to guess? You can guess from the file type, Excel macro enabled worksheet. That file might well contain Excel VBA. We'll talk more about the importance of the file type in just a second. So what happens when I open this file? I get this security notice telling me really to disable macros. So I have to go into Excel and I can disable macros here. So if I go into the Developer tab and Visual Basic, I can see the code here, but I'm not going to be able to run the code because macros for this project are disabled. So how can we fix this so we can actually run Excel VBA? To do that, you've got to go back to the file location. So it would be sensible at this point, of course, to take it out of your downloads folder and to save it somewhere on your system. You have to right click on the file, show more options. On my system, we want to get to properties. You can see right at the bottom here. And then the key really is in the general tab, unblock. You hit unblock at the bottom. You can hit apply and OK. Now, when we open the file, what we should find is we have the option to enable macros. We can see the file is open now. I can view the Developer tab, go to Visual Basic. I can now hit F5 on the Windows PC. You can also hit play, and you might have noticed that flashing. So this macro is now working. So that's how to get macros working. It's something to bear in mind if you're working with a customer, someone within your organization, someone external. If you're working as a consultant, you've got to provide this guidance because people can become discouraged quickly if they can't get your VBA application working quickly. With that said, what else do we have to bear in mind to get set up for Excel VBA? Well, being able to view the Developer tab is really helpful, and the file save format is something else to bear in mind. So if we go to options here, I'm going to go to customize ribbon and just make sure you have the developer box ticked here. Now the default setup here is usually you can view developer, but you can't actually see it. It's not ticked rather. So you can just go ahead, tick it. You might have to reopen Excel, but you should then be able to see the Developer tab. The Developer tab is right here. That means we can access Visual Basic. We can record a macro, as we're going to see in a second, and we can insert a button here. All of these things we're going to do many times during this series. Also bear in mind the keyboard shortcut. So view the VBA Editor, Alt F11 on the Windows PC allows me to bring the VBA Editor straight into shot there. And while we're here, how do we get this nice setup? where we're able to view both screens, or both windows rather, side by side using the Windows key. On the Windows PC, if I hold down the Windows key and then hit the arrow keys left, right, up and down, it does different things with this window. This is, of course, the layout that we're looking for. And you can see I've got multiple screens available. It is useful, if possible, for you to have multiple screens available. That means you can put the VBA editor on one screen, Excel on another screen. That's going to improve your efficiency. Having said that, I've got a 13-inch laptop down here. That's my travel laptop. I've done a lot of my VBA coding on a 13-inch screen. So being able to view these windows side by side, if you can do that, that's going to help regardless of your screen size. Other things to bear in mind in options, the default file save format. So what does this mean? Well, let's go back to our download file. If I were to try to save this as an Excel workbook, you can see we've got different options here. We've got macro enabled workbook. That's what we're interested in, of course. If we're using VBA, we want the workbook to be enabled for macros, a macro being a chunk of VBA code that does something useful. If we try to save it as Excel workbook, what's going to happen? We're going to get this notification, which is if you try to save a workbook containing VBA, this workbook does contain VBA as a normal Excel workbook, you're going to lose the VBA. Yes, and this has happened to me. I have lost big chunks of VBA in the past this way. So we can say go back. Now, what I'd recommend you do, certainly while you're learning, while you get used to this, is of course good version control, backing up files as you go. I'm constantly hitting the F12 key on the Windows PC when I'm doing development to allow me to save files as I go. And then this option is worth bearing in mind. So save, and then your default file save format. You can see I have this save set to Excel workbook. You can set this to Excel macro enabled workbook. And that means by default, when I go ahead and hit the F12 key, I can see Excel macro enabled workbook is the default option here. So just some practical things there to help you get started, to help you get your system set up for Excel VBA. So we've spoken a bit about the VBA editor. We have seen the VBA editor in action, but what are the main areas of interest here? Well, I'll recommend you go ahead, do a little bit of sizing here, and just note three main areas. That's all we need to know to begin with. Firstly, we have the Project Explorer at the top. All of the objects that are active, if you like, at the moment. We're going to talk about more about what an object is later. You can see here. So in English, Chris, speak English. These are all of the files that are open. I can see I've got a file open called Series Outline, and this is the file that we just opened. So things to bear in mind here. Make sure you're working in the right file. Yes, I can see I've got a module here. I want to be very aware what file this module is in, and I can see it's in my video 1 demo file. I want to make sure I don't accidentally use this. So I'd actually recommend, if you're only working with one file, and most of the time you are with Excel VBA, go ahead and close other files. That means the Project Explorer window is going to be uncluttered, and you're less likely to make the error of, accidentally deleting a file. Right, deleting VBA rather. And then what else can we see in the Project Explorer? We can see the sheets in the file, and we can see the workbook too. The workbook itself being treated as an object. Not hugely important at the moment. If you get into advanced VBA, there's routines that live in these objects in this area and this area here. That's why we can see them here. So this is the Project Explorer. And as usual, you can expand and collapse these according to whether you want to see them or not. Code lives in modules. It's best placed in modules anyway. And you can see we've created a module and our code is here. We can rename these modules as we're going to see later. Okay, so the top left is the Project Explorer. Now the bottom left is the properties window. So what's a property? A property is something about the object that we might want to change. We might want to manipulate. And have you ever wondered how you get a spreadsheet to be very hidden in a file? Very hidden. Very hidden means even in the Excel file, if you right click on the sheet tabs, you can't see the sheet to be able to unhide it, potentially. So it's down here. You can click on the worksheet, access it through the VBA Editor in the Project Explorer. You can see them here. You can set the sheet to very hidden. I have to do that again. Okay, it doesn't want to do that. Is that because it's the only sheet in the file? Okay, so sheet 1 is very hidden. So I can go back to the worksheet here, and if I right click, I don't have the option to unhide anything because it's very hidden, and very hidden means you don't have the option to unhide it in the spreadsheet. So that could be interesting if you really needed to hide a worksheet, didn't want people to be able to easily unhide it. So this is the properties window. There's other properties we're going to work with as we go through this series. And then this really is where the main action happens. This is the coding window. We're going to talk about the option explicit ritual later. This is where the code lives. And, for the avoidance of doubt, this is a macro. This is the macro. So sub means the macro starts here. This is the name of the macro. We always try to give macros and variables informative names that describe what they actually do, as opposed to macro 1 or variable 1. And then this here is the command that's the end of this macro. So we've got the start of the macro here, the end of the macro here. Now we could have any number of macros in a module. I can go ahead and create another macro here, and we'd see macros stacking up in a module. The idea would be to organize related macros in the same module. Yes, we can go ahead, insert module. We can see we've now got 2 modules here. So macros doing a similar job. We could have macros that are referring to each other, whatever it might be. We have options using multiple modules to group those macros together. Right, so that's our introduction to the VBA Editor. We've covered some practical considerations to get your system started. For Excel VBA, next, we're going to explore the macro recorder. So we've looked at the macro recorder. This section is about writing organic code. Yes, we're becoming computer programmers. We're going to actually write some code from scratch. We're going to open the VBA Editor, practice that alignment. With Excel, we're going to create and name a module. We're going to go through option explicit, creating a macro. What we're going to look to do is display a message box all in the next 5 minutes or so. With that said, I'm going to get back into our download file. Now, it would be possible to put a macro here. We've already mentioned we can stack multiple macros up in the same file. But for this demonstration, we want to create and indeed name a new module. So I'm going to go to insert at the top and module. You can see how I've organized the Project Explorer. The only file that has its contents viewable is this macro recorder demo file that I'm using for this demonstration. You could even go ahead and close any other files. That's probably the best thing to do. So name the module. We're going to say organic code demo. You can call it whatever you want, but an informative name is always the best way. The name of the module should describe the function of the macros within the module. Then we have option explicit. Now we're not going to talk at the moment about exactly what option explicit means, but briefly it means we're going to get into fewer problems with spellings of variable names. Yes, we're going to come back to option explicit later, but it's our ritual when we start a new module. We always put option explicit at the top. We're going to go ahead and create a new macro. We're going to say display message box here, because that's exactly what our macro is going to do. And once again, just like the name of the module and indeed of variables coming later, the name of the macro should be informative. It's really simple what we're going to go ahead and do. This perhaps is your first line of organically coded syntax. We can just go ahead and type MSG box, and then with the speech marks, you can put some text in there. Whatever you want to display in your message box, that's what we're going to put in. And this is probably your first bit of organically coded VBA, and this is a macro. We know the features of a macro: sub, macro name, and then end sub, and then the commands that we want to follow in the middle here. So I'm going to click in the routine. I can see the cursor flashing in the routine. We're going to go ahead and click play, and we can see our message box flashing up there. Do we stop there? No, we don't. You should go ahead, do some experimentation here. Maybe not particularly exciting for this message box, but it's all going to help. It's all going to help building that skill, building that confidence. And yes, this is the message box, and this is our first piece of organic code. Next, we're going to try something a little more ambitious. So you've now created a VBA macro organically in the VBA editor. Can we do a bit more before the end of this video? Yes, in part 2 of the practical demonstration, we're going to write a value to the spreadsheet. At the moment, we're just displaying a message box. We're not doing anything to the spreadsheet. Can we do something to the spreadsheet? Could we use offset to control position to move to a different cell in the spreadsheet? Could we even create a loop to make something happen multiple times? And then after that, can we play an experiment, refine? Can we get that punch the air moment? Yes, we've got to get addicted to those punch the air moments if you can. There's no limit to where you can go as a VBA programmer. So I'm continuing with the file we were using in the previous demonstration. What we want to do is list 10 numbers. So that's our concept. What tools in our VBA toolbox? Okay, it's looking bare at the moment, isn't it? The VBA toolbox. So I'm going to help us a bit. But what tools might help us to make a list of 10 numbers? Okay, and I've gone ahead and got us started here. And we are in at the deep end. We're not expecting you to understand all of this. We're just getting acquainted with these concepts and beginning to build an understanding. So what on earth does this syntax mean? And this particular syntax, I remember when I first learned it, just thinking, what on earth does that mean? Well, through this video, we've mentioned variables a few times. Variable, it isn't a particularly informative name for what it is. A variable is just a place to store some information that's useful in your macro. And it follows this specific formulation. We're going to talk about it later in this series when we cover variables in more detail. Dim variable name as variable type. Now our variable type is an integer. We're dealing with a list of numbers. So a whole number is our variable type. There's various other variable types, including decimals, including true or false variables, including text variables, a string variable. We want an integer on this occasion, and then this black text, this is the name of the variable. And what good programming habits are we trying to build here? Informative names. Informative name for the macro previously, for our module, and an informative name for the variable. Yes, I don't recommend saying dim a as integer or dim I as integer. You see lots of people doing that. Personally, I don't recommend it. Take the time to write it out, make it informative. That's going to save time and stress in the long run. I absolutely guarantee it. So we've got a new macro. We've declared a variable. What's the use of that variable? Well, this is another step up in difficulty. Once again, don't worry if this isn't making any sense. We just want to become acquainted with the concepts. For counter equals 1 to 10 and then next counter. Yes, for next. These are the building blocks of a loop. The most powerful concept in VBA and computer programming, generally a loop. With a loop, we can repeat an action any number of times. Repeat an action any number of times. That sounds useful to us, doesn't it? Because if we could repeat an action 10 times, maybe we could list 10 numbers. So whatever command we put inside the loop here is going to be repeated 10 times. You could repeat it 100 times or even 1,000 times. Let's stick with 10 in your experimentation phase. You can absolutely go ahead and do that. So we want to write a value to the spreadsheet. What's our building block here? A equals B. It's our A equals B concept. The value of A is going to take on the value of B. So where are we going to start in the spreadsheet? We're in D4. So I'm going to say range D4, and you can see the cell references always live in speech marks. You can see the speech marks there. I'm going to say dot value. So the value property is a property we want to deal with. And then I'm going to say 1 here. Okay, so what we expect to happen? Firstly, what if we had made a syntax error? What would happen? I'm going to click in the routine, and you can see already Excel's not going to run that macro. It's picked up on the mistake there. Very normal when writing VBA code. How many routines have I written? Tens of thousands. This happens to me all the time, so don't worry too much about it. Try to push on. You can always reset the VBA editor using the stop button here. So I'm going to go ahead and play this routine. What are we expecting to happen? I'm expecting a 1 to appear in cell D4. And that happens. We can go ahead, prove it. Now we would expect a 2 to appear there. But that's only telling half the story. Why is that? Because we're actually stepping through this command 10 times. So how could we prove that? What could we use from what we already have in the routine that would make this more exciting and would move us towards listing 10 numbers? Well, we can use the name of the variable here because the variable is always carrying a number between 1 and 10. That's the power of the integer variable combined with the for next loop. So what's going to happen now? You might want to stop the video. If we play this routine, what number is going to appear in D4? And if you get this, you're really understanding. If you don't get it, hey, you've got lots more fun to come. Don't worry about that. I'm going to hit the play button and we can see 10 appearing in this cell. Once again, it's not the full story. It's not the full story because we're not just writing 10 in here. Something else is happening. Let's get into our debugging tools. Debugging, one of our Excel meta skills. I'm going to go to debug and step into the most powerful learning tool in the VBA editor, being able to step through the code. Now you can go to debug and keep pressing step into. And what we're going to notice is Excel working through these lines of code. Hit the F8 key to do the same thing. I'm just going to hit the F8 key. And I can see, just looking in the VBA editor, I can see working through this loop. So we're not telling the whole story by just seeing 10 going into the cell because something else is happening. It's just happening so quickly, we're not able to see it. So let's keep an eye on the spreadsheet now. We can see hitting the F8 key again, stepping through this routine. We can see that value changing in the spreadsheet. So what's happening? Well, this variable counter, I can go ahead and hover the cursor over the variable in the VBA editor. The value of that variable is increasing by 1 each time we go through the loop, and we're then transferring that value from the variable via the A equals B concept, range D4 equals counter. We're transferring that value into the spreadsheet. How cool is that? So we're not just putting a single value into the spreadsheet, we're actually looping through 10 values. We're getting closer, aren't we, to listing 10 numbers. So what's the missing piece of the puzzle here? And obviously, you're not really going to know if you haven't done some VBA in the past. You've watched some of our videos, my videos before. Yes, we're talking about position control. Position control. If we could just nudge the active cell down 1 row each time, we could achieve our goal, which is to list 10 numbers. So how to do that? Well, we're going to use offset, which is our command when we're trying to control position. Okay, so you can see I've just inserted the offset method and I've said offset 10 here. So with offset, the first number is the number of rows to move down. A positive number moves down, which can be counterintuitive, but we've got to remember the row numbers, of course, increase as we go down the spreadsheet. And then 0, and 0 is the number of columns to move across. A positive number moves across to the right here. So stop the video. Where is the number going to appear? Is it going to appear in D4 or somewhere else? Well, I've clicked in the routine. Let's go ahead, hit play, and I can see 10 appearing just below D4 and D5. That's because we've moved away by 1 cell. What if we move away 3 rows down and then 1 column across? So experimentation. Where is this going to appear? I'm going to guess myself, starting in D4, 1, 2, 3 rows down, 1 column across. I'm guessing the value is going to appear in this cell and that's where the value has appeared. So we're just getting to know offset, just practicing the skill of position control. You should go ahead, do more experimentation. But what's the missing piece in the puzzle that's going to make all the magic happen here? What if we reset our offset values? What could I put in here? Substitute for this 0 value that isn't a number, that isn't what we call a hard-coded value. Well, here we can harness the power of Excel VBA, a loop combining with a variable here to make the magic happen. Let's step through this and let's just appreciate this together. A bit of a punch the air moment. I'm going to hit the F8 key, hitting the F8 key, stepping through the code. You can just keep clicking step into, that works fine too. Now hit the F8 key, and what's happening? We're seeing our numbers listed. So when the line of code is highlighted, it's not yet been executed. So this line of code is highlighted. Can I just assess what's going on here? So we're starting at D4. We know that, and then we're offsetting away. We're moving away by the value of counter, which is 5. So we're going 1, 2, 3, 4, 5 rows down. And then what value is going to go into this cell? Well, it's the value of counter again. So 5 is going to go into this cell, and I'm just hitting the F8 key and just appreciating the magic of Excel VBA. So you've got to go ahead, do your experimentation. Just off the top of my head, could you create a list of 100 numbers? Could you create a list that went laterally, left to right, rather than up to down? Could you even create a square of numbers? Could you create a list of numbers that started at 10 and counted down to 1? They're just some ideas, some play off the top of my head. It's your job now to experiment, have some of those punch the air moments. As I said, foster a positive addiction to Excel VBA. If you can do that, the sky is the limit, not just for little puzzles like this, but for real world application of Excel VBA. I'm Chris. It's been an absolute pleasure delivering this introductory session about Excel VBA to you. I will see you in the next video. Hi everybody, it's Chris here. Welcome back to Excel VBA for beginners. And this session is all about working with ranges and variables. Yes, we've already spoken in this series about how Excel gives us this beautiful canvas for learning computer programming, for learning VBA. That canvas consists of a grid. Within that grid, there's cells, and those cells in VBA language really are called ranges, and ranges are used to store information. A variable is used for the same purpose. It's just we can't see it. So hopefully by the end of this session, you're going to feel confident working with ranges and variables in Excel VBA in the next hour or so. So I'll outline the video in a little more detail before we get into the practical stuff. So firstly, our first section is range referencing basics. What are the basics of interacting with the cells in the spreadsheet? We know Excel consists of cells. We've got to be able to reference them, to interact with them. We're going to learn how to do it quickly and easily in the first 10 minutes. And then some more advanced range referencing. Why do we need to do this? Well, in Excel, data sets are rarely static. They're always changing in size, rows being added, rows being taken away. So how can we account for that in VBA programming? Yes, we're going to learn some cool dynamic techniques. Then we're going to work with the cells. We're going to get the cells to do stuff, not just reference them. Can we do some simple operations, some simple calculations between cells? That's the third section. And then the fourth section, very exciting for me. I'm going to show you my man draw. We'll get to that a little bit later. Introduction to variables. What's a variable? Very kind of strange, exotic computer programming word. We're going to see it's pretty basic and incredibly useful to us as VBA programmers. So the introduction to variables, followed by working with variables, getting variables to perform some basic operations, and then some essential variable types. We've already encountered in this series some number variables, some integer variables, but we're going to have to learn to work with 3 or 4 other variable types, those essential variable types that will round out our session. And hopefully you'll feel confident working with ranges and variables in Excel VBA in the next hour or so. So for each section, we've got a cheat sheet. This is our section 1 cheat sheet. We've got our essential vocabulary there. Remember, A key skill is conceptualization or translation. And this is the essential vocabulary on the left. And then on the right, we've translated it into the things that vocabulary actually does. We've got one of these for each section for your ease of reference. So let's get into the Excel file. Now, I'm using the file from video one. You could really use any Excel file. You could go ahead and open up a new Excel file. Let's open up the Visual Basic Editor as we learned to do in video one, and I can see the syntax that we wrote in video one here. Now, as always, let's be aware of what's going on in the VBA Editor, particularly the Project Explorer section up here. Am I working in the right file? I can see I've got 2 files open. You don't need multiple files open. It's easier to work with just one file open. I'm going to make sure that I'm in the right file, which is my video one demo file. I can just see the name of the file up here. So we're going to go ahead, insert and name a module as we learned to do in video one. And I'm going to call this module Work with Ranges, because that's exactly what we're going to learn how to do. And then we're going to get into the option explicit ritual. Not that important yet, will become more important when we're using more variables in our coding. So with that said, we've got option explicit at the top of the module. What are we going to do? Let's go ahead and learn some basic syntax. I've got it listed here. So how would we select a cell in the spreadsheet? Let's go ahead and say sub simple selection. So we've created a macro with an informative name. I'm going to go ahead and type in range a1.select. And this is the basic syntax for selecting a cell. Now, do you always need to select cells in Excel VBA? Well, not necessarily. It's more for learning purposes that we're going to do this selection. You know, we can do things to cells in VBA in a remote way rather than a direct way. What's called a remote way. You don't need to select the cell in order to do something, but for the purpose of this demonstration and learning the referencing techniques, that's what we're going to do. So I'm clicking in the macro. I'm going to go ahead and click play, and I can see A1 selected here. Not too bad at all. So let's talk quickly about worksheets. Does it matter what worksheet we're on? And does it matter that we're not referencing the worksheet here? Well, for completeness, you would include the name of the worksheet here. So I'm going to say sheet 1 dot range a1 dot select, and just take a second to note the positioning of the brackets and the speech marks here. So for completeness, this is probably better. But what's going to happen if we click over to sheet 2 and then we hit play? Can you stop the video and guess what's going to happen here? We're going to see we've got a VBA error. So we're tapping into our Metaskills now. We've got an error. What happens? We try to see it, if possible, as an opportunity to learn. And select method of range class failed means Excel isn't able to select what we've asked it to select. And that's because we're not on the correct sheet. So just a good chance to start getting acquainted with some of these error messages. We can click debug, and Excel's going to tell us the problematic line of code in the VBA editor. So if we have no reference here, no sheet reference, we're just going to select this cell on the active sheet. So that's just worth bearing in mind. And you could go to the workbook level as well. We're not going to go there in this demonstration, but if you're working with multiple workbooks, we'd want to be specific about the workbook too. Okay, so we can go ahead and do some play here. What if we select A3? There we go. And what if we wanted to do multiple selections here? So say I wanted to select cells A1 to A3 here. And then we've got a multiple selection with Excel VBA. Not bad. So this is the most basic referencing technique, but it's not the only one. And at this point, I want to introduce to you the cells referencing technique. Lesser known, but a little more useful, I think, if you're comfortable using these numeric references, as we're going to see in a second. So let's have a new macro. Let's call it cells selection. And this time we're going to use the cells referencing method. And you can see the VBA editor asking for a row index and a column index. Now note, the VBA editor is asking for indices here. So it's asking for numbers. So this is a way of referencing cells without using any letters at all. Here we go. I'm supposed to be a VBA expert. I've got an error. It happens all the time. Basic syntax error, not a problem. I can go ahead and just fix it. Cells 11.select. So what cell are we going to select here? So I'm going to go ahead, click in the routine. I'm going to hit the F5 key this time. That's the shortcut for playing the macro. And I can see A1 is selected here. So you can go ahead, experiment with this. Cells 3.select. So we're going 1, 2, 3 rows down, 1, 2, 3 columns across. Where would this take us? This would take us to C3. So 3.6. Where would this take us? Well, it's 1, 2, 3 rows down and 1, 2, 3 columns across, 3 more columns across. So this should take us to F3 if I click in the routine and click play, and I can see it's going to F3 there. Yes, as a VBA programmer, you'll find yourself learning the position in the alphabet of each of these letters, particularly if you're using the dot cells technique, because it allows us to reference columns using numbers. Yes, that's the key difference here, because with our simple range selection, we're using letters. This can make things easier later when we're talking about dynamic range selection, because we can do things like adding numbers on to that number 6 we've got representing the column there. It's easier to manipulate that number than it would be to manipulate the letter that's representing the cell, that's referencing the cell rather, in our first example. So that's why it's useful to be aware of the cells method too. Other ways of selecting ranges. Now, it's important to be aware of selection of named ranges. Why is that important? Well, if you were to add a cell or a column to a spreadsheet, generally in VBA applications, this can be problematic, but it happens a lot in the real world. Then all of the references are going to kind of change, aren't they? The rows are going to shift down one. One way to deal with this is to create a named range, and I'm going to do it the shorthand way here, using the name box in the top left corner. I'm going to confirm that Excel has understood I've created a named range in the name manager, and I can see it says target range there. Okay, so also be aware that you can reference cells in this way too. So I'm going to have another routine here, I'm going to say named selection here. So keeping the names of the macros informative, of course. And I'm going to say range target name dot select here. Okay, so what's going to happen? I'm going to go ahead and hit play, and I've got a VBA error. So what's happened there? I wasn't expecting that, but we can see how we deal with it. We just click debug. I would guess I've got the spelling wrong of this named range. Let's have a look. Target range. There we go. Target range and target name. As usual, talking too much. This is what my children tell me. I go on for too long. There we go. Range target range dot select. And that's how we can select a cell using a named range. So it's 3 ways. All of these ways will become useful during your career. Let's go ahead, put some data in the cell. And let's deal with some more interesting selections before we move on to section 2. So what about selecting a block of cells starting at A1 and ending at B2? Well, you might say, Chris, that's easy because we can just say, let's go ahead and create another routine. I'm going to say range. I'm going to say here, we're going to see in a second why we call this range. And I'm going to say, so you'll say, Chris, that's easy. So if we wanted to select the cells with the words data in, you'll just say, well, we can say B3 to B5 dot select. This works perfectly well. So why might we need to move past this onto range? Well, if we can use range concept we're going to learn and demonstrate now, it gives us a lot more options later. So let's quickly get into range. Can be tricky to understand, but range, we say range to begin with, and then the beginning of the selection that we want to work with is the first range in the brackets, and then the end of the selection we want to work with is the second reference in the brackets. So we've got range. What's the first range we want to reference here is B3. And then B5. Then I'm going to close the bracket so you can see we've got an extra set of brackets that's enveloping everything here. We can say dot select here. So what's going to happen, let's go ahead and hit play, and we should see the data cells there selected. Very good. So these are our basic ways of referencing cells in Excel. So go ahead, do some play. All you've got to do is change these selections and challenge yourself with some little challenges here. And don't worry, we're going to get into more practical stuff, because don't forget from our first video, we've used the macro recorder to record some code that helped us to sort data. So before the next video, it's worth just going back to this code from video 1 and thinking, where could we use, for example, here, where could we use some of the techniques we've just learned to improve this code so we'd have control over the range of data that would be sorted, and which technique would be most helpful? I'll see you in the next section. So we know in the modern business world, data is never going to stay still. It's dynamic. Data sets are always getting bigger. They're always changing. So our coding approach has to account for that. So in this section, we're going to learn some more cool dynamic referencing techniques to enable our VBA routines to work with changing data sets. So with that said, let's get back into the download file. And the specific thing we want to do is to be able to work with a data set where we don't know exactly what the size of the data set is. So let's go ahead. We're going to say select end cell here. We're going to have a new routine. I'm just going to go ahead and bring these routines better into your screenshot here. And I'm just going to go ahead, try this piece of syntax. So range B3, B3 being the beginning of our data set. Then I'm going to say dot end Excel down, okay, dot select. So is this going to work? It does seem to work okay. So why is this code cool? This code is cool because suddenly we have some dynamic quality in this code. We haven't hard coded the end of our selection here. Rather, Excel will find the right cell to select according to what's going on in the data set. So I'm going to click here, click in the routine, and just observe what cell do we select here. We've selected B5. Why is that? Excel started on B3 and worked to the end of the contiguous range. The contiguous range, that word I can never say, is the key idea here. So how could we prove this? We've always got to experiment. We've always got to play. I'm going to go ahead, just take this data down. Now, can you guess, if we play this routine, what cell is going to be selected? We can see B10 is now selected. How cool is that? You know, it's not quite a punch the air moment for these days, but I always get a little kind of feeling of excitement just seeing this stuff working and building up these skills step by step. Cool. Right. Maybe a trick question. Where are we going to select now if we run the same routine? So let's go ahead, run the routine. You can see we've selected B7. So why didn't we not go all the way down to B12? That's because we're talking about a contiguous, yes, a contiguous range. We're only going to select to the next empty row or the bottom of the spreadsheet, whichever comes first. It's almost always the next empty row. So you might say, Chris, my data set is going to have gaps in. So how could I always select the bottom row in the data set, even if there's gaps in? Well, our other referencing techniques, the cells referencing technique, can help us in this situation. So let's say sub select end using cells. And the logic here is slightly different, because rather than starting at the top and working down, as we just did in this routine, started at the top in B3, we're going to start at the bottom and work up. different way of thinking about it, but how will it work? Well, it works beautifully with the cells referencing technique. Cells is asking for that row index. So how many rows are in a spreadsheet? Essential piece of knowledge for a spreadsheet developer. 1,048,507. I'll start again. 1,048,576 rows. So do we have to type that in? Well, you don't have to, because we can just ask VBA to count the rows here. Rows.count is going to give us that 1 million plus figure every time. Rows.count, and then which column are we working with, comma, which column are we working with, the second column, column B. And then this time we're going to say end, can you guess, end Excel up dot select. How about this one? So how is this working? Well, we're going to the bottom of the spreadsheet, cells rows.count 2. That's going to take us to the bottom cell in column B. And then from there, we're going to go up to the first cell that contains data. That's the idea anyway. Let's see how it works in practice. I'm going to click play, and I can see we have managed to select that cell. So make sure you do your experimentation here. I'm going to go ahead and click play, and you can see we've selected B7. What if we did this genuinely out of interest for me? What if we did this in a column with no data in? Would we get an error? We select the top row in the column because there's no data there. So even if the data set is changing in size, we've got ways and means in VBA to deal with that. Cool. So now we want to take our range concept and we want to make it dynamic. This is what we call a hard-coded reference. And we can see it here. Our reference is hard-coded in. So how could we combine one of these techniques to make it dynamic? And I'm going to go ahead and assume our data set is contiguous. And I'm going to go ahead here and integrate a new line of code. So for me to do this with my screenshot, I do need a new line here. So I'm going to go ahead and create a new line. So you can see a space and an underscore there. You don't have to do that. So what can I substitute in here to make the magic happen? So I don't need the select command, but I do need our dynamic reference here. And I'm going to drop this into here and let's see how we do. Okay, I think we're looking good. So you stop the video now. What's our selection likely to be here? I'm going to click in the routine, hit the F5 key, and we can see all of our data is selected there. So let's go ahead and prove this. I'm going to drag this data down and go ahead and play it again. And we can see all of our data selected. So this is dynamic referencing, dynamic data selection. If the data set is changing in size, our VBA routine should be able to handle this. Okay, so what about doing something useful with this? We've learned something theoretical. How could we apply it? Well, let's go back to our macro recorder demonstration file from the first session. And we're going to go back into module 1. And we can see here our code, which does some sorting. So once again, you've got to be very deliberate, intentional about which file you're working in. I'm going to go ahead and locate our macro recorder file, which is just down here. Now I've made some very slight tweaks here. So we have a variable. We're not going to get into variables yet. We're doing that in just a few minutes. But what the variable is allowing us to do is to store a range. And that range, you can see this variable repeated in the code here. That range is then used to sort the data later. We can see this sort range reference, this sort range variable referenced twice in the code. So this is intriguing because if we could get our dynamic reference that we've just learned here, the variable would then hold it combined with the sort code, and suddenly we'd have a dynamic sort VBA routine. How cool is that? Not bad for an hour and a half into a VBA course, I would say. So how to do that? Well, you could write the code again. Could we recycle it? Let's go ahead and write it again. It is good to practice those organic coding skills. So range is our foundational concept here. What's our starting point? We're going to hard code our starting point. We're going to assume that's not going to change. So range B4, I'm going to go ahead, put in the underscore. You don't have to do that. I'm only doing it for display purposes. And then we say range B4 again, that's our anchor cell. That's our starting point, dot end, bracket, Excel down. Then we close the bracket. And then I'm going to say dot address here. Now, why are we saying dot address? Because we want the cell address to be stored in this variable. We're going to get onto variables later, but this is a string variable. So it's storing letters and numbers, in this case, the cell address that we want to work with. Right. How could we do this? If we're not absolutely sure if a routine's going to work, why don't we step through it? We've learned about stepping through the routine, and that would allow us to pick up any issues as we work through it. So I'm going to hit the F8 key. This is the line of code that's likely to be problematic. I'm going to hit F8 and it seems to have worked. I'm going to hover over the sort range variable and I can see our value has got into the variable there. Okay, so I'm going to go ahead and play the code now. It does seem to have worked. I'm going to add some more data at the bottom here. And let's go ahead and see if our code can deal with it. Because remember, we're not just going to select a fixed range. We're going to dynamically select a range here. So let's go ahead and click play. And I can see it is handling the code well. In the first video, we changed the sort order from ascending to descending. I'm going to go ahead and do that. Hit play, and you can see that's how easily we can tweak, experiment, build our understanding, and actually build something that might be useful for us. So again, continue to play, continue to experiment. Can we just, delete data here? Can we put something different in? And is everything still going to work? So if I put ABC here, what would we expect to happen? Well, that ABC is going to go to the bottom of the data set. So dynamic coding, an absolute prerequisite for the VBA developer in the modern world, if you like, in the modern business world. I'll see you in the next section. So we've already done something cool and practical with Excel VBA. In this section, we're going to get back into working with ranges. We're going to perform some operations. Can we add some ranges up? Can we get some values appearing in cells? And we're going to have a discussion in the end, because with all this power in VBA, do we even need formulae at all? That's an important critical discussion for us to take a look at. So I'm going to go back into our demo file and back into the VBA editor. Once again, being very clear about what file I'm working in. I'm in the demo file, and these are some of the pieces of syntax that we've already created. So we've learned about selecting cells. What about manipulating a cell? What about putting a value in a cell? So let's go ahead, have a new macro here, value in cell. The key concept here is the A equals B concept. A equals B concept, where A takes on the value of B. Now you'll see I've just made a note or an annotation in the VBA editor. You would have seen a few so far in this series. These just help us understand in English or in your native language what's going on in the code. Very simple. You just put the inverted comma in. These will appear in green. I do recommend annotating your code. We're going to pick up on this as we go through the series. So a value in a cell. Let's go ahead and clear our data for now. So if we wanted to put a value in B3, and just note, I'm not selecting B3 with VBA, so you'll call this a remote operation. I'm going to say range B3 dot value equals, and then you can put in whatever value you want. I'm going to go ahead and do 100. Click in the routine. I can see my cursor there. I'm going to hit the F5 key, and I can see 100 beginning appearing there in the cell. Once again, the magic never fully fades. I just got a little frisson of excitement there, seeing the value appear in the cell. Now we've got to go ahead and play. Does it work just as well with 1,000? It does. Does it work just as well in other cells? Yes, it does. So go ahead, do your own experimentation there. putting a value into a cell. Could we transfer a value from one cell to another? Okay, so we have 1000 in C3. So you applying the A equals B concept yourself, what would the syntax be to get a value from one cell to another? Well, let's go ahead. Let's just keep building our little dictionary here of useful stuff in VBA. I'm going to go ahead and say sub transfer a value. And in my mind, I'm thinking about the A equals B concept. So let's get a value into, let's say B5. In fact, let's say C4. Dot value equals, so it's A equals B. A is going to receive the value, whether we're talking about ranges or talking about variables. We're coming to those in the next section. I'm going to use the underscore just for display purposes. You don't have to. Range C4 dot value equals range C3 dot value. So once again, just an application of the A equals B concept with some different syntax in there. I'm going to go ahead, click in the routine, use the play button. What are we expecting to happen? We're expecting a value of 1000 to appear in C4. What if I delete both of these values? What's going to happen now? Well, there's no value in C4. In C3 rather, there's no value in C3, so nothing will appear in C4. This is going to work just as well with text. So C3 being the origin cell, C4 being the destination cell, and I can see that value being pulled across there. Cool. So let's go ahead and help ourselves with some cell, just some descriptions of the cell here. So cell 1, cell 2, and cell 3. Let's suppose we wanted to add up the numbers in cells 1 and 2 and display them in cell 3. Okay, let's say sub add 2 cells here. So it's the A equals B concept, slightly more elaborate with the syntax, but it's A equals B. A is the destination. What's the destination? Well, it's cell 3, so it's C5. So I'm going to say range C5 dot value equals, you know, if things feel difficult when you're coding, take a part that's easy, and then the rest is going to seem a bit easier. So I know C5 is the A in the A equals B concept. And then what's going to appear there? Well, it's going to be the value in C3 dot value plus the value in C5, in C4 rather. There we go. Dot value. Okay, so what's going to happen here? Let's go ahead, hit play. Nothing's going to happen because, well, Excel did put a 0 in that, but there's no numbers in these cells, so nothing's going to happen. Let's go ahead, 2 and 3 here. So what's going to happen now? Once again, note, I don't have to have this cell selected. This is a remote operation. Let's go ahead and hit play, and I can see the value going into the cell. This is going to work with big numbers too. I'm just going to go ahead, do some play, do some experimentation, and I can see this working really nicely. Let's go ahead, little bonus here. Let's say sub multiply 2 cells. There we go. So what could we do here? Well, we could write out the code organically, and that would be great practice, you know, for building your skills. I'm going to go ahead and recycle some code. We've got the 3 sources of code. We've got recycled code, recorded code, and organic code, of course. So for this multiplication operation, I just go ahead and substitute for the addition sign, substitute in our multiple sign, which is in Excel VBA, is of course the asterisk there. So I'm going to go ahead and hit play, and I can see this is now 300. What if this was 200? 200 times 3. I do need a spreadsheet for most of my calculations these days, but that does give us 600. So could we just put some buttons in the spreadsheet to complete this? We've been triggering macros from the VBA editor, which is great for learning, but we need to think about creating a way for the user to be able to trigger these macros themselves. And let's go ahead and hold down the Alt key. We're going to insert a button here. And when we create the button, we have the option to choose which macro we want to trigger when the button is clicked. So now we can see we're benefiting from having those informative names for macros. So I want to add 2 cells. So with this button, you can see when we click it, the cells are added together. So here I'm going to say add cells. Then I'm going to go ahead, put another button in because I don't think I explained that particularly well. Developer, insert, form control, then hold down the Alt key. Holding down the Alt key will snap the button to the grid. And this one, we want to multiply 2 cells. So benefiting once again from those informatively named macros. And we can go ahead, edit the text. I'm just going to say multiply here. So if we want to multiply the values in the cells, we can click this button. If we want to add the values in the cells, we can click this button here. Okay, so our section 3 cheat sheet, we've managed to start doing some operations in the spreadsheets. What do we mean by operations? We did some addition, but we could have done subtraction, we did multiplication, and we could have done division too. And I recommend you go ahead, do your play, do your experimentation and do that. But it might leave you asking the question, looking at our critical discussion, do we even need formulae? And this is something we're going to reflect on through the series, because the answer is yes, we do. We absolutely do, because we can do all this calculation work in VBA. So does that mean we should do it all in VBA? Well, not really. In Excel, we have all these different powerful tools that we can use. We've got worksheet formulae, we've got VBA, we've got things like Power Query. It's a case of finding the tasks for each of these tools. Because if we do all of our calculations in VBA, what's going to happen if we want to change the calculations? We'd have to go into the VBA editor. If we wanted to adjust a formula for some reason, we'd have to go into the VBA editor. So we're not saying shift all of your calculations into VBA. We are saying there are times when it might be best to do it in VBA as part of some kind of automation. And we've done a very simple automation already of our sort process, but that's something you want to open a file in your mind and just start making some observations there. What should the balance be between formulae and VBA? When is it best to deploy my VBA skills? When is it best to do things in the spreadsheet using formulae? Next, we're going to talk about variables. So let's talk about variables. Now, a variable is a really strange computer programming term, but I find once people get to grips with variables, and as we're going to see, they're really fairly straightforward, people can really have a big improvement in their coding skills. It's a bit like VLOOKUP. When people are learning Excel, when people get to grips with VLOOKUP, suddenly their confidence grows and they can really make good progress. So that's my aim in the next 10 minutes or so, for you to get a conceptual understanding of what a variable is, create one in Excel VBA. So let's go. Introduction to variables. What's a variable? We've got a definition here. Simply put, a variable is a place to store information. They're the words you need to remember. A variable is a place to store information that's useful in the computer programming, that's useful in the macro. So you could compare a variable to a cell in the spreadsheet. Why? Because they both store information. So when would you use a range? When would you use a variable? Well, the difference is the user can usually see ranges. Perhaps we don't want the user to see this information. And variables are much more efficient. Yes, for Excel to write information to the spreadsheet and get information from it, we haven't really felt this yet because we've been doing fairly straightforward stuff, but that takes time. It's not efficient. Getting information in and out of variables for the PC is incredibly efficient. At the bottom here, we have to declare variables. Yes, you would have seen this formulation just in VBA code, and maybe you've been curious about it. Dim variable name as variable type. That's the second thing I'd like you to remember. One, a variable is just a place to store information that's helping us, and dim variable name as variable type. We have to declare variables, which makes Excel allocate a space in its memory for it, like a drawer or cupboard in your house. Let me show you quickly this is my man drawer. Yes, I love my man drawer. Why? Because it helps me organize stuff. You can see we've got some tools in here. We've got a tape measure. This is a thermometer for checking food that's on the barbecue. We've got some adapters here. This is for bleeding radiators, all useful stuff. But I love how we have different spaces of different sizes, which are designed for different things. Yes, it's efficient. Now, this is how Excel wants to organize its memory. It wants to make different spaces for different things so it can easily take things in, take things out, and put things in. So when we're thinking about variables in Excel, we're thinking about a man drawer. We're saying to Excel, we want to store a piece of data here, and this is the type of data we want to store. Yes, that's the only reason we do variable declarations, so Excel can organize its memory properly. With that said, let's get back into the Excel file. Let's go back into the demo file we were just using. Let's bring the VBA editor back to, and let's go ahead and declare a variable. Okay, so let's call it first variable. And let's go ahead and try it. So what variable types have we used so far? We've seen a string variable and we've seen an integer variable. We're going to talk about different variable types in the next few minutes. Let's go ahead and start with an integer variable here. So I'm going to say our number as integer. There it is. Okay, so informative variable names. Often on the internet, you see people saying dim I as integer. Now, I can see why you'll do that. It kind of sounds mathematical, algebraic. For me, not helpful, because in any kind of vaguely sophisticated VBA routine, you will have multiple variables and you really need to understand what each one does. So I recommend an informative variable name. So we have a variable. Excel has taken part of its memory and allocated it to the storage of this variable, and it's an integer variable. And in the background, Excel actually allocates different number of bytes according to the type of variable, integer being quite a small number of bytes, a very efficient variable to work with. So how can we store a value in this variable just like we'd store a value in the cell? Well, previously we've been putting values into cells, and I hope this is all kind of hanging together nicely now for you. We have the A equals B concept. We applied that concept to cells. Now can we apply it to a variable to get a value in a variable? Could you stop the video and try to do this yourself? Well, A equals B equals B. A is the destination, B is the origin. So the destination, this is where we want our data to get to. That's going to be A, and then B is whatever we want to put into our variable. So we should now have a value in the variable, but how do we know? This is the tricky thing with variables. If we're working with ranges in the spreadsheet, it's very physical. Although it's not quite physical because it's a computer screen, but you know what I mean. It's concrete. We can see what's going on. Variables are more tricky. So having a few tricks up your sleeve is going to help. If you hover your cursor over the variable, you can see the value stored in the variable. Now, this line of code is currently highlighted. I just stepped through it using the F8 key. You can also go to debug and step into. So this line of code isn't executed. This variable isn't holding a value yet. But once we execute this line of code and then hover over the variable is now holding that value. So that value is being stored in Excel's man drawer in the specific space allocated to the our number variable. How cool is that? Can we externalize the value of the variable more efficiently without having to hover the cursor over the variable there? Yes, we can do that. I'd recommend using message box. So if we say message box our number, what will display in the message box? Will it display the text our number? Well, if we put these speech marks around the text, yes, it would display the text our number. But if we don't have the speech marks, it's going to look for a variable called our number and then display the value in the variable. We can hit the F5 key and there it is, 100. So you can go ahead and do your play. And my challenge would be, could you get the value from cell C5? Could you get that into the variable and then to display in the message box? We won't do that in the demonstration. See if in your experimentation and play, you can do that. Just quickly, what if we misspelt this? What's going to happen? Well, we can play and we can see variable not defined. So once again, we need to get to know these error messages and come to appreciate them. And this is what's going to happen, but it only happens because of our option explicit ritual. Yes, the whole point of option explicit is it checks the spelling of your variable names. And if you don't have option explicit, it won't check the spelling. And that means you can get into all kinds of confusion. You know, you wouldn't readily spot this, would you? That there's a very subtle spelling mistake here. With option explicit, it's going to go through and check all those variables first. That's why we always go through the option explicit routine. So variables, they're places to store information. We have a specific formulation in VBA for declaring the variables. They're just like your man drawer. They allow Excel to organize its memory. We're going to learn more in just a sec. So hopefully we've understood conceptually what a variable is and how it can help us as VBA programmers, and we've created a variable. In this section, we're going to work with variables, perform some simple operations with variables. We're going to see how efficient they are. And we're going to answer the question, you know, do we even need the spreadsheet if we can use variables for this job? Yes, that's going to be our critical discussion at the end of this section. With that said, let's get back into the Excel file. So we've managed to allocate a number to a variable using the A equals B concept. So now we'd like to do something similar to what we did with the cells in the spreadsheet, because remember, broadly speaking, they can do the same thing. They both store information. So could we add values from two variables and put them in a third variable? You might want to stop the video and try to do this yourself. So I'm going to say sub add variables. So another new macro. We're just stacking up all these macros in the same module in the VBA editor. So I'm going to say number to add 1 as, I'm going to go for integer, of course, and then number to add 2 as integer. There we go. And then the third variable, and I'm going to say result number, something like, let's just say result as integer. There we go. So we've declared 3 variables. So once again, Excel has gone and created 3 spaces in its memory to store this information. Okay, so how can we put this operation together? And once again, you could use previous macros that we've created as a kind of template for this, because really ranges and variables can theoretically anyway do the same thing. So I've used quite a long variable name. Now there's a couple of reasons there. One is to prove that I think these long literal variable names, they take a bit of time to type, but they keep things super clear. So I do use these long variable names. Just bear in mind, you can type a few letters, hold down Control and space, and the VBA editor is going to show you some options. You can hit tab, and this means you can cut down on at least some of that typing. So number to add 1, an A equals B operation. I've assigned the value of 200 to this variable. Let's go ahead, going to type a few letters, Control and space bar, and then tab, number to add 2. I'm going to use 3 here. You can see I'm using the same numbers that we've previously used with our range experimentation. So we've assigned 2 values to variables. How could we check that? We can hit the F8 key on the Windows PC and step through. I can then hover my cursor over the variables, and I can see those numbers getting into the variables. So far so good, but now we need to do that operation. How can we get those values into our third variable, which is our result variable? Well, hopefully it's fairly straightforward arithmetic here. So result equals, I'm going to go space and underscore here just for display purposes. You don't have to do that. Number to add 1 plus another space and underscore for me, and then number to add 2, tab, and there we go. And how could we externalize this? We can go to message box result, as we did in the previous macro, and we should see the result being displayed here. So I'm going to hit the F5 key, 203 being displayed. So once again, make sure you do your play and your experimentation here. I'm going to go ahead and hit play, and I can see 5 displaying there. So it seems to be working well. We've tested it with the message box, and you can see this is very slick. This is taking no time at all on my system. It isn't easy for us to see, to appreciate this just with these small routines, but even doing that in the worksheet is going to take more time. Yes, variables are slick and they can withhold, they can hold information in a way that the user can't see. So they're efficient and they allow us to store information away from the user. This really is the role of variables. So onwards, could we do a more complex operation here? So I'm going to go ahead, recycle this code. Control V here, and I'm going to divide variables here. So we've done an addition operation. Let's try to do a division operation. So here I'm going to say number to divide and number to divide 2. And then I'm going to go ahead and change these in this routine. So this is a typical example of recycling some code, making some tweaks. There we go. So number to divide. And then we don't want a plus sign here. We're doing division. So we want our division symbol in Excel VBA. So what's going to happen here? We're going to divide 2 by 3. So let's try dividing 3 by 2 instead. And we're just going to go ahead and observe the result here. So what do you think is going to happen? Stop the video, make a hypothesis here. What do you think is going to happen? I'm going to hit the F5 key. We've got 2. So is 3 divided by 2 actually 2? I don't think so. It should be 1.5 here. So what's happening? Well, it's to do with variable types. Yes, we need to know more variable types than just one. We're going to cover that in the next section. Before we dig into the other variable types, we need to know in Excel VBA, just quickly, we've seen variables working. We've assigned values to variables. We've been able to perform operations, just simple operations. And it might leave you thinking, well, do we even need the spreadsheet? Well, as in this previous section where we spoke about formulae, that's a balance that we need to work out as VBA developers, because yes, we can do everything in the VBA editor, hold information in variables, but the user needs to see some information. The user needs to see the output. The user might want to see some of those calculations too. So for us, some information needs to be visible in the spreadsheet, and some information we can hold back and you work very efficiently with using variables in the VBA editor. So once again, that's an open file for us, and we need to establish that balance. Yes, we definitely do need the spreadsheet. What information should be in there? What information should be held in variables? We're going to feel that out in the course of this series, and you're going to feel it out as you use more and more VBA in your career. So back into our file. And why did we come across this strange situation where we couldn't divide 3 by 2? So we can go ahead and demonstrate this. We're dividing 3 by 2 here via the variables, and we're getting a value of 2. So what's happening there? It's to do with the type of variable. Here we've got an integer variable, and that means that Excel will always try to, whatever value we put in, Excel is going to kind of change it to a whole number. So here we should be getting 1.5, 3 divided by 2. Excel is displaying 2 because it's rounding up to the nearest whole number, because it's an integer variable type. So clearly we need to know some other variables to give us some more flexibility here. And the double variable is what helps us here. The names of these variables are quite curious, I've got to say, but a double stores a decimal. So dim interest rate as double might be a typical declaration you'll see of a double variable, because an interest rate is often anyway a decimal value. So can we integrate a double variable here? And will that allow us to get a different result? So this result variable, I will keep the name of the variable the same, I'm going to change the variable type here. So dim result as double. This is going to hold a decimal. So now we're expecting this value to display as 1.5 because we've got a different variable type in there. I'm going to go ahead, play the macro, and you can see we've got 1.5 in here. So basic variable types, integer, absolutely, but integer is only going to hold whole number as we've seen. So if we need a decimal, then we do need to know the double variable type. So what are the other two variables? These are my essential variables. There are others. These cover probably 95% of the use cases in Excel VBA. So we've covered the number variables, if you like. What about a string variable? So dim sheet name as string is something we've already seen in this series. So a string variable is going to hold text, and it, for example, if we go back to our macro recorder download file, you can see we've said dim sort range as string here. Now here the text we want to hold is the address of a particular range. In this case, it's the range of our data. We wanted to dynamically define that range. So this is an example of when you could use a string variable to hold an address. Now it's also possible, some people out there who've done some VBA will know it's also possible to use what's called an object variable here, which will be dim something as range. That's also possible. This is my approach for simplicity. I find learning the string variable first is the way to go. And I don't think there's a huge amount of benefits from using the object variable. So I'd recommend, at least to get started with, that you use the string variable. So let's go ahead and practice a string. Create a string variable here. And I'm going to say dim example string as string, and then let's take a value from the spreadsheet and put it into this string variable, because we've been working with variables and we've been working with ranges in the spreadsheet, but we can interchange these, of course. So we can say A equals B concept, example string equals, I'm going to say range B3 here. So this will take cell B3 on the active worksheet because I haven't specified a worksheet yet. For completeness, we could say sheet 1. I'm going to say sheet 1 here. Dot range B3. So we can go ahead, step through this code. Going to hit the F8 key and hover over example string, and I can see cell 1 has got into the variable there. And we can confirm that as usual with the message box, or we could do something more ambitious. So let's just write cell 3. Let's write the value that's been assigned to that variable in cell E3. So once again, some interaction between variables and the spreadsheet. So we can now, and let's do a bit of recycling while we're at it. And it's a good illustration of the A equals B concept because we're switching around A and B now. And let's go for E3 this time. And now we just say example string. We need an equal sign here. There we go. So what am I expecting to happen? So whatever value is in B3 is going to appear in E3, but it's gone via the variable in the VBA editor. So I'm going to go ahead and click play, and I can see cell 1 appearing there. Okay, so we've got integer variables, double variables, string variables for storing text. Finally, Boolean variables. Very curious. Now, these are for controlling logic in Excel VBA. So let's say sub Boolean example here. Now, Boolean variables are special because they only have one of two values. It's false or it's true. So I'm going to go ahead and just do some example code here. I'm going to say, is it the weekend? There we go, as Boolean. Okay, so could we very simply create a VBA routine to tell if it's the weekend? Okay, and I'm going to clearly put some new coding ideas in here, but why not? We've been in the VBA editor doing quite a strict set of exercises here. So hopefully this is something you could aspire to do. And who knows, this might have some practical applications. So let's say, I'm going to go ahead and do this first actually. So message box, we're going to say format now, then we're just going to say DDD. There we go. I'm going to hit the F5 key. Now this tells me the day of the week, which I can see is Wednesday. So we can go ahead and use a conditional statement now. And I'm going to say if format DDD now equals sat, which of course would be the output here if it was Saturday, and then I need to cover Sunday too. Then I'm going to say then. Is it the weekend? I can go ahead, control and spacebar to auto populate that, equals yes. Okay, so Boolean variable always wants a true or false value. So is it the weekend? Equals false. And then if it is the weekend, then our variable is going to hold and display a value of true. So this code, yes, we're not going to understand this yet, but this code very simply is just working out if it currently is a Saturday or a Sunday. A useful thing to know is Excel always knows the date and time, and we can quickly grab that in VBA, and this format command allows us to display particular parts of it. We could get the day, we could get the time, we could get the month. Okay, so you can go ahead and play with this. I'm going to go for message box, and I'm just going to use the variable one more time. Going to hit the F5 key, and you can see this is coming up with false. So I'll challenge you to adapt this. Now, if you're watching on a Saturday or Sunday, you can of course download the file, you can write this code yourself, and this should return a value of true. A Boolean variable is false or true. That's what it's used for. It's quite difficult to find real world examples, but as we put together more and more complex VBA routines in this series, we should find more application for the Boolean variable. So back to our cheat sheet: essential variable types, integer for those whole numbers, double for where we need decimals, a string variable for holding text, and a Boolean variable for those true or false, those kind of logical things that we need. So this video, let's quickly summarize. We've done range referencing basics, range A1.select. Those basics are working with ranges, but we also learned the cells technique that I do recommend, has specific benefits. Advanced range referencing, so where a data set is going to change in size, as most data sets do these days, we can now do this. Working with cells, so getting cells to interact with each other, adding cells together, we can do that. And it led to a discussion. If we can do this easily with cells, you know, with VBA, when should we be using VBA? When should we be using formulae? That's something we've got to bear in mind. And then we learned about variables. I got the man drawer out to illustrate the concept of variables. We've got variables to do stuff, adding up values between variables, things like that. And we've thought, what is the role of variables versus the spreadsheet? We've got a file open on that. When should we be doing things in the spreadsheet? When could we be doing things using variables? Pros and cons there. And then we've just covered the essential variable types, going beyond the integer variable to at least 3 more variable types. I hope you have enjoyed learning about the basics of ranges, variables, and Excel VBA. As always, I've enjoyed delivering this session. I'll see you in the next video. Hi everybody, Chris here. Welcome back to Excel VBA for Beginners. This is the 3rd video in the series, and it's an exciting video because we're getting started with loops. Yes, loops. Probably the most powerful concept, not just in VBA, but in computer programming generally. Yes, we've done some exciting things so far, but imagine if you could take any one of those commands we've learned so far and repeat it any number of times. Yes, I find loops a really powerful thing, a difficult thing to control, but really crack open the world of computer programming and VBA when you manage to get to grips with it. So first, we're going to learn about the concept. Then we're going to get into a few examples. As always, my aim is to get you using VBA, loops in VBA in your work to save you time and effort. So the outline for the next hour or so, we're going to learn about the concept of the loop first. Yes, we've got the chessboard ready, props ready as always to demonstrate the concept. And then we're going to learn some different types of loops and how to apply them. So for each loop, we're going to loop through worksheets, create as many worksheets as you want, delete worksheets, make a change to all the worksheets in a file. We can do all this using loops, looping through other objects. It's not just worksheets. We can loop through cells, shapes, charts, open workbooks. It's all possible with loops in Excel VBA. We're going to learn the next type of loop, which is for next, which, as I've said here, allows us to loop through anything, in Excel within reason. And then some other types of loops you might need. Do until is a very powerful option. So the shape for the next hour, as always, we're going to be talking about the concept of getting into the Excel file. So make sure you're working on practicing the skill yourself. With that said, what's a loop? Let's look at a couple of real life examples. Well, I'm trying to teach my daughter, who's 4, to play chess. So I spend most of my weekend unpacking and trying to get her to pack up the chess set. And she says to me, Daddy, shall I put the king away? And I say, yes, darling, put the king away. Then she says, Daddy, shall I put the queen away? And I say, yes, put the queen away. And then she says, Daddy, shall I put the bishop away? And I say, yes, put the bishop away. And what I want to say is, just put it all away. And if I could somehow express myself using a loop to my daughter, I'd say, for each of these pieces, put them into the box. For each of the pieces in the box in this collection, do something. This is the conceptual formulation we're talking about. Another example is your washing machine. Your washing machine. Now, I wasn't able to get my washing machine into my office to demonstrate this, but our washing machine anyway, it rotates its drum a certain number of times, and in the options on the front of the washing machine, you can configure the number of times it spins. So it's like 1400 or something like that. Now, in your washing machine, you've got a tiny computer somewhere controlling that cycle and telling your washing machine how many times to spin. So it will have a command that tells it to spin. How do you think that command is expressed within your washing machine? If you have 1400 spins, do you think there's 1400 lines, 1400 commands saying spin, spin, spin 1400 times? Is that how it's going to work? Rather, there's one command that says, do this spin command until a condition is met, until a counter equals 1400. So there's two concepts that I hope help you, begin to get to grips with what we mean by a loop. So how might we translate that concept into some basic coding structures that we're going to use today? So the key concept, get started with loops in VBA. For each object in a collection, for each chess piece in the box, for each worksheet in the workbook, for each chart on the sheet, for each cell in this range. Yes, this is the formulation that we're going to experiment with. And a loop is an incredibly powerful construct to use, but the formulation is fairly simple. And what we want to do in the next couple of minutes is just begin to familiarize ourselves with that formulation, because it doesn't matter if you're looping one time, three times, or 300,000 times, it's the same formulation. So we've really got to try to solidify those. So we're going to look out for each object in a collection. So you're like, Chris, what's an object? Is it a chess piece? Is it a washing machine? Well, it could be, but in Excel terms, an object is pretty much anything that you could see in an Excel file. The file itself is an object. The worksheet is an object. If there's charts on the sheet, each of those charts is an object. If there's buttons or shapes, each button or shape is an object. The cells themselves are objects too. And the way Excel works is it organizes these objects into collections. Now that's kind of intriguing for us because just like we can say, do something to each chess piece in the box, we can say, do something to each object in the collection. And I've got some examples here of objects and collections. And as we go through, we're going to learn how to harness these examples to get things done in Excel. And we'll probably pick up on a couple of other collections too. But this is our base concept to work from. What does it look like in VBA? Well, I've written that down here for you too. For each Chris worksheet in worksheets. So here worksheets would be worksheets would be the collection. And then this is curious, isn't it? For each Chris worksheet, well, we have to declare a variable to represent the object in the collection. Sounds a little bit technical, doesn't it? We have to declare a variable to represent the objects in the collection. That variable allows us to work with each object in the collection. We're going to get back into Excel as soon as possible before we get too deep into technical land. Now, do you remember this example from the very first video in the series? I'd encourage you to get back into this file. Don't try to go into the detail. You know, it's a big mistake people make. Oh, I need to understand every line of code. I think a routine, a macro like this is rather like a map. You know, if you look at a map, you're trying to familiarize yourself. Do you look right at the little details of the map? No, the first thing you'll do is you'll zoom out, you'll look at a whole country, a whole region, you'll look for a big main road that you recognize. That's the way to interpret code. Yeah. So think about the overall structure of the code rather than the specific details, because let's be honest, even for me, the specific details can be quite scary. So I'd invite you to look at this code. What's the main features of the code and how many loops can you spot? And for additional credit, as my old teacher would say, what type of loops are they? Okay, let's look at the main features of this code. Firstly, what's going on at the beginning here? Well, we know from the previous video, this is to do with variable declaration. What kind of variables have we got here? Well, we've got an integer variable that's going to control a for next loop, which we're going to cover later in this video. And this variable type, we wouldn't have seen this when we were talking about variables. This is an object variable. Yes, dim Chris worksheet as worksheet, declaring an object variable to help us work through a collection. So let's deal quickly with this. You're like, why do you say Chris worksheet? You know, is that an inbuilt Excel function? Are you so, you know, deep in the Excel world that they're naming Excel features after you, Chris? Absolutely not. We need a variable name that's informative, but also unique. Informative, but also unique. So I want to know this variable is a worksheet. I could call it anything, but I also want it to be unique, and it needs to be unique so that it doesn't clash with reserved language that Excel reserves for its own use. So I always say Chris something, Chris counter. I say sometimes Chris worksheet, Chris cell, to get that uniqueness, but also to be informative. So what's the role of this variable? Well, what's going on down here? What's the overall structure that we can see? Yes, for each object in a collection. For each object in a collection. What are we doing? Well, even as not quite a VBA expert yet, you know, the viewer of this video, you can probably work this out. Yeah. So Chris worksheet.delete, we've got the variable that we declared representing the worksheet, and then we're going to go ahead and delete that worksheet. So this is what I encourage you to do with loops, conditional statements, variables, all of the cool things that we're covering. Just look at a routine and try to pick out the main features. And in this case, we've got a loop that's deleting all of the worksheets in the file. But there's more. We're not going to go into this now. We've got another loop down here. It's a different kind of loop, isn't it? It's not for each object in the collection. That's the formulation we're familiar with now. This is a for next loop. And we're going to come to this loop later in the series. So to conclude the first section here, let's go ahead, run this routine. And what's happened? We can see we've got worksheets in the file. Let's go ahead, click into the routine. I'm going to click play. And can you see how powerful that is? Yes, we've seen this demonstration before. This is the power of loops. This is the concept of loops. Thank you to my daughter. Thank you to my washing machine for helping with the conceptual understanding. This is the basic formulation. In the next section, we're going to start making loops ourselves to get useful stuff done in Excel. So I've packed the chessboard away. At least for now, we're going to get into Excel and start doing exciting stuff with loops. Now, two basic routines. I'm using these all of the time in my day-to-day work. Looping through sheets in a file. So we've looked briefly in the first section at how to do that, but how could we do something to each sheet in the file? And then looping through all open workbooks. Yes, we're not just talking about stuff within the file with Excel VBA. In the opening video in the series, we spoke about the pros and cons of VBA. A pro is it's supremely powerful to the extent that some people think it's a bit out of control. Yes, VBA can see beyond Excel, can see into other programs too. That's a bit out of scope for us, but seeing other workbooks, that's absolutely in scope. So in the next 10 minutes or so, learning to loop through sheets and then learning to loop through open workbooks. So back into our download files here. I've just tweaked the previous macro to allow us to create 3 sheets in this file. So what would we do if we wanted to do something to each sheet in this file? And now I'm challenging you to stop the video and to call on your knowledge and try to put this together yourself. You might say, Chris, well, that's not easy. Well, we just go back to our foundational concept. For each object in a collection, what's our object? What's our collection? So for each worksheet in worksheets. That's going to allow us to get started. I'm just going to create some room at the bottom of the VBA editor here. So we're going to say I'm going to say change worksheets here. So as always, an informative name for our macro. And well, we're going to say for each something in something. I'm just going to go ahead and write this in, the basic formulation, and comment it out so that VBA is going to ignore it effectively. That means we can get started just conceptually. For each something in something sounds a bit silly, doesn't it? But let's just keep it really basic to begin with. And then next something. This is our basic formulation. And then if you remember, we have to declare a variable to help us get through each object in the collection. So let's go ahead and do that now in real code, if you like. So I'm going to say, let's say Luna Worksheet this time, just for the sake of demonstrating a different name. I'm going to say Luna Sheet as worksheet. So once again, the variable name is informative, but it has an element of uniqueness. You know, you wouldn't be able to say dim worksheet as worksheets, for example, because Excel reserves these terms for its own use. So for each something in something, well, I'm being helped by the foundational concept we've already put in here. So for each variable name in collection name, for each Luna sheet in worksheets, and then next variable name. How cool is that? So all we've done, we've gone from our basic concepts that we just took from the PowerPoint slide, popped it into VBA, and then gone through that process of translating the concept into the code. This is going to work with conditional statements. It's going to work with variables. This is the way to get started with Excel VBA. So how can we prove that this formulation is working? Well, let's try message box. I'm going to say Luna Sheet, which is the variable to represent the object. So when we're talking about the worksheet that we're looping through, this is what we're going to say. And then I want to take a property. As we go through this video, we're going to learn more about properties. So we know what an object is already, pretty much anything in Excel. All objects have properties, and a property is something you'd want to manipulate about the object. If we're thinking about a cell, the cell has a value property. It has properties to do with positioning on the page, the top and the left property. It has properties to do with formatting. So properties are something you might want to manipulate about the cell. Let's go for the name property this time. So what's going to happen here, and how might we go about testing it? Well, to test VBA code, great option in the VBA editor is to step into, you can just hit the F8 key on the Windows PC. Now, what are we expecting to happen? I've intentionally created some nice short sheet names, say that quickly, some nice short sheet names that we can see here. So can you guess what's going to happen next? Remember, when the line of code is highlighted, that means the code hasn't executed that line yet. So if I hit the F8 key one more time, that line of code is going to execute and it says S1. Why does it say S1? Because S1 is the name of the first sheet in the file. And I love how you can do this. Hit the F8 key. You can also go to debug and just keep clicking step into if you want to. We're going to go keep working through this loop. How many times are we going to work through it? Well, it depends how many objects are in the collection. What collection are we using? Worksheets. How many objects are in the collection? Well, we can see that 1, 2, 3. So we're going to go through this loop 3 times. And I can see the last time we go through the loop, we've got S3, which is the name of the last sheet in the file. So what's going to happen now? Where are we going to go next? Can you guess? We're going to go to end sub because we've finished our business with this loop. We've been through it the specified number of times. So we've proved, without doing too much damage to the spreadsheet, that the loop is working and we're going through the loop. Right. Could we do something a bit more practical? Because just flashing up the name of the file, I can't go and show that to my boss and say, listen, I'm harnessing the power of VBA. What might you want to do with a sheet? Well, you might want to put a value into the sheet. So how to do that? We've learnt about the A equals B concept. So how might we put a value into the sheet? You might want to stop the video, maybe go back through your notes and see if you can do this yourself. I'm going to say lunasheet.range A1. You could choose any cell, of course. Equals, we are here. There we go. So what are we expecting to happen now? Well, once again, use the variable name to reference the sheet that we're currently looping through. And then we're connecting 2 objects together here. So the sheet is the higher level object, and then the cell is the next level down object, if you like. And then we can use .value. We don't have to use .value, this being a property, of course, because each object has a default property, and the default property of the cell is the value. Right. So we can go ahead and play this, and you can see we are here in each cell, not just in the cell on the first sheet, because we've looped through all sheets in the file. We've got this in all 3 cells here. Cool. So we've managed to put some static text into each of the sheets in the file. We've got 3 sheets in the file. You could have 30. You could have 130 sheets in the file. It would work in exactly the same way. Can we do something a touch more dynamic? I'm going to use the space and the underscore and then enter to go onto a new line. That's only because I'm struggling a bit with space here. You don't have to do this. What could we do to show the dynamic quality here? Well, why don't we say lunasheet.name. Now what's going to happen here? So now we're experimenting, we're playing. This is when you're going to make exponential gains with your VBA code, when you're just tweaking things, trial and error, seeing what happens. Going to go ahead and hit play, and I can see the sheet name now appearing in the top left corner of the sheet. Could we make this really cool quickly? I'm going to say the name of the sheet is, now this is static text. That's why it's in the speech marks. How do you join together, concatenate static text with a variable? Well, you do that using the and sign in VBA. This is a very common formulation, a very powerful one, combining together some static text with a variable. We're going to go ahead and hit play again. And it says the name of the sheet is S1, the name of the sheet is S2, and the name of the sheet is S3. How cool is that? Now you might say, Chris, but I never need to change one value on one sheet. Yes, I get that. It's somewhat contrived in that sense, but this is the principle. And it's up to you now to think, okay, what do I need to do in my work? And you can go ahead and play and develop things further. So looping through worksheets, incredibly powerful. What else might we want to do? Loop through all open workbooks. So my question is, how many workbooks do I have open? You're saying, Chris, I can't tell. I'm not on your PC. Well, you can, because you know about the Project Explorer in the VBA Editor. You can see we've got 3 workbooks open here, spare workbook 2 and spare workbook with no number, and I can bring those into your screenshot now. So once again, try to stop the video and do this yourself. Could we loop through each workbook and how to do that? So don't go and reach for ChatGPT or Copilot, because you know the formulation is for each object in a collection. So this time I'm going to say change workbooks. You could even recycle. You could even recycle the previous code and just make the changes you need to make. So this time I'm going to say Lunar Book as workbook this time. So workbook is the variable type. And I'm going to say for each Lunar Book in workbooks, workbooks being the name of the collection. We've already seen worksheets. Then next workbook. How about this? And then we want to prove this. How did we prove it last time? Using good old message box. Then the name of the variable. And then some kind of property. Once again, the name property seems most obvious when we're working with workbooks. So can you guess what's going to happen now? I'm going to hit the F5 key this time. Okay, there we go. Compile error, invalid next control variable reference. As far as Excel VBA error messages go, this is a pretty helpful one because it's telling me there's a problem with the next control for a next. And you can see I need to say next Lunar Book here. So perhaps you were jumping out of your seat there and saying, Chris, it's the wrong variable name. But we can just go ahead. That's VBA programming. It's not, that's that's life, isn't it? That's learning. You're going to make a mistake. It's all part of the fun. And over the years, I think I have learned to love those VBA errors, you know, one way or another. So now the file names displaying here. So we've looped through sheets, looped through workbooks. So your challenge, we're not going to do this now, but could you make a value appear on the first sheet of each of those files? But Excel, it's not just about workbooks and worksheets, although that's clearly a big part of Excel stuff. What if we wanted to manipulate stuff within a worksheet, charts, shapes, buttons? See in the next section. So I had a situation on a client project a couple of years ago where the customer was really impressed with what we'd done. And specifically, we'd created a dashboard, and this dashboard had lots and lots of small charts. I think it had about 20 small pie charts. I love a pie chart. It all looked kind of cute with some nice colors. Anyway, the client was really happy with it. And the client said to me, how did you position all these charts? These charts are all perfectly aligned. So should you divulge your secrets that you're using, you know, the black magic that is Excel VBA? Well, we're going to learn to do it in the next 10 minutes or so. We're going to learn to work with another object, which is a shape. Now, I'm going to use the example of a shape, but you could be using a chart here. And as I said, my specific example involved charts. Firstly, some quick Excel power tips about positioning shapes. So if you have a shape in the spreadsheet, you can hold down the Alt key to position a shape to the grid, to lock it to the grid. You've also got the selection pane over on the right where you can view all the shapes. And you've got an option here, which is called Select Objects. Now, if you click this, it puts Excel into what I call PowerPoint mode, because you can click and hold and you'll select all the objects within your selection there. So one way you could align objects is to do this, and then you've got align options here, just like you have in PowerPoint. You could align these to the middle. You can even distribute horizontally. So you could do this kind of thing to get your charts aligned. So is that what I was doing? Well, it wasn't, because I was doing this all programmatically with Excel VBA. So let's get into it. We have set up our usual formulation here. So we've got our variable declaration. This time our object variable is a shape because we're working with shapes. And then we've got for each variable name in collection name. And then we have the variable name repeated here. So first, how can we test that this loop is working? And you might say, Chris, we've done this twice. Well, I do it because every time I build a loop in Excel VBA, I want to test it to see it's working without actually doing any work in the spreadsheet. So I'm going to click play here. There we go. Object doesn't support this property or method. Very common VBA error. And it's because I forgot to put the property in there. At least I hope so. I can hit play. And now we're seeing the names of the shapes. We just saw those over in the selection pane. So I call that a kind of proof of concept. This loop is definitely working. So how might we begin to position these shapes? Well, we know we're dealing with objects, and then in the last section, we started talking about properties. Yeah, you know, what are my properties? I've got brown hair. I'm quite tall. Things about an object are its properties that you in Excel you might want to manipulate. And a shape has positional properties, specifically top and dot left. So is it right or left? We're going to see. I believe it's left. Anyway, we're going to find out. So dot top, what does that do? Well, let's go ahead and do some experimentation. So A equals B concept. We're setting the value of the property to 40. And we know, because we're using Chris shape, we're using our variable, this is going to happen to all of the shapes, all of the objects in the collection. So we're going to go ahead and click play. What's happened? Suddenly our shapes are aligned. Now that's pretty cool. That's because we just adjusted their vertical positioning property, which is dot top. And, you know, I just can't resist it. I can't resist a little play. And I can just go ahead and do this. And I can't resist just trying this. Yes, you definitely don't have to try this at home. I'm going to go ahead and use the worksheet rand formula here, rand between, to see if we can do some random positioning here. Let's say 1 to 200. Is this going to work? We're going to go ahead and hit play. Yes, and now we're going to have random shape positioning. Feel free to take a screenshot and investigate that further. That's a bit out of scope here. But once again, those punch the air moments. I just had a small one. Let's get addicted to those punch the air moments. So let's go ahead and set this back to a static value. Right. So we've adjusted the vertical position. What about the horizontal position here? And what's going to happen if we change the horizontal position to the same value for each property in each of these shapes? What's going to happen? Well, there's only one shape, right? What's happened to the other 4 shapes? Well, let's go ahead, bring back the selection pane, Alt-P-A-P on the Windows PC, and we can see we still have 5 shapes. So what's happened here? Well, they're perfectly aligned on top of each other. So from here, what would we have to do to get these shapes displaying in a vertical line with uniform spacing? How to do that? Well, it's certainly a step up in difficulty. I would invite you to stop the video here, go back through your notes. What ideas do you have? To give you a clue, we need a space to store some information, a place in Excel's memory to store some information. I'm going to say vertical position, vertical underscore pos as integer. This is going to be a whole number variable. So you can go back to the last video if you need a refresher on variables, but it's just a place to store some information. So what can we say now? We can put a value into this variable using our A equals B concept. I'm going to say 100 to begin with, and then I'm going to say Chris shape dot, what's the property going to be this time? It's not going to be left again, it's the vertical positioning property equals, well, we could say a static value, or what else could we do here? Yes, we can use a variable here. So the left property, the horizontal positioning, is static. The vertical property is being determined by a variable which has a value of 100. So what's going to happen? Once again, you might want to stop the video here, and I can see we've got all of our shapes lined up here. So where to go from here? I'm going to put this line outside of the loop because I want to get this value into the variable once. I don't want this command to be repeated time and time again. What's the key concept here? We only need one more line of code here to get some beautiful uniform spacing, exactly the same way I did all those years ago, a couple of years ago anyway, when I built this dashboard with 20 beautifully positioned charts. Well, it's the A equals A plus 1 concept. Yes, we want to increment up our variable here. I'm going to control and spacebar on the Windows PC. Control and spacebar is going to auto-populate that variable. A equals A plus 1. Variable equals variable plus the value by which we want to increment the variable up. Now, how are you doing? Is this feeling like a lot? I've missed out the equal sign there. No problem. Reset the VBA editor. So if it feels like a lot, what can you do? Just don't play the macro. Go ahead, step through it. Use the F8 key. Keep a close eye on what's going on in the spreadsheet. Now, to illustrate this, I'm going to spread these shapes out one more time. Then we're going to step through and we're going to discover what's going on. So chrisshape.left equals 50. chrisshape.top equals vertical pos. So how can we externalize the value in vertical pos? We can go ahead, hover over the variable, and we can see we've got a value of 100 in there, and we can see our shape has been positioned. This is where the magic happens. A equals A plus 1. I'm going to execute this line of code. Vertical pos now has a value of 150. Yes, we've incremented the value of the variable, incremented it up the value of the variable. So hit the F8 key again, coming back through the code. We're working with the next shape now, and we can see the shape position there. It's going to go further down because that vertical position property is increasing each time we go through the loop. So I'm going to go ahead, conclude this, hit the play button, and we've got our beautifully aligned shapes. Come on, let's go ahead and do it again. Let's do it again. Let's play. Let's experiment. Let's have another punch the air moment. Random alignment for our shapes. Got to go ahead, hit play. And there are our shapes beautifully lined. And this is how I positioned 20 charts on an Excel dashboard perfectly. You don't have to tell your customer how this is all working. And this is how we can exploit VBA to do these really annoying jobs at the click of a button. Your challenge now is, can you line these up along the spreadsheet in columns? We've done it vertically. Can you do that horizontally? Don't miss the opportunity to play, capitalize on this learning opportunity. I'll see you in the next section. So we've learned to loop through a few things, and that's great. Looping through buttons or charts, looping through worksheets and workbooks. But what's the main thing you really want to interact with to get stuff done in Excel? Yes, cells and ranges. So in this section, we're going to get stuck into the spreadsheet. We're going to learn how to loop through cells. I'm doing this kind of thing all the time in my day-to-day work. So looping through all cells in the range. As always, we have the key constructs and the code available for you on the cheat sheet for each section. Change the property of a range with the A equals B concept, and then increment a variable. We just touched on this in the last section. These are the key concepts we're going to use. And as I said, in my day-to-day work, I'm not using much more than these concepts to get a huge amount of stuff done. So once again, I've laid the foundations of here. So stop the video and just take the time to point out the key features of this code. Yes, this routine is much more friendly than this routine that we began with, which is much longer. But you'll be able to deal with this kind of routine much easier if you practice with this kind of routine. So we've got the usual features here. We've got a variable being declared. In this case, because we're working with cells, the object that we're interested in is range. Then we say for each object in a collection. Now, if we're working with cells, you can, I believe, just say cells. But how many cells are in a spreadsheet? Good question. Well, we can just go to the bottom of Excel and you can see we've got row 1,048,576. So unless you want to work that many times and many more through the loop, we need to be a bit more specific. And I would suggest this very simple, this very simple formulation here. So this is the range we want to work with. We want to do something to each object in the collection. In this case, to each cell in this range. So what might we want to do? We want to do our proof of concept first. So message box, Chris cell, and then what property of this cell is interesting? Well, I'm often working with the address property. I want to dynamically define ranges, find the size of a data set that's changing in size every day. So the address of the cell is often of interest to me. The address, of course, being A1, A2, A3, A4, A5. So that's a good start. And just a quick tip here, if you just add 0, 0 here, I've got to say thank you to Copilot for this one, and you hit play, you'll be able to get the references without those $signs in. Okay, so that's our proof of concept. What else might we want to do? Well, let's try a different range. So let's go for D3 to D12. D12 here, and this time I'm going to put a value into the cell. So what might you want to put into the cell? Well, you could just put a 1 in, you could just put some static text in. We've done those things already. So could we put a property into the cell? Something more dynamic, something that's going to change with each cell, of course. So I'm going to say Chris cell equals Chris cell dot address. So A equals B concept. Stop the video. What's going to happen when we hit play here? Just going to click play and I can see the addresses going in. Is this going to work? If I say 0, 0 here, we should see the addresses going in, but this time without the $signs in there. Now I'm getting into play mode here. Like last time I did that random positioning experiment, but I can't kind of help myself, and I like to do it so you can see what it's like. Experimentation, play, trial and error. This is the way you really get good at code. Dot top is the vertical position. We worked with that property last time. So all of that is cool, and that would allow us to get a value into a cell. But we want to do something a little bit more dynamic than that. And we want to touch on our foundational concepts, bringing different themes together. So can we bring variables into this? So counter equals counter plus 1. Now we've already seen in this series creating a vertical list of numbers from 1 to 10. How to do that? There's various ways we could do that. I'm going to show you one way, which is a little bit of a cheats way to do it. The dot row property is something that we might be interested in. So you get the dot column property is something that I use often. So now we can see we've got the row. That's pretty cool. How would we adjust this so that rather than going from 3 to 12, we would go from 1 to 10? Well, we can make a simple adjustment here, Chris cell.row -2. And you can see the power of loops, creating that simple 1 to 10 list there. So that's one way to create the 1 to 10 list. And just for completeness here, we've mentioned the column property. What's going to happen now, once again, stop the video. Well, each column has a letter, but in VBA land, columns also have numbers. And earlier in the series, we used the cells referencing technique, incredibly useful because we can use numbers with cells to refer to columns. But because these are all in the same column, these cells, of course, we have a value of 4 here. So all good stuff, learning more objects, learning more properties, and learning how to play. That's the meta skill. If you can learn how to play, you don't need us anymore. Maybe, you can just go ahead and you can work a lot of this stuff out yourself. But let's look at incorporating a variable to build a list of numbers. You've seen that we can use the dot row property to build a list of numbers. How can we incorporate a variable to build that list of numbers, get some variable action incorporated with a loop? This is when it gets mind-blowingly good, when you start bringing these techniques together, as we're going to feel as we progress further through Excel VBA for beginners. Dim counter as integer. Counter, by the way, it's not a technical Excel term. It's not a reserved term. like range or worksheets. Counter is my informative name for a variable that does what? A variable that counts. Absolutely. And once again, you could say, Chris, you said variables should be unique, distinctive. This is lacking some uniqueness. So yeah, I think there's an argument for saying Chris counter here. Okay. So the A equals B concept, A equals B operation. I'm just going to say Chris L equals Chris counter. What's going to happen now? There's no value being put into this variable. It's empty. So what's going to happen? Well, if an integer variable is empty, Excel is going to return a value of 0 here. So the least we can do is put a value into the variable. I would call this initialization. Initialization, and initialization with a Z. For our American friends, initialization means preparing the variable with a value before we go into the loop. You can see this line of code is above the loop. It's going to execute before we get into any crazy loop action. So can you see where this is going and what concept is going to allow us to make the magic happen? That's the beauty of VBA. You get everything set up, you create the foundations, and then one thing binds everything together, makes those tumblers align, makes the magic happen. Increment a variable with the A equals A plus 1 concept. Once again, I'm using this all the time in my work. Yes, let's do it this way actually. Getting too excited as usual. So Chris counter control and spacebar allows me to choose variables from a list. That will save you some typing. So Chris counter equals Chris counter plus 1. Foundational concept is A equals A plus 1. You might say, well, Chris, this is all the same. These structures are being repeated. You're saying the same stuff. When I used to teach in a university, you know, you get student feedback. Mine, luckily, was generally pretty good. But one student says, this guy just says the same thing all the time. It's true because the concepts are simple. They just need repetition. And once you've done enough repetitions, you are off to the races with Excel VBA. Yes, it's party time. Yes, variable declaration, the basic structure of the loop, A equals A plus 1. Concepts, A equals B concept. There's only a few concepts that are repeated that makes the magic happen. Stop the video and tell me what's going to happen before you go ahead and do your own experimentation. I know what's going to happen. It's not going to be quite perfect. I'm going to go ahead and hit play, and I can see we've got 2 to 11. So what's the slight inaccuracy here that's getting us 2 to 11 rather than 1 to 10? Well, it's to do with the order of execution of these lines of code, because we're putting an additional value on the variable here before we put that variable into the cell. So just a quick adjustment there, a classic example of trial and error. It shouldn't be perfect the first time you build it. Build something that's good, that looks decent, maybe feels a bit quick and dirty. Test it. That's going to be the best way to get quick and quality feedback that allows you to evolve the code as efficiently as possible. And I can see 1 to 10 going in here. So quick recap. So far this video, we've been dealing with for each loops, for each object in a collection. We've learned how to loop through worksheets, loop through workbooks. We've learned how to work with objects. We worked with shapes, but the same would apply to buttons or charts too. And now we've learned to work with cells. But this is only half the story, the for each loop. Join me in the next section. We're going to be learning about more loops in Excel VBA. So we talk about 3 loop types in Excel VBA. Firstly, the for each loop, which we've become very familiar with in the past half hour or so. But there's 2 more that are worth knowing about: for next and do until. Now, do you need to be an expert in all 3 of these loops? I wouldn't say so. And the truth is, with for each, and you now have for each in your toolkit, you can get 95, perhaps 99% of jobs done. But I would encourage you, just from a learning perspective, you've built up a lot of momentum. Now's a good time to cover for next and do until. Firstly, they're just kind of cool to know. They're more powerful than for each, and there are some very specific use cases where you would need for next and do until. I'm going to try to point those out over the course of the next 10 to 15 minutes. But in this session, we're going to cover for next. And the key difference here is it's more abstract. A for next loop. A for next loop is controlled by a variable. So we're not able to kind of, how would you say, anchor ourselves in the spreadsheet, for example, by looping through a worksheet or looping through cells. So it's going to feel altogether more abstract, but that's where the magic happens. So with that said, let's get back into the spreadsheet. We're going to take our previous routine, which we used to create a list of numbers, and we're going to adapt it to a for next loop. To do that, I'm going to recycle this code, and then I'm able to delete some elements straight away. Yes, a for next loop is a little bit leaner than a for each loop, so we don't need our object variable at all. And then we can go ahead and change the loop. So we're going to say for Chris counter, for Chris counter equals 1 to 10. So this is the basic formulation for variable name equals start point to end point. So once again, we want to be clear what's the blueprint here, what's the basic formulation. This is what it is. This is the name of our variable. We're going to have a start point and an end point, and then the variable is repeated as with for each. So can we go ahead and prove what's going on here? I'm just going to comment out these lines of code. That's going to turn them into annotations. The VBA editor is going to ignore them. Once again, can we do a proof of concept here? Can we prove what's going on? One thing to note is this line of code, we don't need anymore. The a equals a plus 1 concept that increments the variable made the magic happen previously. The beauty of for next is that's inbuilt to the construct. This variable is going to automatically increment. Hopefully, we're going to see. I'm going to hit the play button, and we've got message box, a variable name. This is a formulation we've used throughout the series for testing. And we can see we're counting through. Now, what's going to happen when we get to 10? Well, it says Chris counter equals 1 to 10. So we can just change the endpoint, do your play, do your experimentation. What are we expecting to happen? We're expecting this to get to 5. Now, I said we'd point out some specific use cases where you would need for next rather than for each. Now, one situation is where you want to work through some kind of collection, but you don't want to work with every object in the collection. Maybe you want to work with every other object in the collection. Now with for next, we have this brilliant step option. Now what's going to happen? We're going to go 1. We're then going to step to 3 because 2 is the increment that we use. 1, 3, 5, 7, 9. And then we would get to 11, but the exit condition is satisfied here because we've said to go from 1 to 10. So this is one situation in which a for next loop can do something that you can't do or can't easily do with for each. So this is just something to bear in mind. You could even try this. So we can go from the end to the start. Once again, this is difficult to do with for each. So we can say 10 to 1, step -1. We can go ahead and work through this, and we can see we're now, would we say we're decrementing? We're incrementing down. Is that a contradiction in terms? So you can see this gives us some flexibility. This is why for next is worth having in your toolkit, you know, not in the main section, maybe tucked away in kind of one of the side pockets. Okay, let's go ahead and test this. So I'm going to restore our basic loop here, 1 to 10, and we're going to try to get a value into the spreadsheet. But of course, we're not using our range variable anymore. So it's the basic A equals B operation, getting a value into the spreadsheet. We've covered it in this series. I'm going to go ahead and clear the values from the spreadsheet to make this clear. So say we're starting in D3 here. So range D3, I'm going to say dot value for completeness. Then what are we going to put here? Yes, we're going to use the variable, of course. So what's going to happen now? Perhaps stop the video. It's not going to look impressive, but we are working through the loop there. What do I mean by that? Well, if we hit the F8 key, and work through the loop, you can see, we couldn't see this, appreciate this with the naked eye because it's happening too fast, but we are actually working through the loop. So we've confirmed that the variable is working. It's taking on all the values between 1 and 10. The question is how to create that list. So what's the position control technique? Well, I love this one. People who know me from YouTube will know I love this one. What's the position control technique that makes the magic happen? Well, it's offset. And we can go ahead and say offset Chris counter 0 dot value. And then I'm going to use the underscore here only because I'm running out of space. You don't need to do that. So that might have been a lot, and we're going to cover offset more, position control, later in this series. But what have we done? Well, offset is going to move away from an anchor point, D3 being our anchor point. How far does it move away? It moves away this number of rows specified by our variable, and then this number of columns which I've set to 0 because we're looking for this vertical list of numbers. So what's going to happen here? Shall we just go ahead and hit play, and we can see we're making the magic happen here. Now, because our anchor point is D3 and Chris counter is taking on the value of 1, we're starting in D4. We're looking at D3 and then moving 1 row down. This is why we're starting in D4. Pretty cool. So what other cool stuff could we do now? We can harness the power of the loop. We've now got 100 numbers. How cool is that? This helps us appreciate how powerful loops are. Did you see that runtime? Happens in just a second, and we can go ahead. How big a number could you do? You could go up to 1 million, because as we've seen just a few minutes ago, we've got 1 million rows in the spreadsheet. What else is interesting to us here? Well, could we create that list from 10 to 1? We've said this is possibly a unique contribution of 4 next. This would be difficult to do with 4 each. So let's go ahead and hit play, and we can see we're still going from 1 to 10. 10 to 1 step minus 1. Chris counter. Is it because we're initializing Chris counter here? We don't need to do that. To 1 step minus 1. I'm going to hit play. Okay, that's interesting. 10 to 1 step minus 1. I'm going to hit play here. Oh, I'm not sure what's happening there. Offset Chris. 10 to 1. I can see. Can you see what's happening here? I hadn't planned for this. But if we're not sure what's happening, what's a good thing to do? Yeah, a metaskill is debugging. I'm tapping into my metaskills here. I'm going to hit debug and step into, because it's very difficult to see what's going on without stepping through this code. There we go. So that's me solving a live problem with Excel VBA, working out what's going on. Right. So how can we fix this? So we can't really use the counter variable anymore. So let's introduce a different variable here. So I'm going to say dim. I'm going to say rows down as integer. I do want to initialize this variable. Rows down equals 1. Then we want to increment this variable. You said you're thinking, well, we don't need to increment variables because we're using for next. Well, this variable isn't part of the for next loop, in the sense that it's not the variable that's driving the for next loop. So this variable does need a specific increment. So rows down equals rows down plus 1. And now, because we've introduced that additional variable, what's going to happen? We can go ahead and hit play, and we've got 10 to 1 there. So if that was, I may have worked through that too fast, just take your time, hit the F8 key, hover over the variables with the cursor. That will allow you to understand what's going on in this example. So that allows you to understand for next. It gives you a sense of the possible unique contribution at for next, whilst remembering if you have for each that we spent most of the time in this session covering, you're probably good to go. But for academic interest, these are great, and there are a few situations in your career where you might need them. I'll see you in the next section for do until. Welcome to the final section of this video where we're learning about do until loops. Now, do you absolutely need to know do until loops for your career? Probably not, but are they fun? Yes, they're a lot of fun, can be a little bit dangerous as we're going to see, but give us an extraordinary level of power and flexibility. I'm just going to try to help you feel that in the next 10 minutes or so with a quick demonstration. So with that said, let's get back into the file, and I've set up a new routine here called do until test. We've got some simple lines of code here we'll talk about in a second. We've also got this area in the spreadsheet. We're going to input random numbers here. Yeah, I told you it was going to get a bit crazy. We're going to input random numbers here, and it's simple. We want to stop inputting random numbers when the sum of the random numbers equals 20. A simple idea. Could we do that with our previous loop constructs? Well, maybe, but it will be a bit convoluted. Do until gives us the next level of flexibility. And just like our other loop constructs, there's a blueprint. There's the basic parts that are the foundation of all do until loops. So let's take a look at these. So do until total inputs is more than 20. So we're going to carry on doing something until the total inputs variable is more than 20, and then we're going to loop. So that's it. This is our blueprint. Do until a condition and then loop at the bottom. Now, the power of the do until loop, this condition could be anything. Anything you can articulate in Excel. It could be some arithmetic, a cell equaling a certain value. Any exit condition you can input here. This is the flexibility that do until gives us. But this total inputs variable, we're not doing anything with it. So we need an A equals B operation to get a value into the variable. What value are we going to put into this variable? Well, it's got a meaningful name, hasn't it? Total inputs. We're going to take the value from D14, which of course contains a sum formula. So A equals B operation. Total inputs equals range D14. And we're demonstrating something else incredibly powerful here, which is VBA working with the spreadsheet. Yes, VBA, super powerful. The spreadsheet's super powerful too, and the spreadsheet has jobs that it's good at, as we've discussed already in this series. VBA has jobs that it's good at too, performing a simple sum operation. The spreadsheet is very good at that, using a formula, so we can combine the two together to make the magic happen. Okay, so now we need to think about getting random numbers into these cells, and not just doing that, creating a list of random numbers. So how to do that? Well, I'm going to start at D3, and we're going to see why I'm starting at D3 in just a second. Dot value. Dot value equals, now I'm going to go for the underscore here just for display purposes, application dot worksheet function. So application dot worksheet function is out of scope for this beginner course, but in basic terms, all of the formulae we have in the worksheet we can access via the VBA editor. So application dot worksheet function, the rand between formula is what I'm interested in. And we're going to say 1 to 20 here. So this effectively is going to put a value of between 1 and 20 into the spreadsheet. Now's a good time to hit Control S. And when you're testing do until, I don't recommend just playing the do until loop. Why is that? Well, if you haven't got your exit condition completely right, then you might end up in an interminable loop. That might well happen. Excel just keeps doing stuff. You can't get out of the loop. How do you stop that? Hold down the escape key. That works on most systems, holding down the escape key. If not, you're going to have to kind of force close Excel by hitting the close icon in the top right of Excel. It is a messy situation, but it happens all the time. Believe me, I've been there many times. So because we're testing do until, we're going to go ahead and step through it using the F8 key, and I can see my random number appearing there. Now that's just outside of our formula range, and Excel has flagged that up, come up with a little warning here saying the formula omits adjacent cells. So what we'd rather do is harness this variable here. So we've seen many counting variables in this video. We're going to harness our a equals a plus 1 concept here. And we're going to move away from position control, yes, offset. We're going to move away from this cell by the value of the Chris counter variable. So it's only one change really, isn't it? Well, maybe two changes if you count the increment of the variable there. But this, as we know, is going to tie everything together and make the magic happen. So I'm going to hit the F8 key now, and I can see because Chris counter has a value of, yes, let's initialize the Chris counter variable first actually. We want a value of 1 in there so that we end up in our formatted range. So Chris counter equals 1. We're going to initialize this variable. We're going to hit the F8 key again. And we can now see our random numbers appearing in this data range. So what's going to happen? Well, this is a great chance to step through this code and then just hover over these variables. The exit condition is we need the total inputs variable to equal more than 20. What does it currently equal? Currently equals 3. So we're going to keep working through this routine and just keep an eye on the counter variable there. That's going to increment up 1 each time we go through the routine. That's not happening automatically, of course, as it would in a for next loop. It's not happening automatically. We need to be explicit about that and integrate this line of code. Now total inputs is 16. Now what's total inputs going to be? It's going to take the value from the spreadsheet, which is 30. So is our exit condition now met? Well, remember when the line of code is highlighted, it means it hasn't yet executed. Total inputs is 30, so 30 is more than 20, so our exit condition is satisfied here. So where are we going to go? Going to hit the F8 key, and you can see we've exited the routine at that point. Pretty cool, I would say. So now we can go ahead, play this routine. Because I've stepped through it, I'm going to Control S, save the file, going to play the routine. And what we can see is we're creating different sets of random numbers. And those random numbers, when they add up to more than 20, we are exiting the routine here. Let's do one more thing because I want to show you the unique value of do until. It gives us more flexibility. Let's suppose we had a weird situation where our random numbers all came out as 1. What's the probability of that? Need a statistician to tell me. What is it, 10 to the power of 10? We had this situation. What would happen there? Well, the exit condition wouldn't be satisfied, and it would actually go ahead and destroy our mechanism because we would continue inputting numbers down here. We'd lose our sum formula, so we need more control. Now, do until can give us that control because we can use our counting variable here to exit if it reaches a certain number. So it's like an additional safety measure here to make sure we don't break the mechanism, and it's easy to put in with do until. So do until total inputs is more than 20 or Chris counter is more than 10. Okay, and just to prove this, I'm going to recycle this code. I'm going to switch this line of code off, and I'm just going to input 1 to each value. And I'm interested to see if, to each cell rather, and I'm interested to see if our safety measure kicks in here. I'm going to hit the F8 key. If you're not sure with do until, just step through it, and we should see the 1s appearing here. Okay, just hitting the F8 key till we get to the end. Now we reach our final input here. What's the value of Chris counter? Chris counter is 10. We've done our final input. Chris counter is now 11. Total inputs is 10. So that condition isn't satisfied. Going to hit the F8 key, and we should exit at this point. And we did exit at that point. So I'm satisfied our first exit condition works. Satisfied our second exit condition, our kind of safety net, works too. And now, with a degree of trepidation, I can go ahead, Control S, save the file, and remove this inverted comma. And this should give us a routine that generates these random numbers, but it has this fail-safe. And to prove this, I'm going to say between 1 and 2 here. It has this fail-safe, which means that mechanism will keep working. That's only possible because of do until and the unique flexibility it gives us. So once again, do you need to go out and learn do until today? Do you need to understand this example in great detail? Absolutely not. I would file it away. I saw this cool example of this bloke online putting random numbers into a spreadsheet. You might need it one day. Just remember the blueprint. As with all of these constructs, do until, exit condition, and then loop. As with the for each loop, as with the for next loop, we need to remember those basic constructs. Guys, thank you so much for watching. It's such a pleasure to deliver a session on loops. Every time I do it, I feel those punch the air moments. I hope I've managed to light a small fire within you. So go ahead, go get yourself some punch the air moments, go do your experimentation, go do your play. Tell me all about it in the comments. I'll see you in the next video. Hi everybody, it's Chris here. A big welcome back to Excel VBA for Beginners. This is video 4 and we are discussing conditional statements today. Yes, conditional statements. Very simply put, we can send VBA code in one of multiple directions. That's what a conditional statement allows us to do, and it's an absolute essential piece in the puzzle of this powerful VBA toolkit that we're building. Yes, all sophisticated Excel VBA routines feature conditional statements in one form or another, and we're going to learn about the main forms of conditional statements. So this is video 4 of 5. We have a task we're going to be working on in this video. So we're moving out of conceptual and theoretical land where we're just in the VBA editor doing little kind of academic tasks. We're moving towards things that you might do in the real world. And in the next video, video 5, the main focus is position control, but we're also undertaking a task to bring everything together, the kind of VBA routine that I build every day in my day-to-day work, and the kind of VBA routine that's going to build your skills and confidence so you too can go on to save time and money with Excel VBA. So that's where we are. Video 4, let's go, conditional statements. So over the next hour or so, we're going to talk about first the concept of conditional statements. Yes, we always try to illustrate the idea with the concept. I've had the chessboard out, haven't I? We have a real world concept that you can latch onto and begin to understand conditional statements. There's a clue in the bottom right hand corner. We're going to write a simple conditional statement in the first section. We're going to talk about single and multiple line conditional statements because there's a few traps to look out for that have cost me hundreds of hours over the years. I'm going to share those in the first couple of sections. We're going to move on to two-way conditional statements. So this is the next step. So if something is happening, we want to do this, but there's an else part to it. If it's not happening, we want to do that. So that's a real step up in power for us. And then we're going to get to where we really want to get to, which is what I call a versatile conditional statement using select case. Yes, select case is the ultimate in conditional statement power. We can send the code any number of different directions according to very specific conditions. And this is what we need for our task, which is to do with traffic lights. The last section, we'll be talking about calling one macro from another, because to make this traffic light task working, this segue isn't as smooth as I wanted it to be. To get this traffic light task working, we're going to need all of the skills that we've been building so far. We're going to call on them in one way or another. Anyway, so what's a conditional statement? I promised a real life example as always. What about your traffic lights in your country? I recognize we've got an international audience here. So traffic lights, you know, the lights and the sequencing might be slightly different, but we've all spent time sitting at traffic lights. Have you ever wondered what's going on in that traffic light? Well, somewhere there's a tiny computer type thing that's controlling the sequencing of these traffic lights. Yeah, it's telling the red light to stay on. It's telling the yellow light to switch on. And it's telling the green light to do nothing in this situation. So our challenge over the next hour is to learn conditional statements and then apply it to a task, which is creating the sequencing of traffic lights in Excel VBA. We're going to do it in a very fun visual way. And I would say one thing at this point, people might say, well, you might be thinking, Chris, that's not going to be useful to me in my work. Well, I'd say the exact structures we're going to build are the structures that you would apply to any professional task involving conditional statements. And secondly, give yourself permission to play from time to time. From time to time, you don't need to be building code for reports and all that serious stuff. You learn most when you're in play mode, when it's fun. And this is the task that was first given to me to learn conditional statements. I found it a lot of fun. That's why I'm sharing it with you today. So hopefully we're just reinforcing this now. What's a conditional statement? A conditional statement sends VBA code in different directions if a condition is met, if something is happening in the spreadsheet. So Chris, what could be happening? What's an example of a condition? Well, it could be a value in a cell. In our case, it could be, is a shape a certain color, but through the series, we've felt how to articulate things in VBA language. Anything you can articulate logically could be a condition. Are we on a particular worksheet? Is there a particular number of worksheets in this file? Is there a worksheet called a particular name in this file? Yes. The limit is your imagination and your ability to express it in VBA. All of those things could be conditions. Without further ado, let's get back into the Excel file. This is what it's looking like. And I'll just take a second to explain how I put this together. Some more general Excel tips here, because people do always ask. So working with shapes, where do these shapes come from? You can go to Insert, Illustrations. I find these shapes pretty good. I find the icons quite nice for nice premium visual touches. I use these shapes a lot. So you can go ahead, put the shapes in. A couple of things to bear in mind. Alt-P-A-P on the Windows PC. Those shortcuts never work first time, of course. Alt-P-A-P on the Windows PC allows you to view. I've just realized what I've done here. I've put some text on our traffic light. Don't want to do that. It allows you to view the selection pane. You can also go to Home. Then over here in Editing somewhere, over here, yes, you'll be able to find the selection pane. So the selection pane is important because it allows us to name objects. In this series, we've named ranges. We can also name objects. I'd recommend you do that. You can do that right here. We've got an object named green light, yellow light, and red light, as you would expect on a traffic light, of course. So this one, just to show you how to name, I'm going to call this base color, because it's the base that the other colors are sitting on. And I'm going to call this one, what would you say? What would you say? It's traffic light support, maybe. Let's double click here. And I'm just going to say light support. So I like to see this. When I go into the selection pane, you'll get charts appearing here too. Just like we want to organize the name manager well, I like to see objects named on the spreadsheet. That's going to make everything easier when we code later. A couple of other things that are worth knowing if you're working with objects. If we go over to this option here, we've got select objects. Now what happens if you click this? It puts Excel, I call it PowerPoint mode, because we can just click and hold and we can cover what we want to select. It's a bit like working in PowerPoint. This is really helpful for working in objects. And my final tip for working with shapes and objects in Excel is to bear in mind, let me click on the shape quickly, that you can align shapes and you can distribute shapes. You've got all those options to do it here. So these things can make everything line up on your spreadsheet, make it look really good, because the icing on the cake is an important thing, no matter how good your coding skills are. With that said, let's go ahead and create a conditional statement. I'm going to close the selection pane here. Now in the VBA editor, you'll find some useful code that we might call on as we progress through our task. You'll also find some recorded code, because you might be saying, well, Chris, I don't know the code to change the color of a shape. Where would I find that? You know, we definitely haven't learned that. So we have to go back to our Metaskills, the sources of code. What are the sources of code? We've got organic code that we code ourselves. We don't know how to do that. So you could recycle some code that you have from another source. You're very welcome to recycle this code. You could record the code with the VBA, with the macro recorder, as we did earlier in this series, this code is actually recorded. You could go online, you could go to your AI tool, Copilot. These are all ways to get the code. So there's no need to feel stuck on this kind of task because we know the sources of code. I'm going to go ahead, insert a new module, always give the module a name. I'm going to say lights code here. And then what's our ritual when we start a new module is to go option explicit at the top. And that means that variables and spelling mistakes, particularly of variables, are easier to pick up and easier to manage. Okay, so what might we want to do here? So let's say sub easy if statement. Okay, so to keep it simple, this is going to have no real practical value, but it's going to get us into conditional statements. So we can say if selection.name equals red light, then underscore message box. I'm going to say this is the red light. There we go. Okay, so a few things to cover here. I need the underscore because I'm limited in space here. You don't need the underscore. This is going to work absolutely fine if all the code is on a single line. I can't quite fit it in. This is why I'm using the underscore here. Secondly, this code will only work if something is selected in the spreadsheet, if an object rather is selected in the spreadsheet. If nothing is selected, this is going to happen and we're going to get some kind of error message like this. Don't worry too much about error messages. As we've found, as we've gone through this series, we get them all the time. It's a meta skill to be able to deal with them. I'm going to go ahead and select the shape. I'm going to select the red light here and I'm going to click play and we can see our message box is displaying. Why is that? Well, let's go back to our foundational concepts. We have a condition here. So if condition, then the code we want to do if the condition is met. Because the name of the selection is red light and we can see in the name box in the top left of Excel, that's the case. We are displaying the message box. If we select something else like yellow light, we can see this message box isn't displaying because that condition isn't met. Very good. So a simple one-line conditional statement here, but there's just a few traps to look out for here because there's different ways we can write this conditional statement. So we can also say end if at the bottom here, but only if the code is not on a single line. I mentioned a couple of minutes ago, this code is a single line of code. The underscore is only there because I need to use another line. So this construct is also perfectly acceptable for a conditional statement, and I can go ahead, prove this, hit the red light and click play, and it says this is the red light. So what wouldn't work? So this wouldn't work if we get rid of end if. You can see we've now got two lines of code. We don't have an underscore, so we're not connecting those two lines for VBA. If we hit play now, we're going to get block if without end if, which is one of VBA's more helpful syntax errors. So basic formulation then, we can have all the code on one line, or we can use if, the condition, and then the instructions to undertake if the condition is met on a different line, as long as we use the block if, as long as we use the end if there. So this is our first conditional statement. Let's go back to our slides quickly. Yeah, we've covered everything here. So what we were talking about at the end is 1 and 2 line simple conditional statements. So what's our task? Well, we've felt that we can interact with shapes in the spreadsheet. We can interact in some way, very simplistic way so far, with our traffic lights. This is what we want to build up to. So this here in the UK is our traffic light sequencing. This is how the traffic lights work. So we go from red to red and amber to green to amber and then back to red, and you can see the first and the last visual are the same here because this cycles around. So we've got to go ahead and actually try to put that together, and we will continue with this in section 2. So for section 2, we're going to set ourselves a really easy task. Yes, this is how to work through these big jobs, just break them down into smaller tasks. So we're going to suppose we take the red light. Can we change it to black? And if the red light is black, can we change it to red? So we just want to work with those two colors. So as always, we've got our cheat sheet. We've got some syntax to help you along the way. We can change the shape color by changing the property of an object. We know what objects are. We know these objects have properties. So first, can we get into the VBA editor and just change the color of a shape? Okay, so I'm going to go ahead and say change red light. And this routine, I'm going to note down here the purpose of the routine using pseudocode, which is just an annotation. So I've hit the inverted comma here. We're going to cover the importance of this as we go through the task. So I'm going to say change red light to black or back to red. This is what the code is doing. So we need to find that code for changing the color of the shape. So I'm thinking, well, what are the sources of code? I'm a very experienced VBA programmer. I can't just write that code organically. So what have we got? Well, we've got recycled code. I know I've got some useful code in this module, and I can just go ahead and grab this code here, Control C, and drop it straight in here. And it gives us at least a starting point. Now, as usual, I'm going to go ahead and break this line out over 2 lines, but that in your VBA editor would be across a single line. Okay, so what does this line of code do? Well, once again, let's use some pseudocode to make it clear. Use some annotations. Changes red light to red. There we go. So could we go ahead and prove this? Well, the red light is already red, so we can go to the shape options here. Let's just change it to black. And when we run this routine, we would expect, hopefully, this light to turn red. So I'm going to go ahead, click play, and I can see, yes, the light turned red. Great. So that basic command is working. What do we need to do next? Well, we don't just need the light to go red. We need the light to go black too. So how would we do that? Well, clearly there's some conditionality there, but let's not get lost in the difficult logic. Let's do the easy bit first. Always do the easy bit first. It's funny how the difficult bits come together once the easy bits are done. So VB black is an option for us too. So now I'm going to go ahead and step through this code, hit the F8 key. So the first command, which of course doesn't execute until you hit the F8 key. So if it's highlighted, it hasn't executed yet. This changes the shape to red. So nothing, we can't see anything happening. And then this should change the shape to black. Okay, so this is a great start. No errors so far. And we're doing pretty well. So now that conditionality. So how do you go about articulating this? It's very easy to get into a mess. I recommend using as much pseudocode as possible. Make the notes in English or your own language, and then just translate those commands that are written in English or in your own language into VBA. Okay, so if the light is red, then we want to change the color to black. Okay. Then what's the other part of this logic would be if the light is black, or we could say if the light isn't red, then we want to change the color to red. Okay, and you could even go ahead for additional credit. If you want to be the teacher's pet, you could say close if statement here. So that's how easy it is, guys. That's how easy it is to make a logical nightmare a lot easier to work through. Write it down in your own language first, and then we can translate these one by one. So if the light is red, okay, well, what syntax would help us here? Well, we've got syntax down here to do something similar. We've got syntax here to change the color of the light to red. So that's something we can work with. So sources of code, let's go ahead, recycle here, and we can say, we know from our basic conditional statement construct, if we say if, then suddenly we've changed that command into the condition, which is the first part of our conditional statement. What else do we need in a conditional statement? Well, we need to say then. This is part of our blueprint, and we can reference our simple conditional statement there. And then What's the other part of the syntax? The remaining part of the blueprint is that block end if. And so suddenly we've got a conditional statement here. What would our command be? Well, once again, we can reuse code. So if the light is red, then we want to, going back to my notes here, I literally lost the thread there, just went back to my pseudocode. That's why it's so important. And we can change the red light to black. This should say. Okay, we can go ahead and drop this in. I'm going to cut this time, Control X, Control V. So this should get us halfway there. But what's going to happen? I'm just going to comment out this line of code. If you want to effectively switch off a line of code temporarily, just commenting it out, putting the inverted comma in there, VBA is not going to read any of these green lines of code. So that's effectively a way to get VBA to ignore the code. So what's going to happen? I'm just going to hit play. And as I expected, nothing's happening yet. Why is that? Well, this condition isn't met, is it? Our condition is do something if the color of the light is red. The color is currently black, but will my red be the exact red that VBA is looking for? I'm not sure. I'm hoping it is. But if not, we'll work around it. Let's hit play. And I can see the color changed that time. So that's half the story, but it's kind of useless without the other half of the story. So how would we do this? Well, maybe we could use another conditional statement. Let's go ahead and complete our annotations here. Close conditional statement. You could just say if statement. I mean, come on. And then what if we recycle the whole thing and try to deal with the other half of the logic, which is if the red light isn't red. So how could we say this? Let's say if the red light is black, then we want to change it to red. So what's going to happen here? Let's go ahead and just play this code. And let's see what happens. I'm going to play the code. And you can see we're kind of stuck on red. So what's happened there? Well, what do we do? Tapping into the Metaskills. If we don't quite understand what's happening, step through the code. You can hit the F8 key or debug and step into. Hit the F8 key. Right, the light is red, so this condition should be met. So we are going into this conditional statement, and then we're changing the light black. But what does that mean? When we get to our second conditional statement, that's also met too, because within the code, we've created this condition already. And then we can hit F8 again, and we can see the light changing back. So it's an example of VBA doing something, but it's happening so fast, we can't actually see what it's doing. So how to rectify this? Well, we're very close. We have to bring these statements together into a single statement. Yes, this is our next building block, if, else, and if. If, else, and if. So we can say, if the light isn't red, then we can go ahead and drop our command in here. I love how it's pre-annotated. That's helping me. Then everything else we can actually get rid of, I believe. Okay, so this is our second foundational concept. We've had our simple if statements, but we've just raised the game. Seriously, we've raised the game here because we have a condition. But if the condition isn't met, and this is what this else syntax is doing, this is part of the blueprint for if, else, and if. Else is giving us the catch-all option. If that condition isn't met, this is what we're going to do in all the other conditions. So we're going to change the color to red. Right. Let's step through this code once again, hitting the F8 key. So I can see the first condition is met. So we're going to go to black. And because we're using if, else, and if, that's where we exit the conditional statements. Right, let's go through again. So now the condition isn't met. So what happens? Well, we don't execute this command, which is the command that executes if the condition is met. We go to the else section, and hopefully when I hit the F8 key, we're going to go into the else section and we're going to change the color to red. How cool is that? As I said, the punch in the air moments, you know, no matter how long you do this, you just get that little bit of excitement when things work well. So we can now go ahead and you can impress your significant other. With this, we can change the color from red to black using conditional statements, using our if, else, end if conditional statements. But there's more to traffic lights than that. I'll see you in the next section. So we're making progress with our traffic lights challenge, and we've managed to do something that might be useful in VBA using conditional statements, just changing the color of that red light from red to black. But of course, that's not how traffic lights work. So could we do something more useful and change from one state, that's going to be an important word, change from one state to another state using some more sophisticated logic? So this involves going into our cheat sheet. This involves using multiple conditions. Yes, with if statements, we're given the flexibility to specify multiple conditions with if or logic. So if this is happening and this is happening, do something. If those things aren't, both of those things aren't happening, then we won't do that. And the same with the or logic. So can we go ahead and create the code we need to move from one state to another back into the VBA editor? So the name of this macro will be, I'm going to say sub from red, yellow to green. Okay, so once again, an informative name for this macro. Can you see all of this supporting information is helping us to understand what's going on in the VBA editor? Having properly named modules, having properly named macros, and having well-structured code, and that's decorated, if you like, by our annotations, our pseudocode. All of these things are helping us understand what's going on. So we have red and yellow on. We want to move to a state where only the green light is on. So the yellow light will be black and the red light will be black. So we're going to start, as always, with our pseudocode. So if red is on, if red light is on and yellow light is on, then what are we going to want to do? Well, we're going to want to switch the green light on, but we've got to switch the red and yellow lights off too. So let's create two more annotations here. Switch red lights off and switch yellow lights off. Red and yellow lights off. And then we want to close the conditional statement. So once again, using our pseudocode to get things straight in our minds, that's a big step towards getting this working, because now all I have to do is translate each of these lines into VBA. I can chip away at this task without getting too lost and too disheartened. Yes, it's all about psychological management of the self when we're doing computer coding, particularly VBA. So you'll notice I've already started scrolling up the VBA editor. I'm thinking about sources of code. Could we recycle some code here? So if red light is on, well, that sounds familiar because we did that in the previous section. So I'm going to go ahead and grab this. But there's a crucial difference here, isn't there? Which is the and condition. So once again, I'm going to use multiple lines here for display purposes. You might find yourself in this situation, you might have one long line of code. So you might need to use the underscore to allow you to articulate this properly. So it's always space and underscore to allow you to move to a new line. That moves the syntax to a new line, but VBA understands it as the same line. VBA read and, so can I, and yeah, be prepared to get into a bit of a mess here, but that's all good. So we don't need to repeat if. We do need our underscore here. So this, I think, is good. And I'm going to go ahead, close the conditional statement, and remembering that the VBA editor ignores anything in green. It's going to ignore our notes there. So if the red light is red and the yellow light is yellow, that means we're in a particular state, and that means we want to do something. VB yellow. Okay, making progress here. At this point, I want to take a beat and I want to prove that this conditional statement is working because I've already written quite a lot of code. How to do that? Well, if the conditional statement is working, I can see visually the conditions seem to be met. So if the conditional statement is working, we're going to end up here and we're going to flash up a message box. Yes, the message box. Super useful code testing tool. There we go. So I'm happy at the very basic level, this conditional statement is working. So now the commands, we want to switch the green light on. So I'm thinking, can we recycle? And yeah, let's go ahead and grab this code from the previous section. Let's drop it in here. Once again, it's just a case of changing the letters here. So VB green is also accessible. Switch the red light off. Let's just use the same code here. Well, that's exactly it. Switch the red light off. Red light is black. Switch the yellow light off. And we're going to say yellow light becomes black here. Okay. So I'm now sense checking. Does it look reasonable? We don't need our message box here. Looks reasonable enough, so you could just kind of go for glory and play this code. If I'm not sure, I almost always step through. So we go to debug, step into, or you could, just to show you another debugging tool here, you could put a stopping point in the code. That means when the code gets here, it's going to stop. So let's try with a stopping point. I'm going to click play. We have got into the conditional statement. That's what we'd expect. We know that from our previous mini test. So the line of code is highlighted. It hasn't executed. So I'm going to keep an eye on the green light, F8, and the green light is turning green. Now keep an eye on the red light, F8. The red light is now off. Keep an eye on the yellow light, F8, and the yellow light is now off. So it seems to work well. What's going to happen if I play the code again? Well, let's step through it. So is the condition met now? We've got two conditions connected with this AND operator. Well, the condition isn't met now. So what's going to happen? Excel's going to just exit the if statement because we don't have an else part to this statement. Excel is just going to exit. Good. So we've managed to change from one state to another. So that's something that could be useful for us. But now the question is this the way forward? Is this the way forward? I would invite you to try. I would invite you to try to program the other states in this way and just see how it feels, because what we're trying to touch on here is that things can get very busy with if statements. We've got 4 different states. Each of these states has 2 or 3 conditions attached to it. What you might find is you get into a bit of a mess. So this is why we've got to go back to the drawing board. We're going to bring some more tools in from our VBA toolkit, conditional statements. I'll see you in the next section. So if you're feeling you've done a lot of code and it's quite mentally taxing learning all of this new code, maybe you've done previous videos today too, I've got good news for you, because the next 5 minutes or so, we're not going to do any code in the VBA editor. Certainly, we're not going to write any actual VBA in the VBA editor. That's because we're going to deal with the meta skill of conceptualization. The meta skill of conceptualization. So why is it important? Well, we set up the last video to help you feel how easily you could get into a mess doing this kind of sophisticated VBA job. And I can tell you from the bottom of my heart, I've been there so many times, and it's a difficult place to be. When you're working hard on something, you think, oh, if I can get one more step, then the job's done, particularly if you have a customer waiting. It really is a tough place to be. So I've learned over the years the importance of conceptual planning. It's crucial to plan a sophisticated VBA routine. You might think coding, well, it's all about knowing the most code. It's all about, who's got the best coding skills in the VBA editor. That's not true. I'm sure over 15 years that isn't true. the most important things are the meta skills that we've covered. And the first thing is, can you think clearly through what you're trying to do? And then can you translate it into pseudocode? So can you write the commands out in English or your native language, as we've felt already in this video? From there, it's just a case of translating those commands one by one. So I fully expect people to skip through this section. You'll come back in a few years. I guarantee. I was the same. I was just interested in coding, less interested in the conceptual side. So with that said, what might help you when you're trying to conceptualize? Well, good old pen and paper, 100%. You know, I think if you get away from the computer, and this applies to Excel and all kinds of other things in business, it allows you to think differently. So perhaps grab your notebook and go ahead and write down the main parts of the task, and then try to get to the stage where you can articulate it step by step in a way that's a bit like code, that's pseudocode. That would be the aim. So pen and paper would help. Personally, I love visual stuff. I love visual stuff like this. So this to me made the traffic lights task absolutely clear. This task I did 15 years ago. Warwick Business School, Andrew Martin first taught me spreadsheets. And I remember when I saw it visually, it made things very clear. Now, this might not just make things clear for you, this kind of visualization, it might make things clear for whoever uses your spreadsheet, or if you're building VBA for somebody else, for your customer. So this kind of visual can have all kinds of cool, kind of unexpected benefits too. So conceptualization. We've got this concept of state. So a state is a particular configuration of the lights being on or off, each light being on or off. So the first state would be, I've called this the wait state, which is everyone's just waiting at the lights. The red light's on, the yellow light's off, the green light's off. State 2, this is how it works in the UK anyway, the amber light is on, so you're getting ready to go. I call this the ready state. Red is on, yellow is on, green is off. And then state 3 is the go state. Red is off, yellow is off, green is on. So the traffic is now flowing through the lights, the traffic is going. And then state 4 is the stop state. And the stop state is just an amber light here in the UK. That means you should be stopping, although amber gamblers, they often keep going. And then we're back to state 1. So not only have we made each state clear, but we've established there's a cycle here. These states cycle through. Is that ringing some bells for you? What tools have we learned already to do with cycling through stuff? So hopefully there's something that we can grasp, if you like, in VBA here. So with that said, this is entirely conceptual, this section. We're going to go ahead and write the pseudocode in VBA. That's going to help us to better be able to create this routine properly. So I'm going to say I'm just going to call this traffic lights. Let's call it change lights, something a little more informative here. I'm going to make some general notes here. So 4 states. 4 states. The first state is the wait state. And the wait state is red on, yellow off, green off. And the second state is the ready state. So red on, yellow on, and green off. So the next state is the go state. So red is off. Just missed red on here. Let's go ahead and put that in. Red is off now. Yellow is off. And green is on, of course. And the fourth state is the stop state. And here, red is off. Yellow is on, and green is off. Okay, so once again, pseudocode. And the great thing about pseudocode is it doesn't have to be perfect first time. You can get your thoughts on paper or into the VBA editor, and from there you can craft them into these kind of single lines of code that we could potentially translate into Excel VBA. So what else would we need? We'd need some kind of conditional statement to help us to navigate through these states and to help us get to the right state. And not only that, to help us loop back to the first state. So let's just flesh this out a little bit. So first, let's find the current state. We're going to see in the next section how we express state. You might want to think yourself, how could we store the state? A place to store information. What might help us? So find the current state. Then we'd say if. Then we'd want to increment the state to the next state because we want to move things on. So if we're in state 1, we want to increment to state 2. And then if state is 1, it's the wait state. If state is 2, it's the ready state. I forgot my inverted comma there. And then if state is 3, it's the go state. It's 3. And then if state is 4, it's the stop state. And then we want to close the conditional statement here. Very good. So as I said, a selection that's entirely conceptual and perhaps a bit boring. Perhaps, this isn't what you came for. You came for groundbreaking VBA code. But this is what it's like. This is programmer life. It's not about jumping in, solving everything, just coming up with amazing lines of code. It's working through tasks slowly, steadily, incrementally, getting it crystal clear in your mind what the logic is before you even think about talking to Excel VBA. So what do you notice about the structure here? We've laid out the structure, the blueprint, if you like, in Excel VBA. What tools would help us in our toolkit? We've got our simple if statement. We've got our if then, else, end if statement, which allows us to go in one of two directions. But what's idiosyncratic to this? Well, we've got 4 states to work through. 4 states to work through. So we need a new addition to our toolkit. I'll see you in the next section. So we're going to get back into coding land now, and we're going to add the last part of our toolkit for conditional statements. Yes, select case. I love select case. I'm using it all the time in my day-to-day work. Why do I love it? Because it's so versatile. It's so powerful. It allows the code to go in any number of directions. Yes, we've done a simple conditional statement which deals with one situation. We've done if, else, and end if, which gives us 2 situations really. Select case gives us flexibility and versatility. Any number of situations, any number of conditions we can deal with. For me, it's an absolutely essential part of your Excel VBA toolkit. You may have heard of other conditional statements, if, else, if, and there's others too. I don't think you need those. You need exactly what we're learning today. Select case, which with its versatility allows you to deal with pretty much all situations. What's the blueprint? Well, the blueprint is as follows. Select case, cell, or variable. So what on earth does that mean? Well, here we're saying this is what we want Excel to look at to decide where it's going to go. That could be a cell in the spreadsheet. What's the value in this cell? According to the value, go in a particular direction. It could be, I've said cell or variable there. It could be the value of a variable. We know a variable is very much like a cell, certainly in the role it plays, because it just holds a piece of information. So we could say select case variable name, and then according to the value in that variable, we can do something completely different. So with that conceptual introduction, let's get back into Excel and let's go ahead and build the blueprint for select case, and let's just get it working a bit so we can appreciate what's going on. Okay, first we're going to go into the spreadsheet. I'm going to choose a cell here, and you can see I've actually already gone ahead and given it a name. In the name manager, I can see I've called this state cell. You could call it anything else that you think is informative. Why should you name this range? Because this is a pivotal range in this VBA routine. Yes, it plays a very important role. If you name the cell, should somebody come and add rows or columns later, this cell is going to retain its name which is state cell. So that's why it's a good idea to give these cells names. So with that said, let's go ahead and build the basic syntax for select case. So I'm going to say select case range, and can you guess what range I'm going to put in here? State cell. Okay, does state cell have an underscore? Yes, it does. And of course, I've made a basic syntax error there. What's happening? Absolute chaos in Excel. Select case, of course. Select case. So this is our basic formulation, and we can tell because the VBA editor colors the main parts of the blueprint in blue, a different color. So select case starts our conditional statement, and then we're saying, look at the value in this cell. According to that value, do different things. How cool is that? So we can go ahead, just adjust our notes here. First thing we want to do is increment the state to the next state. Okay, so how to do that? Foundational concept, A equals A plus 1. So range state cell. Now you can say dot value here. You don't have to because value is the default property. So you can just say range state cell equals range state cell plus 1. Plus 1. That's going to have the effect of incrementing up to the next state. Where should this be? This should actually be here. So let's do that incrementing first before we get into the conditional statement. So going back to our blueprint for select case, let's go ahead and close the conditional statement. Now, it's a good idea when you open a conditional statement before you start programming all the conditions, go ahead and close it, and end select is the syntax here. We can see VBA has understood it because it's highlighted it, colored it blue. So what are the different eventualities we want to account for? Well, case 1, if the state is 1, we're in that wait state. This is where our notes are helping us. We're in the wait state and we want to switch red on, yellow off, and green off. If the state is 2, case 2, this is what we want to do. Case 3, this is what we want to do. Case 4, this is what we want to do. That's how easy it is with select case. All this power, all this versatility. We have 1, 2, 3, 4 cases. You could have any number of cases. You could have plenty of cases. I've done this with probably up to 100 cases in the VBA editor. And you have your catch all option 2, which is case else. And this will account for all the cases where none of these conditions are met. Now, we don't need that, but that is incredibly helpful and another advantage to using select case. So how can we prove this is working? Well, let's go ahead. I'm just going to say message box, and I'm going to say case 1 here. And let's go ahead and just drop this in. Control C for a quick test. Once again, we've put a lot of syntax in, so before we start putting even more syntax in, we need to program the commands, what's going to happen in each case. Let's go ahead and just prove conceptually, well, a bit more conceptually, prove programmatically that this is actually working. So how to do that? Save the file, Control S. Equals A equals A plus 1. Let's go ahead and step through, hitting the F8 key. So I can see state cell went from nothing, 0 to 1. So what's going to happen? Well, it equals 1. So we'd expect to jump into this first case, and I can see case 1 flashing up there. Cool. Now, because this condition is met, we're not going to go into any of the other conditions. We're going to go to the end of the conditional statement. Cool. So I'm going to hit play now. We're now case 1. Going to hit play again. Case 1. I was wondering why case 1 kept flashing up. I was hoping it would resolve itself. It's just a simple syntax error on my part. And I hope you're saying making errors and dealing with them, fixing them is very much part of VBA programming. Right, case 4. So let's go ahead, play this a few more times. What's happened here? Can you see the state cell is increasing in value? So when we get to case 4, what we want to do is reset this probably to 0. So let's say range state cell equals 0. And what I'm trying to create is that nice cycle through these different states. And this should close the loop and should allow us to do this. Okay. Let's hit play. So case 1, case 2, case 3, case 4. Now we've reset to 0. Let's see what happens here. I'm going to step through and we're going to see the state cell increment here. And that's going to take us to case 1. Again, case 2, case 3, case 4, and then back to case 1. How cool is that? So a great way, I think, to begin to understand and use select case, and this is your toolkit. As I mentioned at the beginning of this section, you will hear about other conditional statements, you'll see other formulations, but you need no more than this. You've got your simple conditional statement, could be a one-line conditional statement, could be an if, then, end if formulation. You've got your if, else, end if conditional statement, takes us in 2 directions. You've got if or if, else, end if with multiple conditions. But we felt that things were getting complicated. We would have needed to articulate a lot of conditions. It would have been logically possible using if, but it's easier and tidier using select case. Yes, it's supremely versatile, powerful. This is your conditional statement toolkit in Excel VBA. In the next section, you might want to pause the video and try to do this yourself. In the next section, we're going to populate each of these sections with the commands, see if we can finally get our traffic lights working. So in the final section of conditional statements, we're going to look to complete the traffic lights challenge. Yes, can we get those traffic lights working beautifully, cycling through those states? And although we've completed our conditional statement toolkit, we've got a simple if statement, we've got if, else, and end if, and we've got the incredibly powerful select case. So the conditional statement toolkit is complete. We've got one more concept, one more idea to introduce, which is it's possible to call one macro from another. An interesting idea, perhaps. Why would you want to do that? Well, let's get back into the VBA editor and let's take a look. We've got our routine taking shape. There's 2 reasons why you might want to modulate out here. Modulate out would be the term I would use, perhaps, but we'd just take a chunk of code and put it in a different macro and then call that macro from what I'd call the parent macro, which is the main macro or routine that we're working through. You'd want to do that for 2 reasons. One, the routine is getting quite long. You know, it's currently manageable in length, but you don't want super long VBA routines. They can get very difficult to understand. And secondly, if we break out some code somewhere else, we might want to call it from a different macro. So if the code is modulated out, things become modular. So we can fit these routines together in different ways. So we're also going to cover that in the course of the next 10 minutes or so. But first, can we get these lights changing color and can we complete our traffic lights task? So case 1, I'm going to go ahead and find this code. So red is on, yellow is off, and green is off. Can we go ahead, can we just grab these commands here? And I'm going to overtype our message box because we don't need those anymore. So what do we want to do here? Wait state, red on, yellow off, green off. So this isn't quite what we want, is it? So red is on, so red needs to be VB red. I'm going to go ahead and reorder these into the actual order of the traffic lights, make things as easy to understand as possible. Let's put green at the bottom, Control X, of course, just using the cut here. Okay, so the red light is on, the yellow light is off, and the green light is off if we're in state 1, which is our wait state. And you can see we've only programmed one state and we've got quite a lot of code stacking up here. That's why it's going to be good to modulate out some of this code. We're going to do that in just a second. But we can recycle here. Control C and then case 2. Well, the red light is on. The yellow is on. So we need to set it to yellow. And then the green light is off. So the green light is okay there. And of course, we're going to test this. We're going to see visually very clearly if we've got this right or not. Let's go ahead and go for state 3. So state 3 is our go state, of course. So the red light will be off. Set it to black. The yellow light will be off too. Set that to black, and the green light is on. So let's set it to green. Okay, in state 4. So once again, benefiting from the notes, the annotations we've made, good practice to put those annotations in. You know, I have been teaching, you know, for some time now. So you have the mental strain that you'll get in a coding session. All of these things we've done to support our understanding, definitely helping at the moment. Finally, state 4, red is off, yellow is on, and green is off. So yellow needs to be yellow. I'm quite excited to see this. Hopefully it'll work. And then green is off, so green needs to be black. Right, do you think we've got all that right? And are you excited to hopefully see our traffic lights work? So how to do this? I'm going to go ahead and step through the code, Control S, save the file, hitting the F8 key. So the state cell is 2. So where are we going to go first? Well, we're going to go to case 2, skipping out case 1. And what's going to happen? Well, the red light is going to be red, the yellow light is going to be yellow, and the green light is going to be off. It's going to be black, and then we go to the end of the conditional statement. We don't go into any other conditions. These are mutually exclusive, if you like. Cool. Right, so I think I feel confident enough now. We've stepped through this a few times. We stepped through the basic structure in the last section. Now we've stepped it through with all of the syntax in. So I'm feeling quite confident. I'm going to go ahead, click in the routine, hit the play button. So green, what happens after green? We should go to yellow. We are going to yellow. What happens after yellow? We go to red. After red, we go to red and yellow, and then we go to green. So now I'm able to just click through, but we don't just want to trigger the macro from the VBA editor, right? We want to have a button in the spreadsheet, and we can say, well, firstly, what macro are we going to want to run? The change lights macro. So once again, benefiting from those informatively named macros, when you see them all stacking up, you can see why it's useful. I think it's change lights. And let's go ahead, edit the text. And let's say change here. Okay. Seems to be good and seems to be working well. So what will my critique be? What vulnerabilities are there here? Well, this state cell, as we mentioned, is absolutely pivotal to what's going on. It's a bit exposed there, isn't it? So the user could accidentally overwrite that. That would mess things up. So I would advocate putting this on a supporting sheet. Overall structure of Excel files is not something we've really covered in this series, but you will feel it out as you go through your VBA career. So I'd have something like an engine sheet, another sheet in the file called engine, which I'll probably hide from the end user. And that would be the perfect place to house this kind of cell that performs this kind of pivotal function to support VBA. So we mentioned there's a lot of code now. So how about creating some smaller macros to make this code easier to manage and to apply the principle of modulation, create some smaller macros that we might want to use from other macros. This is generally a good principle to follow. So how to do that? Well, what would the name of these macros be? Well, let's say red and amber, and yellow rather. So this is state 1 to state 2, I believe. And then the next state will be red and yellow to green. To green. So just know I'm creating separate macros here, and we're going to populate these with the commands in a second. Red and yellow to green. And then what happens? Well, it's going to be green to, it's just yellow, isn't it? Next, green to yellow. And then finally, we've got 4 states, yellow to red, which is our starting state, and that's our wait state, of course, yellow to red. There we go. Okay, so now we can manage this code more effectively. So what do we need to do? These commands, we're going to drop into each of these routines. I'm going to cut and paste here, so being very deliberate and very careful here. I don't want to lose any code. And then what do we say in select case? Well, I'm going to go ahead, select the name of the macro, Control C here. Going to go ahead, just drop it in. Now it does work just putting the name of the macro there, but for completeness I would say call to make it absolutely clear that you're calling a different macro there. So already it's looking less cluttered. Right, state 2, and this is red and yellow to green. Red and yellow to green. Is that correct? Oh, that's not quite right, is it? Red to red and yellow. No, this isn't quite right. So this should actually be here, I believe. Yellow to red. So this is just the red light on. Yep. This is red light is red, yellow light is yellow. Yep, so this should be the first one, I believe. And then red and yellow to green. It's this one. Drop this code in here. So once again, I'm cutting and pasting. You could copy and paste, which would be a less risky approach. And let's go ahead. Drop this code in here. And then we need the names of the macros, of course. So red to red and yellow. Well, I think that's probably wrong. That should be yellow to red. So I've just slightly got the state concept wrong in my mind. And this is something that would have become abundantly clear had we started actually testing this. But case 1, wait state, yes, red is on, yellow off is green, and green is off. That's what we do in the yellow to red macro. So state 2, red to red and yellow. Red on, yellow is on. So once again, we don't need the brackets. We want to call this macro. And case 3, yellow off and green on. Green on, so red and yellow to green. Then finally, green to yellow, I believe. Yep, so call green to yellow. Okay. So it's instructive now to step through this code so we can see this principle of modulation in action, calling one macro from another. Yes, that was quite mentally taxing for me to work it all out, but we can see this macro is looking much simpler now, much easier to understand the overall structure of the macro because we've decluttered it by breaking out some of the code into different routines. So I'm going to go ahead, hit the F8 key here. So the state cell is going to increment. I'm going to go to case 2, red to red and yellow. So now just see what happens. Going to hit the F8 key and we've jumped all the way down to that macro. And we're now coloring our shapes, and that does seem to be okay. I'm going to go ahead, run this again. So we're now going to state 3, red and yellow to green, and we can see green coming on there. Okay, so feeling reasonably confident now. So let's go ahead and play this macro a few times and let's see that code working beautifully. And that's the principle. That's a principle of modulating your code out, simplifying things, decluttering things, and all of these routines you might want to call from a different parent macro, so it gives us more flexibility. This is the idea of modulation. So there it is, guys. There are your traffic lights. As I said, make sure you impress your significant other with this, people in the office, whatever it might be. But I just want to address one point before we go, which is you might say, yeah, well, that was kind of fun, Chris, messing about with the traffic lights, but that's not something I'll do in my day-to-day work. Yeah, and you're right. That's unlikely you would have to do that in a professional situation. But the structures that we've learned here, the easy if statement, if, else, end if, and then select case, these three coding structures are all you need to do whatever you need to do with conditionality in Excel VBA. And yes, you might not be creating traffic lights, you might be creating reports, doing any of the infinite applications of Excel VBA, but the structure, the blueprints are going to be the same. And if you're thinking, Chris, I'm dying for a real world task, I feel your pain. We are moving on to a real world task. In video 5, we're going to touch on advanced position control using offset, but we're going to bring everything together. We've got a briefing that's very similar to the real world task that I'm doing every day here at Tiger Spreadsheet Solutions. That's all in video 5, but it's been an absolute privilege bringing this powerful stuff to you guys. As I said, I first learned this 15 years ago at Warwick Business School using exactly the same example. I found it powerful to bring things together for me. I hope to some extent it's helped you, and I hope it helps you move forward with VBA in your career. I'll see you in video 5. Hi everybody, Chris here. Welcome back to Excel VBA for Beginners. And yes, this is video 5. It's the last video in this series, and our topic is position control and offset, as we can see. But we're doing more than just looking at another technical topic. In this video, we're undertaking something akin to a real world task, the kind of thing I'm doing all the time in my job with Tiger Spreadsheet Solutions. We're going to undertake it, do it together, and hopefully it's going to bind together everything we've learned in this series. We're going to see all the tools working together and give you the confidence to go ahead and do real world VBA development and have an impact with these VBA skills that you've learned. This is the aim in the next hour or so. So with that said, let's get into the slides and let's look at a quick outline for this video. So Chris Cohn's Traffic Management. Have you heard of this company? Well, it's a big topic here in the UK. Seems to always be problems with traffic, but Chris Cohn's is a fictional company, but they have given us a data set and we've got to do a job for them. We're going to get to that in a second. So we're going to have to interpret a real world briefing. And this for me is when VBA starts getting exciting, because the technical stuff is great. I love those punch the air moments when a loop or a conditional statement finally works. But when you actually start creating value for real people in the real world, that's when you get the real punch the air moments. And that's why I've become addicted to VBA and helping people with it over the past 2 years. So a real world briefing. We're going to learn how to structure a task. Yes, remember the Excel Metaskills we mentioned right at the beginning of this series, to be able to conceptualize. So understand what somebody's looking for, and then to be able to translate that into the main techniques that we need to get the task done, and then to be able to write the commands out in pseudocode in your own language rather than VBA. This is all part of structuring a task, and we're going to do that first before we even get into the VBA Editor critical skills for the modern VBA developer. We're going to build the solution step by step. We're going to test the solution. Another meta skill, as we know, is experimentation and debugging. I'm sure there'll be some of that along the way. We're going to look at dynamic user communication. Yes, you might have the most sophisticated VBA routine in the world, but if you can't communicate with the user, if it's not clear the value you're creating for the user, it doesn't really matter. So how can we really communicate in a crisp and clear fashion and get the user saying, wow, this is amazing? Dynamic user communication is coming. Advanced position control with offset. Offset we've touched on a few times, but we haven't unleashed the full power of offset. We're working with dynamic data sets in this task. We're going to really solidify that understanding and see it in action. And working across workbooks and worksheets, this is a common thing you have to do in VBA development, because often you have one file with the code in and you want to interact with other files, as we're going to see in just a second. So all the things we're going to be doing in the next hour or so. So the briefing, Excel VBA development for Chris Cones. We're having problems with our temporary traffic lights. The timing of the lights is inconsistent and motorists are complaining. Sounds scary. Every day we receive a new Excel download file with the previous day's data. We need to look through the data to find when the green traffic light, yes, it's the green traffic light. Well, rather, when the traffic light flashes green, I think that's what Chris Cones means. We need to find when the green traffic light has not stayed on for the correct time. It should be 10 seconds. This takes us ages to work all this out, a different Excel file every day. Can you automate it for us? So how does that sound? So it sounds like they've got a traffic light, and we know we can visualize a traffic light in Excel with Excel VBA, but that's not what we're doing in this task. And it seems to me the green light is on, but it's staying on for too long. And this is causing a problem with the sequencing of the traffic light, and motorists are complaining. So take a second to have a look at the download file. You should be able to find it with your resources, and it looks something like this. I'll just full screen this quickly. So what have we got here? Well, in column B, we've got these states. So we're already familiar with the concepts from the last series of wait, get ready, go, and stop. But just to make absolutely clear, Chris Cones has included the status of each of those lights. So which state are we interested in? Well, we're interested in this go state. The go state here. This go state, Chris Cones has said is problematic. Why is it problematic? Because the amount of time the green light is staying on, the amount of time in this go state is apparently too long, or rather, sometimes it's too long. So our specific task is to go through the data and find the instances when this go state is too long. What does that mean? Well, we know the target time is 10 seconds. So we can see data point 3 here on row 4 in the Excel spreadsheet, 9 o'clock and 22 seconds to 9 o'clock and 32 seconds. This seems absolutely fine. But Chris Cones has told us there's a few instances in the data where it's not fine. So how can we do that? Can we just start to get the mental juices going, start to get the cogs moving? How might we do that with Excel VBA? We'll get into conceptualization stage 1 and 2 in just a second, but there's more. There isn't just one data set here. There's 3 data sets from 9 o'clock, 10 o'clock, and 11 o'clock. And very quickly, a good idea when you're given client data is to look through all of the data. So I'm going to go control and down arrow. I just want to know how many rows even are there in this data set. And is the data set contiguous? So if I go control and down arrow again, I've got to the bottom of Excel. So I'm confirming this is all the data. We've got 420 rows there. Onto the next sheet. Hopefully it's the same size data set, because then we won't have to think about dynamic position control. Unfortunately, it's not. We've got an additional row here. So with position control, perhaps with offset, we're going to have to dynamically tell Excel what data to work through. And on the next sheet, we can see we've got much less data here. Here we've got 160 rows. So we've got to loop through this data set, this data set, and this data set. We've got to find all of the go states, and then we've got to check for each go state, is it lasting 10 seconds? Well, we're already well into the conceptualization of this task. Yes, I'll keep saying it. It's an Excel metaskill. It's so important. If you're strong at conceptualization and a weaker programmer, you're going to have more impact in the real world than somebody with the reverse skill set. So structuring a VBA task, conceptualization comes first. And there's 2 stages to it. I call it conceptualization 1, conceptualization 2. Firstly, what are the main mechanisms required? You're like, Chris, mechanisms? What are you talking about? Well, I know what's in your VBA toolbox from the Excel VBA for Beginners series. So what have we got? We've got working with cells and ranges. We've got loops. We've got conditional statements. We've got dynamic position control. We know the requirements of the task. So now you become a translator or an interpreter. Yes, as I've said previously in this series, in a previous career, I was a Japanese to English interpreter over in Tokyo. Unbelievable. But I've come to realize being a good computer programmer is an interpreter. You're looking at the real world and you're finding all the good things in computer programming that could help people in the real world. So what are the main mechanisms required? Well, I'll recommend you pause the video, try to do this yourself. But what do we need to do? Well, we know we need to cycle through multiple worksheets. There's not just one worksheet in that file. There's 3 worksheets in there. In the real world, not the world of Chris Cones, you'll probably have 24 sheets in the file. Why is that? Because the traffic light will be working 24 hours a day. So we want to do the same thing to multiple objects. So what do we need? We need a loop to do that. Yes, this is conceptualization 1. On a very basic level, what from our toolbox are we going to be using here? So we need one loop, but we need to do more than that because we need to cycle through multiple rows. So we're going to need another loop. So this is going to mean a loop within a loop structure. Might sound scary, but because we go through the conceptualization properly and then we build it step by step in Excel, nothing to be scared of, just awesome programmatical power with Excel VBA. What else might we want to do? Well, we've established the data sets are different size. So unfortunately, we can't just have a static data range work through A1 to A400, whatever it might be. We need dynamic range definition. We've done that a long time ago in the series, so we're going to bring that back. Advanced position control. So whatever data's in there, our routine is still going to work. How cool is that? And then we know if we find a go state, so we're going to loop down these rows, but one by one. If we find a go state, we need to do something. So it's an if logic. So that means a conditional statement. And you can do more. There's probably 3 or 4 more main features in the requirements that you could easily pair up with something from your toolbox. So I'm inviting you to begin that now. So conceptualization 1, I always say, do it with a coffee. You know, like most boring middle-aged men, I'm into running. And they talk about the power of running at conversational pace, zone 2 running, they call it. So it's just gentle running, doesn't stress your body too much, and it really gets you fit without getting you too tired. This is the idea. Conceptualization 1 should be in zone 2. It should be like conversational pace running. You should be able to do it with a coffee. You shouldn't be working really hard. That's because we're not in detail mode yet. We're still very much in real world conceptualization land. Do conceptualization 1 with a coffee. It will keep you in the right mindset. Conceptualization 2, pseudocode. So the next step is to go to the next level of detail and to write out the commands in your native language. A lot of English speakers here, my native language is English. So I've done it in English. Now, once again, I invite you to stop the video here and take the next step. Now, this is tricky, but it's going to be less tricky because you've already done conceptualization 1. Now, what I'm going to do, I'm going to grab these from my slides, and to make sure we get into VBA land, I'm going to go to our master file and bring in the VBA Editor 2, and I'm going to drop my pseudocode straight into the VBA Editor, and it's going to look like this. So I'm going to comment all these out using the inverted comma. And what does this give us? This gives us a blueprint for our VBA solution. Yeah, it's a complex problem, relatively complex that we're dealing with, but we have some super powerful, flexible, sophisticated tools at our disposal. So the actual routine to get this job done is not much more than 15 or 20 lines of code. Let's go through the main features. Now, so we're going to need a loop through the 3 sheets in the file. We can go back to conceptualization 1. We established we need this loop. So this loop is starting and then it's ending here. So it's not just about getting the language right. It's also about getting the structure right. You can see with the indentation, we have made the main structures in the code clear. So we've got to loop through the 3 sheets in the file. We need to get the last row on the sheet that we're looking at. We know the data sets are of different size, so that's something we're going to have to do. And now it's the loop within a loop, because on each sheet, we want to loop through each row. So we've got to start that loop. What do we do if we start a loop? We don't want to be here forever in an interminable loop. We want to end the loop too. Now, if this is a go state, then a go state row, then we want to do something. So this is our conditional statement, starting it here, ending it here. So if we are on a go state row, we want to get the time period for this state. How many seconds is it? If that time is not 10 seconds, there's the keyword if. If that time is not 10 seconds, we want to do something. So we want to open a conditional statement there, end the conditional statement there. And then if that condition is met, we've found not just a go state row, we've found a go state row with the incorrect time. That's exactly what our customer, Chris Cones, wants. We're just going to flash up a message box. And we want this message box to say, on this worksheet, on this row, we have found a problem. Okay, so before the next section, could you take Conceptualization 2? Could you take our pseudocode and just start translating it into the VBA code we need? Yes, because we've done the conceptualization phase, all we need to do, famous last words perhaps, but all we need to do is translate each of these lines of code into VBA. That's the power of conceptualization. That's why you need to structure a task before jumping into the VBA editor. That's what we're going to do in the next section. I'll see you then. So we've completed the all-important conceptualization phase. I've set out on this slide the way we're going to execute this task. So our next job is to set up a mechanism to reference another file. Let's see if we can do that first. And then in the other file, we want to loop through each of the sheets. Yes, we know from our briefing that this is one of the basic requirements. So back into our master file, the first thing we want to think about is referencing another workbook with Excel VBA. So why would we want to do this? Well, we know from the briefing, our customer is having a new download file every day. So we want to think, where is the VBA code going to live? We know VBA code lives in an Excel file. Well, it's not going to be in the file that they download every day from their system. So the way our mechanism will work, we'll have a master file that can sit on somebody's PC desktop. They can then download the Excel file and get it interacting with the master file. Yes, this is why we need to be able to reference another workbook using Excel VBA. So let's go into our master file. By the way, this master file, there's no code in there. It's just a new Excel file with the VBA editor open. You can see we've got 2 files open. I've got the Chris Cones data file too. So we know we have to be careful about which file we're currently working with. I'm in module 1 in the master file. Now I'm going to go ahead and call this CC underscore solution. So Chris Cones solution here. So let's go ahead, Alt-H-O-W. 30 and hit the F4 key, Alt-H-O-W-3 here. Let's get those keyboard shortcuts accurate. So we want a place to input the name of the workbook that we want to work with. Sounds cool. So I'm going to say name of download file. And then what we want to do here is input the name of the file we want to work with. Now, it's called Chris Cones data on my system. Something to bear in mind, your system may or may not need the file extension. Now, I found this is a genuine kind of system-to-system difference with Excel VBA, so try both ways too. So try both ways here. Going back to our blueprint, our pseudocode, well, we need to create a routine here. So I'm going to say sub, and let's say, I'm just going to call it find green problem, because we know there's a problem with the green lights, and an informative name for macros is definitely the way to go. The end sub command, well, that's got to go at the end of our code, of course, so I'm just going to cut it down here. So specify the workbook to work with. So we need a way of getting the name of the workbook from the worksheet into the VBA editor. How to do that? Well, we need a place to store information. So how about a variable in the VBA editor. So I'm going to say target workbook, just target WB will do, as string. I'm going to use a string variable here. We know a string variable holds text, so it's going to hold the name of the workbook in there. There's other ways to do this with object variables. I generally recommend using string variables to do this, certainly for beginners, to keep it simple. We're going to say target workbook equals, and then to get started, let's just say range C3. So to begin with, we're going to assume that this workbook is the active workbook. Later, we're going to introduce a mechanism that will keep it working even if this workbook isn't the active workbook. And then we need to activate the file that has this file name. So how to do that? Let's go for workbooks. Now we can use the variable name .activate. So how about this? Control S, save the file. So what would we expect to happen? We'd expect this data from C3 to get into the target WB variable, and then for that workbook just to activate. So how do we test? Excel VBA, I'm going to hit the F8 key, step through. So I can now hover over the target WB variable. I can see it's storing data, hit the F8 key, and we can see the Chris Cones file flashing up there. The Chris Cones file has become the active file. So I'm happy with that so far. One thing to bear in mind is this. So what's going to happen if Chris Cones is the active file and I just hit F5 and run this macro? We're going to get this subscript out of range error. Why is that? Well, because we haven't managed the active file here. Excel has taken C3 from the active file, which at the moment is Chris Cones. So it's looked for a file called off, and no such file exists. That's why we got this error. So I'd invite you to use this workbook.activate. What does this workbook mean? It's not something we've seen so far. So this workbook, a very useful line of VBA, it means the workbook containing this code. So just keep an eye on things now. Hit the F8 key. This workbook.activate there. Now we should be okay. I'm going to hit the F8 key. Just keep an eye on the left side of the screen. We should see our other workbook flashing up as the active workbook. So that's a mechanism to guarantee, hopefully, that we always start in the right workbook. Okay, so we know we can interact with our target workbook, which is the Chris Cones data. So now what do we want to do? Well, we know we've got 3 data sheets here. So our next challenge is to loop through the 3 sheets. Really powerful stuff, this. Working with another workbook, looping through all sheets in the workbook. So how to do that? Well, I'm going to do this using the sheet index number. So we're going to say sheet counter. So as usual, an informative name for the variable, and this is going to be a whole number variable. Yes, we're going to use the index number of the sheets to reference the sheets. So dim sheet counter as integer. We've activated the workbook here, and then I'm going back to my blueprint. I was supported there. I lost the thread mentally. I was supported by the pseudocode. Start loop through 3 sheets in the file. So I'm going to say for sheet counter equals, I'm just going to say 1 to 3 to keep things simple. This 3 is not dynamic. This is a static coding element. You could use worksheets.count to loop through all sheets in the file. So 1 to 3 is going to loop through the sheets in the file. What have we got to do? If we've opened a construct, we've opened the loop, we need to close it. So I'm going to say for next sheet counter, and you'll notice this basic blueprint is the blueprint we saw in the loop session. It's the blueprint we've seen several times in this series. Yes, VBA is just stuff repeating, enforcing the patterns in your head, getting on that exponential improvement curve. I love it. Come on then. Right. For sheet counter equals 1 to 3. So we now need to prove we're looping through these sheets. How might we do that? Well, you could activate each sheet like we activated the workbook. Let's go ahead and just get the name of the sheet. So I'm going to say sheets sheet counter. Now, what's this variable holding? It's an integer variable. It's holding 1, 2, or 3. So if we say sheets 1, it's going to reference the first sheet in the file. But don't believe me or don't believe the code. Make sure you practice yourself, experimentation using the F8 keys. Once again, I'm going to hit F8. Now, because the Chris Cones file is active, we're going to see our mechanism to ensure we're starting in the right place, working again. And this is stuff we've looked at previously. So for sheet counter equals 1 to 3, message box sheets, sheet counter.name. Interesting. We should be okay because the target workbook, the Chris Cones file, is active. Going to hit the F8 key. So it says 900, representing 9 o'clock in the morning. And that is indeed the name of the first worksheet. Going to hit the F8 key. We're going to go back to the top of the loop. We're going through this loop 3 times. Hit the F8 key, and now 10 o'clock there. And then one more time, hit the F8 key, and 11 o'clock there. So far, so good. I was helped a lot by our conceptualization, by our pseudocode. You can see how we're just building out this routine. You know, shouldn't be stressful. Stay in zone 2. Try to stay at conversational pace, building it up step by step. Some of the most complicated mechanisms are already in. Referencing another file seems to be working well. Looping through the sheets seems to be working well. Still plenty of work to do. Next, we'll look at how to use position control dynamically to define the data range on each sheet. So we're working through our task step by step. We've set up the mechanism to reference another file, and we're looping through the sheets in the file. Next, we've got to define the data range to work through on each sheet. Yes, here we're going to consolidate our understanding of advanced position control. So with that said, back into the VBA editor and back into the workbook. So defining that data range dynamically. So let's just remind ourselves what the situation is. Well, each sheet has a different number of rows. So we can see here, we're getting to row 421. Now, this is a very common situation. With data, you have a reference attached to the data that isn't the same as the row number. So for example, here we've got reference number 420 on row 421. Just something to be aware of when we're in the VBA editor. First sheet, row 421. Second sheet, row 422. The third sheet is row 160. So how can we use the same VBA routine to work for these differently sized data sets? Okay, back into the VBA editor. We're going to be holding that piece of information, the last row on each sheet. We need a place to store some information. We could use a cell in the worksheet. It's easier, more convenient to use a variable in VBA. So we're going to say last row as integer. I'm happy with an integer variable for this. What if we had thousands and thousands of rows of data? Precisely, if you had more than, I believe it's 32,000 rows, you'll need a long variable here because integer only goes up to about 32,000. Let's use long, which means this would work for larger data sets too. So dim last row as long. So we then need to think about how can we define last row? So last row equals. And let's go ahead and do this. So sheets 1, various option here. I'm going to start with our most obvious option, which is to reference A1. And we can then say dot end Excel down, which we have encountered before, of course, in VBA for beginners. So this underscore here, this is just because I'm short of space. You won't need to use this space and underscore in your VBA editor. So how about this? Well, we don't need this line of code. I'm just going to clear this out, keep things lean and mean. I'm also going to correctly position this line of code below our annotation. Let's keep things nice and consistent. So how to test this? I'm going to go ahead and use a stopping point this time. This means when the code gets to this line, it's going to stop. I'm going to go ahead and click play here. So what are we expecting to happen? We're expecting the value of 421 to get into this last row variable. Remember, when the line of code is highlighted, it hasn't yet executed. So we can hit the F8 key now in the VBA editor. that line of code has executed, and we've got the value of 421 into that last row variable. Seems to be working okay. I'm going to play it again. We're now on the second sheet in the file. We've got the value of 421 into the variable. Is that accurate? That should be 422. So did we properly step through that? Let's see. 421. Okay. Yes. Can you see the mistake I made here? So this variable kept picking up 421 here. That's because we're working with the first sheet. So what do we need to do? What's the critical change we need to make here to make sure this row is looping through the sheets? We do, of course, need to use the place where that information is being stored in the routine, which is the sheet counter variable. And to speed things up here, let's use message box again. I'm going to say message box, last row, hit the F5 key. We're going to go 421, 422, because we know there's a difference from the first sheet to the second sheet, and then 116 for the third sheet. Seemed to work well. Okay, so would you use this construct? What are the pros and cons here? We're talking about advanced position control, so what are our options? This works if you can guarantee your data set is contiguous. So contiguous means you don't have any empty rows in your data set. If you had one empty row in your data set, you can see I've just cleared cell A8 here. What's going to happen? I'm going to hit the F5 key again, and you can see this construct stops at, if there's an empty cell, it's going to stop at the first empty cell and it's returning 7 there. So my approach is, rather than going from the top down, which means we're vulnerable to this case where we have a blank cell, I'd recommend working from the bottom up. So how to do that? We can say .cells rows.count. And then we're familiar with the cells technique from earlier in the series. So cells needs a row number and a column number. So yes, let's use column 1. And rows.count is going to take us to the bottom of the spreadsheet because it's counting all the rows in the spreadsheet. And then we can say .end Excel up .row. So what's going to happen now? Well, effectively, we're going to get the same result in a different way. And for me, in a more robust way, because we're now accounting for situations where you might have non-contiguous data. You might have some blank cells. I'm going to hit play here, 421, 422, 160. The results are as expected. Let's clear this cell again, and let's just show why, for me, this is advanced position control. This position control technique is a slightly superior. We can see we've now got 421 because this technique is working from the bottom of the spreadsheet, so it doesn't matter if there are blank cells in the data set there. Cool. So advanced position control. This is how to work with data sets that change in size. But we're not there yet because we've got the last row, but we need to do more than that, don't we? We don't just need to tell the customer what the last row is. We want to work through each row. So how to do this? Well, we mentioned a loop within a loop. So let's go ahead and implement that now. We're already counting through sheets. Now we want to count through rows. I'm going to use the long variable again. Let's make this routine as robust as we can. And now we can use row counter to start our loop. Once again, I'm being supported by our notes here. Start our loop through each row on the target sheet. So for row counter equals, well, what row do we want to start on? This again is a tricky thing just to look out for. Do we want to start on row 1? Probably not. As I said, it can be confusing if there's sequences or referencing data in your data set. We want to start on row 2. Row 2 contains our first row of active data, if you like. So for row counter equals 2 to what? We could say 2 to 421. 2 to 421. That would work for the first sheet, but this is a static, not a dynamic approach. We're talking about dynamic position control here. So we can say for row counter equals 2 to last row. And we've opened a loop, so we want to close this loop. And because, once again, because of the annotations, it's easy for me to position this. Certainly vertically, I'm struggling a bit with the horizontal positioning there, just trying to get them lined up perfectly. And now we want to say next row counter. Okay. So how to test this? Well, I would say a word of caution here. Because we've now completed this loop, it's going to loop through hundreds of times here. How many times is it going to loop through? Well, maybe we could test that. How about testing that? Let's have I'm going to say row tally here. Row tally is long. I'm going to use this variable to test how many rows we count in total, because I want to be sure we're counting through all the rows on each sheet. How to do that? Well, I've just created a row tally variable, and then we're going to use a very simple A equals A plus 1 concept, row tally equals row tally plus 1 to increment this variable. And then by the end of this routine, this row tally variable should tell us the total number of rows that we're working with. If I type in message box there. So this is one way for us to test the loop, working through this step by step, testing as we go. We're certainly not leaving all the testing until the end. So before we test, let's save the file. I'm going to click play. And there we go. Row tally equals row tally plus 1. Let's try one more time. So we've got 1,000. Interesting. So what's happened there? And why have we returned a value of 1,000? Well, on the first sheet, we have 420 rows of data. I'm just going to add these numbers up here. Second sheet, we have 421 rows of data. I'm just using the count at the bottom of Excel here. 41. And then the third sheet, what was it? Can you remember? I think it was 160 rows of data. 159 to be precise. 159. So when we add these numbers up, what should they total? And they total 1,000. So this is a very common way to test and build confidence in VBA structures, to do things two ways, to do it in the VBA editor, and then to do it in a more manual way, perhaps using formulae or doing what I did there, inputting numbers to the spreadsheet to prove that what we're doing is accurate, to do it step by step, to not do it all at the end. That's the approach we're taking, trying to keep the stress levels down, moving towards our VBA solution for Chris codes. Now, have you ever worked with dates and times in Excel? Well, if you have, you'll know it's always quite kind of tricky working with dates and times in Excel. What's our next task as we're working through our job for Chris cones? It's to do these number of seconds calculations. So for me, even as an experienced Excel person, I have a degree of trepidation here. And this is very common. When you're doing Excel tasks or VBA tasks, you get to a part that's kind of tricky, often a part that involves some calculations. There's some things we have to be aware of, and there's a particular way that we can work through calculations to make sure we don't get into a mess in the VBA editor, and to keep us progressing steadily with our tasks. So let's get back into Excel. Now, the basic idea is if we're going to do something complicated, let's do it outside of the main routine. So we've got our main routine here. This routine is already pretty sophisticated. It's going to a workbook, it's going through the worksheets, and it's going through all the rows in each worksheet. So this is now not a good place to test a calculation. So what's the best way to do this? The best way is to create a new routine, a kind of safe space for testing, and then to test it in there, and then we can subsequently drop the calculation, integrate it into the main routine. So we're going to have a new routine here. This is called time test, and this is going to help us work out the number of seconds for each stage here. So we know in our data we've got the start time and end time. It would be great if they provided the duration for each of these, but they haven't. So we need to calculate it. So if we were in kind of normal Excel world, it would be fairly straightforward to find the difference between these cells. So I'm just subtracting the start time from the end time. That's given me 20 seconds. And we know for this stage here, this state, the go state, this is what we're interested in. in, this one is accurate, this one is 10 seconds. We need to flag up the instances where it's not 10 seconds. So it would be easy if we could download the workbook every day and input these formulae ourselves manually. It would take time, but that would be one way to do it. We can't do that. We can't do that. We've got to hand this over to the customer. So these calculations, we've got to find a way to do them in Excel VBA. So how to do that? Well, we've got our safe space to do some experimentation, and let's see how we get on. So let's start with F2 and G2. And let's just see what happens if we do a simple calculation here. Where are we going to store the result of this calculation? Well, let's have a result variable. I'm going to go ahead and call this a double variable. We know a double variable holds a decimal. It holds a decimal. Why is that important? We're going to see in just a second. So result equals, and we want to subtract the end time from the start time. So range G2 minus range F2. Now for completeness, we could say F2.value, but the value being the default property, we don't absolutely need it. And then can we just say message box results? And let's just see where this gets us to, because I have a feeling, because we're talking about times and dates, it's never simple. That's why we've got to work through it step by step in a safe space outside of the main routine. So what on earth does this mean? Not absolutely sure, to be honest. Well, this is a tiny number in Excel when it gets a very small number. So what's happening here? Well, it is returning a value of 20 seconds, but it's expressing that in a particular way. And this is just how Excel works. It expresses times as a fraction of the whole day being 1. So 1 hour is expressed as 1/24th, and seconds are expressed as even smaller fractions than that. So how can we do this? Well, we need to work out the number of seconds in a day. So we've got 24 hours, we've got 60 minutes, and then 60 seconds. So if we multiply these three numbers together, 24 multiplied 60 multiplied by 60, that gives us 86,400. So this tiny number that we've got in our result variable, if we can multiply that by the number of seconds in a day, we're going to get a result in seconds. So does this get us any closer? And let's put these in brackets and let's multiply them by 86,400 here, which is the number of seconds in a day. So you learn something new every day on Excel VBA for beginners. And let's play this. And this looks much more reasonable, doesn't it? This is the result we were expecting, because remember, we've done this a different way already using a formula in the spreadsheet. So we've got just over 20 seconds. Now, this is another quirk of working with times and dates in Excel. They just don't seem to line up perfectly, but this is a tiny fraction. So what I'd recommend we do in this case, we just say round. We've got a round function in VBA. We've got to open the brackets, and then how many decimal places do we want to round to? Well, we want to round to a whole number here. So we can now press play again, and we've got 20. So we've rounded to that nearest second, and we've got a nice clean number that we can work with. This is our result. So we're getting closer. We've managed to work through the main complexities of times and dates here. But we need to do a little more. I'm now thinking, how can we integrate this? Well, we're looping through all of the rows here, and we're going to loop through an anchor column. So what does that mean? Well, we're going to loop through column A, for example. That means we need to reference the start time and end time from an anchor point, which is the first column in the spreadsheet. So how to do that? Rather than using these hard-coded references here, let's try this. I'm going to say with range A2, of course, because A2 is where the data starts. And then I'm going to say end with here. Now this with end with syntax, it means whatever is written within this construct, if we have a dot before it, it automatically connects to A2. That's not a great explanation, don't worry. We'll see how it works in just a second. So rather than using these hard-coded references, we can now use a position control technique to reference these cells. What are we going to use here? We can just say dot offset. So with offset, we know the first number is going to take us a number of rows down. The second number is going to take us a number of columns across. How many rows down do we want to go in this case? Well, we want to stay on the same row, but we do want to move across a number of columns to get us to the end time, because we want to subtract the start time from the end time. So that moves us across 6 columns there. So if I say 0, 6, this should do the job. And then the same thing for the other side of the subtraction. So dot offset, that dot is important. The dot is what connects the offset method to the object here, which is A2. And then dot offset, I think I need 2 brackets here. I think so. Let's see. Yeah, 0, 5 it will be. Too many brackets maybe? That seems to be working okay. Right. Just to confirm this, I'm going to put a message box in first. And I'm going to say dot offset 06 address. This is just for testing, just to help me build confidence that we're looking at the right cell here. I'm going to use the F8 key. And it says G2. So G2 is the cell, it's the end time. So I'm happy with that. It seems to be accurate. Then I'm going to hit the F8 key and then result. That's not quite what we wanted. Interesting. So we're going to have to work through this step by step. And I think it might be to do with... okay, right. What if we put dot value in here? Do we need to be more specific here? I'm just going to work on a new line. And let's put dot value in here. Okay, this needs to go here, I believe. Then if we subtract, it's just going to work. Hit the F5 key, G2, minus those 2000. Okay. It must be to do with these brackets. I think I might have lost a bracket there at some point. Let's try this. Let's put those brackets in again. Let's hit play, G2, and we've now got 20. Okay, so when I make a mistake, I always like those mistakes to be kept in the videos, because that's just how you work through it. It's a meta skill, being able to respond positively as you can to those error messages. Just keep experimenting, stepping through trial and error. This is how we work through it. But this seems to be working, and we've seemed to have a result that's going to help us. So the next step is going to be to integrate this into the main routine, and then we're going to be pretty close to completing this task for Chris Cones. So we've managed to deal with those tricky seconds calculations in this section. We need to integrate that code back into the main routine. Then we need to do more than that. We need to integrate some conditionality here, because remember, if that green state doesn't equal 10 seconds, we need to flash that up to the customer. But what do we want to say to the customer? So we've got to think about that dynamic reporting too. We want to give them the sheet. We're going to give them the row. This is what we're going to try to do in the next 10 minutes or so. So with that said, let's get back into the Excel file and let's think about how we're looping through this data, because we have this code that's ready to go. But this code uses an anchor point. An anchor point, that's what we saw when we did our safe space testing in the previous section. So we need to set up a similar anchor point in the main routine. That means we should be able to fairly easily integrate, although these things are never easy, fairly easily integrate the code that we created in the previous section. So with that said, let's use a with statement here too. And then what syntax is going to work here? Let's use exactly the same syntax. We're going to say, let's be specific about the sheet 2. So we're going to say sheet counter dot range. We're going to say A1. And then when we create that with statement, we want to close that with statement too. Now, I don't specifically have an annotation related to this, and end with there. So for end with, we're going to say with cell A1 on each sheet. There we go. So I'm interested in testing this, but I think it would be better for us to put this line of code. I'm going to cut this and let's put it, let's put this construct just above the line of code where we work through the loop and making sure the other part of this construct, the closing part of this construct, yes, we're going to put that just here, just below our row loop. There it is. Then I want to update the indentation to keep it as consistent as possible. Good. So we've established a kind of anchor point, and now we want to move away from that anchor point by a certain number of rows and a certain number of columns. This row tally variable we've used for testing. We don't need it anymore, but I am going to do something now. I'm going to do something as a kind of safety net to stop us getting into a loop that we wouldn't want to be in for a really long time. I'm going to say row counter equals 2 to 3. Later, we can bring back that last row variable. This means that we're not going to get in a situation where we're looping through hundreds of rows in testing when we don't want to. Okay, so let's go back to our calculation, which is down here. So our next job, we've established our anchor point, is to try to integrate our calculation. So firstly, we need to redeclare this result variable at the top of this routine too. So I'm going to say result as double here, which is the exact same syntax we used before. So result equals. So this should work because we've created this in the same structure, the same column structure on the other sheet. This should work. So I'm tempted to just go ahead and test. Now, because we've controlled the row, I feel fairly confident just going ahead and testing this. So if I say message box result, we should have the message box flashing up 6 times. Why 6 times? Because we've got 3 sheets. And we're working through 2 rows on each sheet, and we can then check the times and see how we're doing. I'm going to go ahead, Control S, save the file, hit the F5 key. We have a type mismatch here. Okay, so dot range A1. Okay, can you see the problem here? So we've started at A1. In our previous routine, we started at A2. So what Excel has tried to do is tried to subtract text, tried to subtract start time text from end time text. That's not going to work. So once again, we need to integrate the variable here, the row counter variable. That variable initially carries a value of 2. So let's just subtract 1 from this, and that's going to offset, that's going to move us down by 1 row. Okay, we could maybe change the value of row counter. I don't want to get into that because that's all been tested and calibrated previously in the series. So let's go ahead now, hit the F5 key. So we have 22, 22, 2, and 10. 0 on the end there. Okay, let's see why we had 0. So 20 and 2, that seems to work. Then the second 2, we can go ahead and put these calculations in. So the end time minus the start time, 20 and 2. And the same thing here. So the end time minus the start time, and 2 and 10. And then we got a 0. I'm not sure why we got that 0 at the end. Okay, let's go ahead and hit play here. So 20 and 2, that's from the first sheet. Our values from the first sheet, that makes sense. 20 and 2 are our values from the second sheet, that makes sense. And then 2 and 10 are our values from the third sheet. That makes sense. Now I've just realized where this 0 is coming from, because we still have our message box row tally line of code there. We can go ahead and delete that. Okay, so we've taken that tricky result calculation, we've done it in a separate macro, we've now reintegrated it, and we've done a limited test with some safeguards on it to ensure that we don't go through too many rows. And it seems to be working okay. So now we want to be thinking about conditionality, because we want to do something if a certain thing is happening. Now, what are the conditions? The conditions are as follows. If this row is a go state, we want to do something. And then if the time period is not 10, it's a go state, and the time period is not 10 seconds, we want to do something. So there's two conditions. We've articulated this in two separate conditional statements, and I can go ahead now, just update my routine so it's better aligned with my blueprint. So this is the line of code to get the time period for this state in seconds. I'm using the tab key just to line it up as best I can there. And then we've got our conditional statement here. So start, if this is a go state, how are we going to articulate that using the conditional statement, using the syntax? Well, we can say if dot offset 0, 1 equals go. If dot offset row counter 1 equals go. Equals go then. And of course I put go in the speech marks there because we're talking about text specifically. Then we need to close this conditional statement. So once again, benefiting from our annotations, benefiting from our blueprint here, we can say end if here. Good. So that's one conditional statement. Let's go ahead and test this conditional statement now. So what would we expect to happen? Well, we don't have a go state on the first worksheet, not in the first 2 rows. Remember, we're doing a limited test here with just 2 rows. What about on the second sheet? Do we have a go state here? No. And on the third sheet, we do have a go state. So given that we're only working through rows 2 and 3, we should get into this conditional statement once on the third sheet, on the third row in the file. So can we prove that? If I say message box go state here, so we think this should flash up once if we play the whole routine. As always, before we test, Control S, save the file. I'm going to hit the F5 key here, and it does say go state. It says go state more than once. Interesting. So this is one for us to step through, I think. If dot offset row counter 1 equals go. Let's check. Is it only 1? Yes. Wait and get ready. Wait and get ready. And get ready and go. Interesting. So I'm not sure why that's happening. So I'm going to step through the code here. Okay, so this is with the first sheet in the file. So I can see row counter is 2. Okay. Yes. This is my problem here. So previously, I introduced this adjustment to bring the row counter to the top of the data set to begin with. So we just need to say row counter -1 here, because rather than working through rows 2 and 3 in the file, rows 1 and 2 in the data set, we were working through rows 3 and 4 in the file, rows 2 and 3 in the data set. That's why we got the go message box flashing up 3 times. So once again, with that minor adjustment, let's go ahead, hit play, and we can see go state flashing up once. So that seems to make sense. Okay, I'm happy with that. But that for me is enough for a work session. As always, when we're programming VBA, trying to monitor stress levels, for me, that was a lot of cognitive load, integrating that conditional statement, integrating this calculation, but we have tested it. I feel confident in that, and we're moving towards completion of this task. We've got an additional conditional statement to input to do with the time period. If the time period isn't 10 seconds, we want to do something, and then we've got to flash up the message box. Then we've got to test the whole thing. I'll see you in the next section. So our aim in this section is to complete the task for Chris Cones and to do a full test so that we're fully confident and we can hand it over to a customer. And it's already used so many cool VBA techniques. We've got 2 loops, conditional statements, advanced position controls here. So let's build our confidence, get it to a state where we can hand it over to our customers. So we've integrated one conditional statement, which tells us we're on a go state row in the data file. But there's more to it than that, isn't there? We want to say if we're on a go state row and the go state didn't last for 10 seconds, we want to do something. So once again, benefiting from our annotations here, we can go ahead and create another conditional statement. And how to articulate this? Well, the results variable is storing the time period for this state. So we're benefiting from that useful place to store information. Yes, it's a variable. So if result does not equal 10, then because we know we managed to get that calculation clear and crisp and accurate, and it's a whole number calculation because we've rounded it. So if it doesn't equal 10, then that state hasn't lasted for 10 seconds. And we need to go ahead and tell the user about that. So end if. Okay. So how to test this? The integration of a fairly simple conditional statement there. And it's kind of moment of truth for us, isn't it? Because we don't really have an idea how many times this might have happened. We've had a quick look through the data. We've had a look at a few rows. But we also know that to build confidence with VBA, we want to do things 2 different ways. So we want to do it programmatically with VBA. That's what we're doing now in the VBA editor. So now's a good time to pause. Let's do this in a more manual way in the spreadsheet to help us build confidence. Now I've put filters on this data. So let's go ahead and filter by states. So let's bring all of the go data in there. And let's go ahead and reintegrate our calculations here. So end time minus start time. So this gives us the duration. Can you see the problem? Can you see my error there? So I put that calculation in with the filters on. So let's go ahead, do the calculation without the filters, and then double click. Take this, double click again. Take this calculation down. This is just going to be a nightmare, isn't it? Okay, let's clear this and let's start again. So equals end time minus start time. There we go. And we can double click. There we go. Okay, managed to get there in the end. Now this is duration. Now remember, we're not doing this for the customer. We're only doing this for our own testing purposes, doing one thing in 2 different ways. I can now go ahead, put the filters on, Alt-A-T on the Windows PC. I want to filter out the go rows. And now if I click here, I should be able to see what the results are. Now we're expecting 10 seconds because it should be 10 seconds, but the customer has told us there's instances where it isn't 10 seconds. So if I go ahead and tick those, it gives me a sense of how many times is this actually happening. So it seems to have happened 3 times in the 9 o'clock hour. Going to clear those filters. Going to do the same thing for the 10 o'clock hour now. Learning my lesson about not putting formally in into filtered data. We can say duration here. I'm going to do the same thing. Put the filters on. Alt-AT on the Windows PC. We're going to filter by go state. And then I'm just interested in this duration column. So what times do we have here? We can see we have 19 seconds cropping up again, but it's only one time this time. So gradually getting to know this data set, just building confidence really. I'm going to make sure I remove these filters, Alt-AT. And I'm getting a sense that these errors don't happen too often. Don't happen too often. 3 times in the first data set, once in the second data set. So what are the implications of that? Well, it means for testing, I feel quite confident stepping through this code or even just running this code because there's not going to be too many errors and I'm not going to get caught in that interminable loop. Okay, so if we say message box error here, that's not a VBA error message, of course, it's our own custom built error message. We'd expect that to flash up 3 times on the first sheet, once on the second sheet. And let's go ahead and complete this analysis for the third sheet too. Duration here on the column header. Alt-AT on the Windows PC. Filter by state. Then what results do we have here? Okay, so there don't appear to be any results, any errors rather, on the third sheet. Okay, it's interesting that. Always an interesting exercise doing something manually that you're doing programmatically in VBA because it reminds you just how useful VBA is because it took a lot of clicks there to get that output manually. We're going to get it programmatically now, hopefully, with VBA. So I'm just interested in, okay. Can you see the problem there? Okay, that was interesting. Right. I should have switched off this message box. There we go. This message box is switched off. Now, I forgot to do one thing, which is to reset this variable to last row. Why is it last row? The last row variable is storing the last row in each data set. That gives us dynamic quality. Now I'm looking around for any message boxes from testing, any previous testing detritus, can't find any. Control S, save the file. So I'm expecting this error message to flash up 4 times. 1, 2, 3, 4. That did seem to flash up 4 times. So minor punch the air moment there. But what can we do? We need to think about dynamic communication now because we don't just want to hand this over to Chris Cohn's and say, yeah, the job's done. It will flash up error for the number of times it finds an error in the data set. That's not really useful. We've got all this amazing code working. We need to put the icing on the cake. We need to communicate this to the customer. Otherwise, the customer's not going to feel any of the benefits of this fantastic VBA routine that we've produced. So what might be helpful? Firstly, we can flash up the sheet name. So how to do that? Sheet counter dot name. So sheet counter is how we're looping through the sheets, and dot name is the property of the sheet. So what's going to happen now? Control S, hit the F5 key. So why is it saying 9 o'clock? It's because there's an error on the 9 o'clock sheet. There's another error on the 9 o'clock sheet. A third error on the 9 o'clock sheet. There's an error on the 10 o'clock sheet. And there's no errors on the 11 o'clock sheet. So we can do more than that. We can say error found on sheet and then use the and sign here to connect together the text in the speech marks with the object here, the object and the property, which is the sheet name, of course. So what's going to happen here? Well, I love this. This is dynamic communication with the user because now when we play the routine, it says error found on sheet 9 o'clock, an error found on sheet 10 o'clock. So progressively here, step by step, it's getting more useful, but we need to know more than the sheet name, don't we? What else might be useful? How about the row? The row is going to be useful. So error found on sheet Now, if we say and sign and underscore, that gives us a new line in the VBA editor. And then if we now say on row, and then let's say row counter -1 is the syntax that we've developed to reference the row currently being looped through, and I forgot the and sign there. There we go. So let's hit play here. So a slight problem with how I've set up the syntax there, but row 83, row 327, row 407, row 243. So row 83 on the 9 o'clock sheet. Let's go ahead and test this, because if everything's worked, and this is a moment of truth moment, if everything has worked, row 83, which should have been row 84 perhaps, but we can tweak that. Yes, we can see it's a go state and it's 19 seconds. So our mechanism does appear to be working. Now, how can we improve this syntax? On sheets, on row. Yeah, we need to say and VB new line here. Okay, this should position the syntax nicely on the next line. Let's see. Error found on sheets 9 o'clock on row 83. Okay, 9 o'clock row 327, 9 o'clock row 407. So let's have a look at row 407 too. So I'm just doing more testing here as I go through building confidence. 407. We can see it should be 408. So I'm going to remove this -1 here. So for row 408 is a go state. And we can see, that says 20. So what's happened there? I wasn't expecting that. Let's go ahead and hit play. Row 84, row 328, sheet 9 o'clock, row 408. Okay. Let's have a look, because that didn't seem wrong to me. Yes, it's wrong. Of course it's wrong, because it's 20 seconds and it should be 10 seconds there. There we go. I thought the default value was 20 and not 10. So it does appear to be accurate. So are we happy with this message box as it's flashing up? Well, there's one more thing I'd like to do with this message box, and people often don't do this. I think they're missing a trick. It doesn't need to say Microsoft Excel in the title of the message box here. We can use that to give some more informative information, and I'm happy with the rest of this message box. Right. Let's go ahead. If we say (0), 0 is the type of message box and 0 is the default simple message box. And then we can say Chris Cones here. Why not use the customer company name for our message box? So error found on sheet 9 o'clock, row 84, row 328, row 408. I'm just going to go ahead and check row 244 on the 10 o'clock sheet to prove to myself that this is working. Gradually building confidence in this. 244 is a go state and it's not 10 seconds there. So it seems to have worked. So a quick reflection before we part ways today. Well done for sticking with this. And if you have managed to keep up, if you managed to work through, you managed to do your testing, you did your conceptualization, you've been experimenting as you go through, you've done a great job and your VBA skills are already pretty good. So congratulations. What would I want to do from here? Well, from the customer perspective, I'm saying, okay, so these message boxes are flashing up. What are you expecting me to do here? Are you expecting me to write down these as we go along? So to evolve this function, and by all means, go ahead and do this and let us know in the comments how you get on to evolve this routine further. I would want to perhaps take all those rows with errors, put them in a separate report, perhaps give the user the option to exit each time that message box flashes up. Could we say at the bottom, do you wish to continue searching, or would you like to exit here? So there's opportunities here for evolving this further. But overall, how much time would we have saved the customer here? An epic amount of time. An epic amount of time. Earlier in this section, we manually found the rows that were causing problems. How many mouse clicks did it take? And we're only working with 3 sheets here. We've noted already in this video, it would probably be 24 sheets in the real world. Can you imagine the time it would take to click through to do that? But the truth is, in the real world, people are doing that all the time. And if we go right back to the first video in this series, I told you about our $1 million project. Yes, we have a customer here. They invested $30,000 to $50,000 with us over a couple of years. We built a VBA application doing exactly this kind of thing. They then took the Excel file to a software company and got a quote from the software company to develop it into a full custom bespoke piece of software. They were quoted $1 million. So that's the potential impact of Excel VBA. That's the potential impact of your skills. And that, I think, is why it's worth learning Excel VBA. It's been an absolute pleasure bringing this video series to you. I hope to see you in another video.